Welcome back, team. So basically, we started our discussion from virtualization. Virtualization is the one exactly on top of the virtual machine where hypervisor is distributing the underlying hardware to the different machines. That is what the virtualization. And we have seen the problems with the virtualization as always, specifically if you go for the virtualization, it's heavily involved with the operating system. That is one of the drawback which we noticed. And also you cannot make sure the same versions of the applications in that particular Linux, Ubuntu or CentOS or Windows machines. Let me bring the diagram so that you will get a clarity. All right, team. So this is exactly the thing. So what are the missions you are seeing on top of the hypervisor and on that particular virtual missions? If you want to deploy Java specific applications, maybe you can use Java specific application Java 11 or Java 15 or Java 17 specific to only one version. You cannot have the multiple versions into that particular virtual machine, team. That is not possible. So to overcome these particular specific drawbacks, I think we are moving to the containerization, where the containerization, especially the container engine, example Docker is really helping you in to solve this particular issue. How exactly this is solving this issue? Where you are running containers on top of this particular virtual machine, what are the virtual machine is here, and each and every container will run independently. That's where exactly you can run this particular Java container with 8, another Java container with 11, another one with Java 15. That is absolutely possible. This is what exactly we started the containerization. Now, when it comes to the Kubernetes, the concept is same, where we will use the containers only for Kubernetes also. But what exactly the additional thing which you need to think about here is the pod, Kubernetes pod. That is the additional one. Now you should understand what is this particular pod and how exactly the pod exists, why we are renaming container to the pod. Okay, before going for that, let's understand about what exactly and how exactly and what are the benefits usually we will get out of the Kubernetes. We'll understand first these things. Okay, all right. And as part of this one, I just placed a first benefit as a service discovery and the load balancing. That's the thing exactly we started with. And especially when now we are discussing the service discovery and the load balancing, where I just placed master and the slave architecture. What are the master and slave is the one exactly I placed it in, right? This is where we are exactly. Now, let's deep dive into the case, team, okay? So generally, what exactly we understand about the container? The container in Kubernetes, the container will be deployed into these particular slaves. Now you should understand why I'm calling this one as a slave. This is nothing but a virtual machine, team. Okay, don't think like that's a different thing where I'm calling. Okay, this is none other than virtual machine only. You just come here, each and every slave, you can call this one as a worker node also. So that depends upon your interest. Okay, I'm just keeping the virtual machine. I'm just keeping the virtual machine. For instance, if you see this particular thing, you have in this particular Kubernetes cluster, master and slave cluster, you have 3 worker nodes. That's where exactly you are saying at the moment. And when it comes to the Kubernetes pod, why I'm calling this one as a pod, you should understand about that one, team. Okay, you know very well about the container so far. That is what exactly we understand. Okay, you know very well how exactly you need to bring a container out of an image. These things and all very clear for you. Now what exactly I'm just bringing now, team. So what are the container? Maybe I think I'll just take a simple image only. I don't see. Okay, I'm just taking this one as a container, for example. Let's take this as a container. So now in this container, what are the container you are seeing at the moment? Okay. So this particular container, same. For example, this particular container, whatever you have seen so far in the Docker project, the same container only. But this time you will deploy the container into Kubernetes slaves. So far where you deployed, team, so far you deployed into the app service, so far you just ran into the virtual machines, all these things you did. Similar to that, running a container in the virtual machine, running a pod in the virtual machine, both are same only. But there is a slight difference between this container and the pod terminology. And this is what exactly you are seeing container writing. This container is being covered with another layer. I'm just covering your container with another layer, Tim. This is what exactly I'm trying to keep, and I'll just put this one back. Okay, for example, at the moment, if you notice this one, okay, this is what the round circle is, the one exactly I'm calling as a pod, and that inside the pod I'm just placing a container. Point to be understand here is a pod can consisting of multiple containers. This is one container, team. Okay, this is one container which I just placed. Okay, which I just placed is one container, and you can have n number of containers, team. Okay, that doesn't mean that you should use the same application container. You can deploy another container also. That is also absolutely possible, team. For instance, okay, let me take another container here. I'm just taking another container. Especially I'm keeping another container inside your pod. I'm just giving that container with another color. Now the point you should understand here is the point what exactly we are trying to prove here. A pod can consisting of one or more containers. It's not one-to-one relationship. A pod can consisting of more than one container, team. So far you have the container concept only. From now onwards, we are just trying to keep more containers inside a single unit. That single unit we are calling as a pod. But as part of our best practice, it is always recommended to keep one-to-one relationship. One-to-one relationship means if there is only one pod, you will have only one container. You will not have more than one container inside a pod. This is the best practice. For example, I'm just separating these things for your better understanding. I'm just pasting this one this side also. I'm just pasting this one this side also. Now what exactly the thing I'm just highlighting here, this is the thing exactly I'm highlighting. This is always the best practice, team, to just keep one container inside one pod. This is always a best practice and also the proven theory. Okay, so we will also use the same technique. We will try to keep only one container inside the pod. There is a reason behind why we need to keep only one container inside a pod. Why don't we keep multiple containers so that everything will be go there in one place? No, so that I think you can think, okay, everything is sitting in one place, which can save us a lot of memory and the space and also schedules each and everything. You may think in this way, but that is not true. There is a big issue if you run multiple containers inside a pod. It's too early to understand the problem, but I'm just giving a problem at the moment. What exactly the problem you will get here, team? If you run two containers inside the same pod, the problem is if any one of the container dies, automatically your pod dies. It doesn't care about the another container is healthy or not. It doesn't care actually. If any one of the health is down, two containers you deploy. Let's consider this is Spring Boot application and this is React application. Just assume this is React application. Now what exactly I'm just saying, for example, if the front end is down or back end is down, doesn't matter, your pod will be out. So you should not make sure this kind of issue, you should not create these kind of issues if, for example, these two are independent containers. These two are independent. So if one is down, doesn't care actually for another one, but you are making another one also not work. That is the problem exactly here. That is why it is always recommended to keep a container inside a single pod. Single container inside a single pod. That is exactly the technique we will also follow. Okay, alright. Now you should understand little bit more on the pod point one more time. Okay, so especially when I'm talking about pod writing, you should get few things in your mind. Okay, let me just tell you what exactly the pod is bringing for you. So whatever the pod you're saying writing, always pod will be allocated with a specific IP address, team. Okay, let me write down the points here. So the points you should keep in your mind here is, first one, pod is the smallest unit in Kubernetes. Kubernetes. Okay, that is the smallest unit in the Kubernetes team. It's a combination of one or more containers. Okay, another point we are just writing. One or more containers. I'm just writing to you. So once this is done, to another point I want to highlight. Okay, for example, team, I'm telling you this is the best approach to keep only one container inside a pod. Okay, that is what exactly I'm telling. Okay, in this case it is always recommended for us to just make sure to have a very good high availability, right? How you can make sure the high availability, team, that is also very important. No, how you can make sure high availability? This is what your application only one container, but how you can make sure high availability? Very simple thing, team. You just copy this particular part, just duplicate this one. You know what exactly you did? Indirectly you are encouraging to have one more pod. If you do the same thing one more time, so for example, same thing one more time, this is one more pod. So point you should understand here is, team, so whatever the pod you are seeing at the moment, okay, these are all the pods. Exactly, these are all the pods which are helping you to just maintain the high availability. 3 Spring Boot containers are being placed inside 3 pods. 3 pods are helping you to maintain the high availability. To take a note on that, what exactly the point you need to write here? To have high availability, to have HA, okay, we always maintain the pod replicas. So point you should understand here is, team, so we are maintaining the pod replicas. Why we are maintaining the pod replicas? The reason for that one is you should be able to handle the public traffic. No, that is why always it is recommended to maintain the replicas. For instance, let's deep dive a point here, team. For example, 3 pods are there with you. Okay, 3 pods you deploy into the Kubernetes cluster. Now you may get doubt where these things will be deployed. These things will be deployed into these machines only. So ultimately you are going to deploy your pod into the virtual machines only. Underlying is the virtual machine only. That is what exactly you are going to deploy. Okay, and also another important fact here. Pod has its own unique IP address. Okay, pod has own unique IP address. Okay, IP address. Okay, that is another one. Okay, so meaning that, for example, team, today you have 3 pods which you placed here. That's really good. For example, whatever the pod which you are keeping here, right? For example, whatever the pod you're just keeping here, I'm just moving this place, and I'm doing one more. I'm just going there. I'm just keeping this one in the center, and there is the final one which I'm just bringing this one. And I'm just keeping this particular thing also here. Okay. Now, what exactly you should understand here is, team, we should understand a technique here. What are the pods you are planning to deploy? Each pod will be allocated with an IP address. For instance, I'm just taking an IP address 10.90.0.7, for example. Likewise, I think this one also will get an IP address or something 0.8, and this one also will get an IP address 0.9 or something like that. Now the point you should understand here is the learning point. What is the learning point exactly here? So each pod will have an IP address. That's where exactly this pod IP address will come from your Kubernetes cluster only. So ultimately you need to plan a subnet for the Kubernetes cluster. You need to plan for a subnet. That subnet will give an IP address for your pod. That's exactly the thing here, too. Right? That's awesome. And another interesting fact, by default, all pods can communicate each other. So meaning that, so by default, all pods all pods can communicate each other. Okay, so that's the point. All right. So this is what exactly you should understand about this particular case. Okay, right. So now what exactly the point you should think about? Okay, exactly the point you should think about here is next. Usually once you make a deployment to the Kubernetes team, what exactly usually you will think about? I'm telling you very clearly, whatever the pod you are just trying to deploy, these particular pods are maintaining replicas, meaning that to maintain high availability. Now what exactly I'm going to do? These are deployed into the virtual machine. I'm telling you very clearly. I'm just taking that virtual machine icon as something like this. This one I will call as a node. Okay, for your reference, I'm calling as a node. And I'm just pushing this one back, and let me take the same reference here also, and let me take the same reference here as well. Okay, so now what exactly the thing you are trying to prove here is, okay, 3 pods are being deployed into the virtual machines, 3 different virtual machines, and this IP is corresponding to your pod. Please understand, okay, this is not the node IP address, this is your pod IP address. Please understand him. Okay, this is your pod IP address. So far good. Now usually what usually you will think about, so whenever you deploy an application into any one of the, this is a VM only, this is VM only team, don't confuse with that, that's a virtual machine only. Let me place that particular diagram at the bottom so that you will get a very good idea. Okay, so I'm just placing this particular thing, I'm just placing this particular thing, just placing this particular thing. Okay, so this is nothing but a virtual machine only. You are deploying your particular part, whatever the part you have, right? I'm just keeping a part name here so that you will not be confused. So far good team. Okay, so far good. Okay, all right. So once your understanding is clear team, now usually what exactly you will think about immediately? Okay, once we have deployed all our parts into the virtual machines, usually your idea would be how to expose this application to the public. That is what ultimately you will think about always, right? But how to do that? To do that team, what we need to do, okay, that is what our next challenge thing. Usually any environment, this is the common practice. First we will make the deployment, but how we will give an access for the end user. This is the simple thing, right? Always we will think in this direction only. We have deployed our application successfully, and we are maintaining a very good number of replicas also. In 3 machines we are maintaining each one replica. So total 3 replicas you are maintaining, very good high availability. But the point here is you need to think about how to give the public access. How to give the access for the public. Now I'm highlighting one more point to you. This is pod got an IP address. This is a VM also will get an IP address. Now I'm just considering here, I'm just writing some IP address for this particular VM. Okay, I'm just writing some IP address is 10.90.11. In the same way, this VM also will get 10.90.12. I'm just giving an example team. Okay, this VM also will get 10.90.13. So meaning that each and every component whatever you are deploying into the Kubernetes cluster, why I'm calling this one as a cluster, these are the nodes. This particular connection, this particular collection is called as node pool. Another terminology which you should remember this one. Okay, node pool is nothing but a collection of virtual machine. Please understand him. Okay, node pool is nothing but a collection of virtual machine. So that is what exactly you're saying. Better let's maintain a different color, otherwise you will be confused with this particular color. With you may think that is there is a relation between container and this one, right? That's why I'm taking out team. All right, so far. Now once you're done with this thing team, now there is an interesting thing, how to provide an access for the end user. That is where exactly services are talking about. We need to talk about the services. What is service? Service nothing but your load balancers. For example team, I am the user. I'm just considering a user here. Okay, let me consider a user. Okay, I'm the user here. I want to access my application. That's what exactly we have seen in our in our app service for the Spring Boot application, how we access an API. In the similar way, I want to access API for this particular container which is sitting inside a pod, which is sitting inside a virtual machine. I need to go there. How you can go there? To go there, first you need to come to virtual machine. Then you need to go to pod. Then you need to communicate with the container. That is what exactly the sequence you should follow. But how? But which container? Which pod? Which virtual machine? Right? This is exactly the challenge, right? You cannot give, for example, let me give an idea for you. Okay, always you will be very happy to have an IP address, right? To have an IP address where you are very much comfortable to communicate with your application. If you recall our previous project with the Docker Spring Boot and the app service, Azure provided a very good domain name for you. By using the domain name, we played really well. We just launched our Spring Boot application. Everything is ready-made. But here, you need to do that. You need to think about it. You need to derive the solution. That is your call team here, okay? Alright, so what exactly we need to do? So how to expose these particular containers or pods to the external world? So that's exactly the problem statement which we need to deep dive. But at the moment, for the end user, it is not so easy to connect with your container by crossing virtual machine, by crossing the pod. Not so easy thing, okay? So we raise the problem statement here. We will come to this problem statement and the solutioning. And before going for this particular one, first we need to discuss about what are all the additional features we will get, okay? That's what exactly we will discuss now. Now, the first one which I placed here is the service discovery team. If you come to the service discovery, the same thing whatever I highlighted so far is about the service discovery and load balancing only. So what exactly the thing here is, team? For example, whenever Kubernetes is receiving the traffic, Kubernetes is receiving the traffic, nothing but your application is receiving the traffic in the Kubernetes. For example, when Kubernetes is receiving the traffic, meaning that there is a traffic for your application which is sitting inside the pod. Okay, traffic is coming. First and foremost thing, how you can expose this particular pods to the external world. How you can expose, that is what exactly service discovery. How exactly you are exposing your particular service to the external world. That is the first thing. And also second thing which is there, which is a load balancing, right? If you come across the load balancing, obviously I can just talk about one particular case here. I'm just taking one particular service called load balancer, which is a Azure load balancer for your better reference, so that you will get an idea also, okay? I'm just taking the Azure load balancer team at the moment. So whatever the load balancer you are saying, let's assume I place the load balancer here. I'm informing to the load balancer, hey load balancer, do one thing, okay? Can you please distribute the traffic to this particular part? What are the part you are saying, okay? Part and this part, and there is another one, right? Sorry, and this particular part, okay? This particular part. How a load balancer can route the traffic to this particular three parts? How load balancer can discover corresponding parts? How load balancers knows where the traffic should go to? Who will inform the load balancer? How the load balancer is aware of such things? That is what exactly the service discovery where load balancer will do it. Load balancer will discover where exactly the traffic needs to forward or traffic needs to redirect to. That is what exactly the service discovery. And the load balancer balance the load among these three parts. For example, if you get 100 requests, 33 will go here, 33 will go here, 33 will go here. In this way, the load balancer will maintain the traffic as well. That is what distributing the network traffic. And also that service discovery is how the load balancer is discovering the corresponding parts. There is a technique, team. There is a technique to discover the parts. To discover how a service is, I'm just typing here, how service is discovering discovering the respective parts. Okay, discovering the respective parts, how exactly it can identify. So there is a technique to do this one, that by using that technique only it can discover the corresponding parts and it can route the traffic. That's what exactly the advantage. So service discovery and load balancing is there in the Kubernetes. All right, the next important thing here is storage orchestration. Okay, storage orchestration. What is this particular storage orchestration? Why we need to discuss about this particular thing? You know one thing, team, so far you played one of your Kubernetes, one of your Springboard project where you connected to a external database, which is a MySQL database, right? You connected to that. But the advantage with the Kubernetes here is you always no need to connect. For example, if you want to connect to the Kubernetes, okay, if you want to connect to the database, how the connection I will give you. I'll give the connection now, okay. I'm just giving the MySQL. The same project, whatever the project you just discussed as part of your previous understanding. We are just continuing the architecture. This is not architecture, this is a flow diagram for you, so that you will get a very good understanding while I'm drawing the architecture, okay. For instance, I'm just keeping a database here, Okay, let me just reduce the zoom, reduce the size here, so that you can see everything very clearly. Now, what exactly the thing will happen, you know? So I'm telling you, this is a virtual machine. This is very much clear, right? This is very much clear for us. I'm just keeping these things on top. They're just saying that these are all the virtual machines. I'm just keeping this one. But when it comes to the pod team, the pod will come and directly connect with your database, because your application needs to connect with the database. No, your application needs to write the data to the database, right? Obviously, your application needs to participate in the database operations. So whatever the data it needs to write, it will write. But how it is doing, see this particular connections team, okay? Now, if you notice this diagram team, you are seeing very clearly your pod is able to write, pod is nothing but a container team, inside container only. So your pod, a container is able to write the data, whatever the data it is intend to, this particular data intend to, it is able to do that activity without any issue. Comfortable it is doing. But how it is doing? See, customer is coming, customer is hitting the load balancer, but then all exactly the thing will happen, your application will respond, customer fill the data, customer click on submit button, then the data will pass to this particular database. That's all. So meaning that where parts are mounted to the external volume, this is external database, I can call this one as. What exactly the point you should understand here is, not only MySQL, you can use disk, I'm just taking on Azure disk team, okay. This is what Azure disk, in place of MySQL server, you can use disk or you can use file. Even this is also absolutely possible, okay. You can use Azure files also, team. That is absolutely possible. That is what exactly they are telling here, okay. You can mount your data to the external volume such as disk or file comfortably without having any issue. Question to you, team. Why we are keeping data outside of your pod or outside of your container? What is the reason for that? Why don't we keep our data inside your Kubernetes cluster? Is there any reason for that? And why we are keeping outside? So the reason here is, team, generally whenever you have the containers are deployed, container volume is ephemeral. You know that already. Meaning that if container starts saving the data inside the Kubernetes cluster, maybe it may store somewhere inside the container path. What will happen if any of the issue, some memory issue or some pending issue or terminating issue, any reason, a pod goes for a termination, obviously you will lose your data. You will lose your data completely here, team. If you lose your data, so data is very important for your application, it will become a big issue for you. So since container volumes are ephemeral always, it's preferable to keep your data outside of the Kubernetes clusters. outside of the Kubernetes clusters team. That is the reason we will always prefer to keep outside of the Kubernetes cluster. Okay, that is the best way which you can think about always team. Okay, all right team. So far good. So you just connected with the database also, and also we understand what exactly the storage orchestration is exactly talking about. Storage orchestration is you can store your data to outside of your particular Kubernetes cluster. That's where even Kubernetes is supporting that. That's what exactly the point. Next important point is automatic rollouts and rollbacks. So what is this particular rollout and rollback? For example, team, today you are deploying an application inside your Kubernetes cluster. Okay, what are the application you are deploying, right? You are simply deploying over there, right? You are simply deploying. And for example, you want to override the particular deployment with a new version. For example, you deployed version 1. You want to override that one with version 2. Let's take an example. So what will happen? Obviously, you will override that one by making the deployment one more time, so that all 3 v1 parts will be gone, all 3 v2 parts will come, version 2 parts will come. Now, but what exactly I'm talking about? Even you can do this activity with the zero downtime deployment. There is no downtime required for these cases, to be frank. Okay, that is why one of the benefit by using Kubernetes cluster. You no need to maintain any downtime. It will automatically deploy whatever the things you are requesting for without having any downtime. For that, you need to have proper AML structure. What exactly the things you need to add? You need to add the readiness probe, you need to add the health probe. These things you need to add in the manifest file. Let's understand manifest file after some time, not right now. It's too early. Just wait for that. But for now, what exactly we need to understand here is, if you want to deploy v1 to v2, it's very easy to deploy. And also you want to come back v2 to v1, that is also very easy. To handle this case going forward, we will go for the Helm charts. That is the best case which you can use also. Okay, we can learn a little bit advanced with the Helm. Okay, going forward. All right, team. Another one which we are going for. Okay, so for instance, team, so what are the things we are just thinking about? Automatic bin packing. Okay, another important thing. Okay, what is this automatic bin packing? This one also you should understand. Yeah, bin packing. For example, team, yeah, automatic bin packing. So if you consider automatic bin packing, what exactly it is giving a benefit to you? Generally, whenever you are deploying your container, right, team, so usually what exactly you will do? You will simply deploy a container inside a pod. That's what exactly you did. But tell me one thing, if you are using 100 MB of space or 200 MB of space, you are wasting the remaining resources on this particular virtual machine, no? And also you don't know how much you are utilizing also. If you don't tell your container, hey container, please go there and use only 100 MB of memory. So what exactly container will go, and container will use like anything. It can go for 10 MB to 1000 MB also if you have a space. It can go like that, it can grow like that based upon your traffic. But you don't want to see such a situation. Then what you need to do? You need to set the proper target. Right? You need to set the proper target. Then obviously your container will behave properly. For example, you will tell to your container, hey, please go with only one CPU. You are just telling your container, hey, one CPU and only use some 1 GB of RAM. For example, this is what exactly you are telling to your pod. But we will call in terms of pod, team. Let's not talk about container anymore. Let's use the terminology to the pod. So you're just informing your pod saying that, okay, this is one CPU, one core CPU and 1 GB RAM is the one exactly you're recommending for your pod. So meaning that you're tightly planning on your virtual machine. Okay, if 1 CPU, 1 GB RAM it is being used, how much is left over and how many pods it can scale to. For example, your virtual machine is a 4 core. Let's consider your virtual machine is a 4 CPU and 4 GB RAM. Okay, 4 GB RAM. Then how many pods you can launch in this particular virtual machine, team? You can launch obviously 4 pods you can launch. Confidently you can launch 4 pods. That's what exactly I'm talking about. So you are tightly planning your resource limit, especially the CPU and memory. That is what exactly automatic bin packing. You will tell your Kubernetes cluster very clearly. You can scale up to 1 to 4. That is where exactly I also have the capacity. You will tell very clearly. That is what exactly we'll call as automatic bin packing. Okay. All right. The next important thing you need to understand about here is, so once the bin packing is over, next one is self-healing. Okay, you should understand this one also. What is the self-healing exactly is talking about? Generally, team, sometimes your container may go for the failed state also. There is a possibility. Usually we will make sure these are not getting failed, but in some cases we cannot really control. For example, if you don't test your performance testing or performance requirements, if you don't test properly, obviously when heavy load comes, automatically your pods or containers will consume too much memory, and your node will become node memory is completely occupied by your pods. Then automatically there is no space or there is no memory for your container to utilize further. Then automatically your container will throw OOM error. Okay, so that is what exactly you need to think about. Okay, so it is just feeling that, okay, completely the memory is completely out, there is no memory at all. So that in that particular case your container will go for a restart, but nothing will happen. Restart. But when your container is going for restart, again will start from zero, but the zero MB. But the problem is during the restart, if traffic is keep coming, generally I'm telling, if traffic is keep coming to your containers, what are the containers you have, if all the things are going down, automatically you will have some errors, client side errors. You will get some errors, 500 errors, because your service is not working. Your service is going for a restart. Why it is going for a restart? Because of too many requests, too much traffic. Why we are experiencing this one? Because you have not tested your performance requirements well. So this is one possible use case, team. Okay, possible use case. In some cases, you know few cases. For example, if you delete your container, automatically container will come up. That is what exactly the self-healing. If your container failed, or if you delete accidentally your container, automatically your containers will come up, team. That is what exactly the self-healing. So it will go for a restart and it will come back, team. That is what exactly you can experience in Kubernetes. And next important thing here, which is a secret and configuration management. Generally, secrets and config. Okay, secret and config. Generally in Kubernetes, you will keep all your secrets in a specific to one database. Kubernetes has its own database. That particular database is called as etcd server. You will understand that one when we are discussing about the architecture. Okay, at the moment you just remember this one. This is what the database exactly, where Kubernetes will store all secret information inside. Not only secrets, complete your node state, your pod state, each and everything will be stored inside this particular etcd server only. Everything will be uploaded. So even you can directly write this. For example, let's take this case. For database to connect, for example, your pod needs to connect with the database, right? To connect to the database, pod needs a secret. So far, you passed a secret in the app service, team. If you remember, you passed in the app service. Let's not pass through app service. This is Kubernetes world. You need to pass the secret to the etcd server. Hey etcd server, please remember my password. When our pod asking you, please pass that one. Automatically pod will get the password and pod will connect to the MySQL server. That is what exactly the use with the etcd server to store all your secrets and all. Alright, the next important thing, generally you can think about the batch execution. Okay, another one is the batch execution. That's what exactly the batch execution here is. For example, you want to migrate the data, especially from one database to another database. Let's consider you want to migrate the data from this, you want to migrate the data from this database to another database. You want to migrate it. So generally you want to do this particular activity on a scheduled basis. Let's understand. You want to do this on a scheduled basis. To do this on the scheduled basis, obviously what exactly the thing you will get. So you need to run a particular job. That is what in Kubernetes we'll call as a cron job. So what exactly the cron jobs will help you? Cron job will create a schedule. Okay, every day 12 o'clock you want to run this particular job. Okay, 12 a.m. 12 a.m. job will be created. Job will create a pod. Pod will do that particular data transaction. So whatever the transactions you are expecting, which we will call as a ETLs generally extraction, transformation, loading. But it's little bit early because we have a clear. So what are the things I'm discussing? We have a clear use cases for each and everything, team. Okay, I will prove each and everything with a proper use case which we will use in real time. This is on a high level. Okay, what Kubernetes can do. That's what exactly we are trying to understand. You cannot understand completely one class, so it will take time. But what exactly I'm highlighting here, in Kubernetes there is a feature called cron job. You will schedule cron as a 12 a.m. Then job will be created. Job will create a pod. Pod will do the activity. That's the thing exactly I'm highlighting to. So to copy one database to another database, which is a scheduled activity, if you have this requirement, example, if you have this requirement, you will use Kubernetes cron jobs. It will pull the data as a batch. It will pass the data to the destination on the schedule, exactly what of the schedule. But everything in Kubernetes, if you want to do something, pod will be launched. No doubt in that. Pod is the only one responsible to do each and everything. Behind can be job, behind can be cron job, doesn't matter. But ultimately, pod is the one to do that particular task. Alright, team. And also I covered one specific thing, if you recall, the horizontal pod auto scaling. Okay, horizontal auto scaling. What is the horizontal auto scaling? Is the one exactly will help you to scale your pod horizontally. What does that mean? For example, you have a pod here. If you want, that is what exactly I explained here. If you want to scale, this is what the scaling 1 to 4 pods came based upon the traffic. This is what horizontal auto scaling is, this one. So please understand this one also, right? And also there is another concept called cluster autoscaler. That one, this VMs, whatever the VMs you are seeing, those things will be increased. That is cluster autoscaler. But let's not talk about cluster autoscaler. I'm just highlighting what is horizontal autoscaler, which is an increase in the number of pods in your Kubernetes system. Is nothing but a pod autoscaler, horizontal pod autoscaler. All right, team. That is exactly the benefits which you can get if we move to the Kubernetes world, and we can implement our projects also going forward. Any questions so far? You guys are there?
Dinesh?
Yes, Praveen.
Dinesh, in self-healing concept actually. So if any interruption happens to the pod, so if it is goes die, automatically it will scale up the container, right? So in that once it is scale up, so till then what and all installations done in that container, it will be there, or if the empty container it will scale up?
No, everything will be there, Praveen. Everything will be there. Everything will be there. If it is a fresh one, which is of no use for us, right? Whatever the app is running inside, the same app will come again. Okay.
I have one more question.
Yes, please,
that is belongs to the last session. Shall I ask you?
One second. Let's take the questions from here, from this part. Can one VM contain more than one pod? Oh, hundreds of pod. Chandrakant, there you see. I just placed one pod for your reference. If you consider horizontal pod autoscaler, I just placed multiple pods, right, Chandrakant? So meaning that one VM can have multiple, absolutely possible. If VM has the capacity, please understand. If VM has the capacity, obviously that is absolutely possible. Clear, right? But anyway, that's really good, guys. You guys are getting very good questions, okay? Very good questions. I believe you might have some knowledge. That's okay. If you don't have also, Just understand this one, okay? Because we will go in depth in Kubernetes, okay? So you just need, don't miss any class. Don't miss any class. Try to attend each and every class. If you miss some class, refer the video without fail, okay? Without fail. Otherwise, you will not understand the next class. I'm damn sure about that, okay? Yes. Any other question?
Dinesh?
Oh, 1 second. Asha, go ahead, Asha.
Yeah. So you mentioned by default all the pods can communicate each other.
Correct.
So that are present in a single node or among the cluster.
Among the cluster, Asha. Okay, among the cluster. Not only single node team. Asha question is a very good question. What she is thinking about, for example, let's take this horizontal pod autoscaler only. Maybe one more pod got launched. These two pods can communicate each other because these two are sitting in the one VM. The concept is wrong. Okay, don't think like that. This pod can communicate with this one. This pod communicate with this one. The logic is, if you recall one logic team, subnet components communicate each other. Here is the same logic here also. I'm not stopping anything, but if you want to stop anything intentionally, Asha, that is absolutely possible. Okay, you don't want this particular part to talk with this, of course you need to set up the policy accordingly. Clear?
So we want to maintain a high availability. In that case, we provide that VM, that node with very high compute. So in that case, we can launch many more pods in that node. So why we need another node?
Very good question. Okay, so what Asha is asking team, why we need 3 virtual machines instead of maybe 4 CPU, 4 CPU, 4 CPU, total 12 CPU, launch one VM with 12 CPU, no? And also 8 GB, 8 GB, 8 GB RAM, total 24 GB RAM, 12 CPU and 24 GB RAM. A big virtual machine is the one exactly Asha is expecting. But if you do the team, I will tell the problem what you will get. If you launch this one, where you will launch the VM? You need to refer the concept. If you refer the concept of our Azure regions and zones, let's go there. Let's go there to Azure regions and zones. If you refer this concept, ultimately your VM is sitting here. Agree? Your VM is sitting here, Asha and team. In any instance, if data center is down, your cluster is out. You got it, Asha? If you think your zone is down, your cluster is out. But if you follow the technique what I mentioned, one VM will sit here, another VM I will make sure here, another VM I will make sure here, 3 VMs. If data center down, no problem, I have 2 more VMs. If zone down, no problem, I have 2 more VMs. If entire region down, then that is the case you need to think about backup. That is what exactly disaster recovery. I will give you the technique by using Veliro. Veliro is the backup solution for the Kubernetes, which is open source. We'll discuss that one at the end of these particular sessions. Okay, Kubernetes. That's a Veliro. That's a backup one. Okay. Your doubt is clear, right, Asha?
So in our architecture, the nodes are in different zones.
Yeah, obviously, though that is the reason I took 3 virtual machines actually. 3 virtual machines are representing 3 different zones team. Okay. Maybe I don't place the zone. That's the thing. Maybe the confusion got raised. But 3 VMs belongs to 3 different zones very clearly. I will tell the Kubernetes launch in 3 zones. Don't launch in 1 zone. Okay.
And you are passing that secrets into the database.
Yes. What are the secret we are creating? We will not pass those things via as a external variables like app service. Okay, we will not do that. From here on, we will move that one inside the Kubernetes cluster database only.
Okay. Then what is a etcd server here?
You will understand that one in the architecture, Asha. That is the database. For now, I can give information. That is the one of the database for the Kubernetes cluster, where it can store the information in the key value format, and that is the one exactly will help you to store your secret in the base 64 format, and no one can see your secret directly from outside. Okay.
It's an encrypted format.
Yes.
Okay, thank you so much.
No worries. Yeah. Any other question there? But someone is asking something earlier.
Yeah, yes, Dinesh. The auto healing is there, right? The pod is down automatically. The one new pod will create, right? And the IP address will revert create, or the old IP exists with the key?
IP will change. You have a very good question, Murli. IP will change. Guys, you will not get the same IP. IP will change. But the technique here is very good question. But load balancer will identify the new IP address. You got it? That is what service discovery. Load balancer has the capability. For example, if pod gone. So far my load balancer only thinks about 1090.0.7 is my pod, one of the pod. If your pod gone, then this time you come up with 1090.0.12. But again your load balancer still identify this is your pod. It can understand. How it can understand is the one exactly the service discovery. So it will follow some labeling technique. Based upon that it will identify. You got it, Morley?
Yeah, I got it.
That's good. Yeah. Yeah, IP definitely will change, team. Okay, no doubt in that. IP will change for sure. We will not depend upon any private IPs, team. Okay, we will not reserve anything. We will never do that. We will never do that. Usually, I will only do that activity when we are discussing about NGINX Ingress. When even application gateway ingress also I will not do. In NGINX Ingress, internal NGINX Ingress is the one exactly I will deal that. Okay. How to reserve a private IP I will show. You need to block it. You need to find the available one and you need to block it. Yeah. Anyone has any other question, team?
Yeah, Dinesh, I just pressed and start.
Vivek, yeah, tell me, Vivek, yeah. Sorry, Vivek, are you asking a question? Yes, please.
Posted in the chat box.
Sorry, I don't really. So sorry, you posted in the chat. Sorry, yeah. No worries. Okay, one pod is died due to out of memory or some other reason. How can we manage pending transaction or request? Okay, I believe very good question. This one. Pending transaction generally, Vivek, what will happen? Let me tell you. For example, if a pod dies, let me take a real-time case, team here. Okay, what exactly Vivek is telling here? A pod dies. If any transaction is passed by load balancer to this one, we are losing the transaction, right? How can we save the transaction again? Is it your question, Vivek?
Yes.
Okay.
Right.
So the point is, team, if the pod dies, your load balancer will not route the traffic to the pod based on few conditions. What are those conditions? Generally, your pod has few parameters. Those are readiness check and health check. Two things are there. If your pod is really ready, then only load balancer will pass the traffic. If your pod is really healthy, then only your particular load balancer will route the traffic. Otherwise, you will not get the traffic. You got it, Vivek? It's completely safe. But you need to use that one properly in the pod. If you don't use that, you will lose the transaction for sure. Okay?
Yeah, that's fine. But if the transaction already received to that particular part, then the pod gone due to some other reason, some out of memory and some other reason. Okay, that time how we can save the transaction or something?
Okay, see, okay.
Pending request.
Okay, I got you. So, okay, Vivek, I think your question is more into application developer question. Okay, let me tell this because this is not a DevOps guy to answer. Let me answer your question. Okay, for example, if your request been received by one of the pod, during the processing the request, if something happens to the pod, rare case. Okay, for example, if something happens, then what will happen? This one developer needs to think something happened. He needs to write the failed transaction to the database table. You got it, Vivek? He should be able to write if some failure happened, whenever some exception comes, he should be able to write the failure record to the database error queue table. Maybe he will have some table which is called error table. He will write to that. Later he will come and refer what are all the failure requests there. He will reprocess it by using Postman API. This is application developer answer. Okay, got it, Vivek?
Okay, fine.
Yeah. This is not our job, DevOps, not the DevOps job team. Others, no need to worry. Okay. All right, team. Thank you for the session. See you in the next part. Welcome back, team. So now we'll go and deep dive into the Kubernetes services team. Okay. So we should understand how exactly the Kubernetes services works and what exactly the technique usually will be available here. And is it easy to handle the services or very complicated? Those things and all we'll see now. First and foremost thing, I'm just going for the similar diagram, whatever we have seen yesterday, the same diagram. Especially, I'm just considering the nodes. These are the virtual machines team. I'm just considering this is a virtual machine. I'm just considering another virtual machine or something like that. On top of it, another virtual machine. So why we are taking 3 virtual machines? The reason for that one is you want to deploy your virtual machines with the high availability. That is the reason usually you will take 3 virtual machines in your architecture. Always it's recommended to keep the high availability with 3 virtual machines. And as you know already that I'm just taking the virtual machine. The VM, each VM is dedicated to individual zone team. For example, this VM belongs to one zone, and I'm just writing some value here so that you will get an understanding as well. I'm just writing here zone 1 or something like that. Okay, zone 1 or some similar to that. I'm just copying this one. I'm just pasting over there, and this is zone 2 and this is zone 3. Okay, all right. So this is what exactly the point you should just think about. Okay. So 3 zones are there, 3 virtual machines exactly being deployed. Okay, these are the worker nodes exactly we are talking about. Okay, so far good. So once your application being deployed into the Kubernetes cluster team, so once your application is deployed, so meaning that let me just draw something for that. For example, this is exactly the basic thing which you need to keep in your mind. Now, for example, an application is deployed. What is an application deployed means? It's nothing but a pod got deployed. Just understand, pod got deployed. Okay, this is one of the pod which I'm just considering. A pod got deployed into the virtual machine. Let me consider the pod with some color so that I think we can align on the same. For example, this is the pod. Exactly, I'm just pasting. Sorry, I'm just keeping inside the pod as it's a Java application. I just kept it's a Java, and whatever the Java is there, just Control C, Control V. Okay, so another pod got launched, and just drag that particular pod here, and one more time. Okay, just do the same thing and just drag this one to the third node also. All right. So you have deployed your pods into the nodes team. That's what exactly this particular diagram is representing. Now the challenge for you is, okay, here is the user exactly, right? Here is the user. How you can make sure always user is accessing your application. That is exactly the challenge thing always will think about. What exactly the technique usually you will use, especially when user wants to connect with you. User wants to connect with your application. How you can facilitate your deployment to expose to the public, to expose to the end user. So how we can sort out this particular case team. Okay. So Kubernetes is supporting few services by default. Okay, let's understand about those services. Those services are, one is cluster IP, another one is node port, another one is load balancer. So these are the three services where Kubernetes is offering you to just have a particular, all these 3 services are kind of load balancers only. All these 3 are kind of load balancers only. So for example, why 3 services? What is the importance of each and every service? That's what exactly we'll see now. So to know one by one team, the first and foremost thing, generally, if you recall, one of the feature of the Kubernetes is service discovery. See, yesterday also I just mentioned, service discovery is the one where the services are able to auto capture where exactly we need to route the traffic. For example, what exactly I'm talking about here is, I'm just taking one particular box here. Okay, let me call this particular thing as a service. Okay, I'm just calling this one as a service, I'm representing a service like this, but ultimately service also one of the part which will be deployed into your Kubernetes only. That is also, but I'm representing something like this, and this is a service. Now the point what exactly I'm trying to highlight here is, for example, whenever you're deploying any service into the Kubernetes cluster, see, first you deployed the pod, this is a pod, and next you are trying to deploy a service. So whenever you are deploying any service, always you need to inform to the service, hey service, please go there and capture or discover these are all the pods with the label so and so. For example, each label, whatever the label you are seeing, right? I'm just giving some pod label as middleware. Example, middleware. You know what does it mean, team? So whatever the label I just prepared here, I'm just bringing that one here. This is the pod label. Just assume this is the pod label. Now, if you could prepare your pod label something like this, what exactly the meaning for this one is? Now, service, you will inform to the service also. Hey service, wherever you see label equal to middleware, please route the traffic only to those ports. That is what exactly you will highlight. That is what exactly a service discovery. So meaning that your service can easily discover where exactly we need to route the traffic. For example, if you could tell very clearly to the service, the label middleware is your target, then obviously it will be considered this pod as the targets, because these three labels are the replicas. Each label has the same label only. Each pod has the same label. No doubt in that. So this is what exactly the point I'm trying to highlight. So if you have three labels with the same label, obviously that is a very good call for the service to just route the traffic to this particular pod stream. That's all exactly the point I'm trying to highlight. For example, I'm just keeping this one also here, and you can think about this connection, something like this, okay? Something like this, just a moment. Okay, so something like this. So this is the one of the connection which you can think about, okay? Just a moment. Yeah. So this is exactly the service discovery which you can think about, okay? All right, perfectly all right. Okay, good. So your service is able to discover where the traffic needs to be routed. That's clear, but this is a service which you kept inside a pod, inside a node. No, it is sitting inside a node team. It is sitting inside a node. That's what exactly you are saying. Maybe for your better understanding, I'm just keeping this one into any one of this particular node. That's fine. So already I told you one thing: a service to pod, a pod to pod, all this communication comfortably can happen. So no problem on that. But the point is, when you see this particular service, whatever the service you just deployed, the service is an internal. Clearly, it's an internal. It is not going outside. It's clearly internal. The problem exactly here is I cannot provide an access for the end user. I cannot, because this guy is sitting outside now. This guy is sitting outside and your service is inside. A service is sitting inside a virtual machine. Right? So this is completely internal. It's internal, where I cannot provide an access for an end user. So what should we do? There, we will think about few other techniques coming days, especially on the ingress controllers. Okay, ingress controllers, such as NGINX, HAProxy, so, and also AGIC, Application Gateway Ingress Controller, AGIC. So these are all the different types of ingress controllers which are available, which you can use. So NGINX HAProxy for free. These two are the open source, NGINX HAProxy, but AGIC is not free. AGIC usually will come, it's a Azure native. Azure native means it's an Azure dependent component. So AGIC is a Azure native, but NGINX HAProxy is the one, exactly the open source one. So we'll explore these things, except I will not deal HAProxy. I'll teach you NGINX architecture project. I will teach you AGIC. Those two are more than enough. Okay. HAProxy usage number of users or the usage market is not so good, but NGINX is too high when compared with AGIC. Okay, NGINX is too high. All right. Now, what we need to think about here. So you need to bring any of the ingress controller here. If you bring any one of the ingress controller, this ingress controller can definitely talk with your internal part and the external user can comfortably come and talk with this ingress controller, and ingress controller can talk with your service, and your service can talk with the pod. That is what exactly your architecture for the coming days. But at the moment, I'm not touching any kind of these kind of ingress controllers. I just gave the names, that's all. But the point what we noticed exactly, if your service is a cluster IP, I'm just taking a cluster IP now. But this behavior is not for all the services team, especially what are the things I'm discussing. So the cluster IP is the one. The name itself is very clearly telling. Cluster IP means it's only limited to the cluster. Only limited to the cluster. It will not go beyond to the cluster. Meaning that by using cluster IP, you can communicate with the pod, a pod communicate with the cluster IP communicate with any other services, but a cluster IP cannot communicate to the outside, and outsider also cannot communicate with the cluster IP. That's the problem exactly with the cluster IP. That is why, but I'm just telling it's a problem, but the point here is this is of best use case when you bring your ingress controllers. When you have NGINX Ingress controllers, this is the one of the best use case which you can use. This is absolutely fine. But when you have the ingress controllers, then only we will make sure this is absolutely good. But for now, the cluster IP is not so good to just expose your services to the public. It's not good. You cannot make use. That's impossible. That's impossible. Okay. Let's take the another service now. Okay, I'm just considering one more service. What are the service you are seeing at the moment? I'm just considering one more thing. So that particular service, what exactly I'm just going to keep here. And instead of the cluster IP, I'm just keeping the node port. Sorry. Just a second. Yeah. Instead of cluster IP, I'm trying to keep a node port in. So what is the node port now? So now you need to understand what is a node port also, right? So that is also another important thing. Okay. So when you're thinking about the node port team, so what are the node port you're just talking about? Especially the name itself is clearly telling it's a node corresponding to the port. Node corresponding to the port. So meaning that node means a virtual machine, and port means a port on the virtual machine. A port on the virtual machine. Now the point here is, if you use the node port, okay, let me just draw another diagram for that, so that I think you get a very good clarity. And first, let me keep all these things in one color, so that I think your understanding would be nice. I'm just keeping that one in the red color. That's fine. Just leave that. Okay. I'm just taking one more team. Okay. I'm just making this is little bigger, and this one also little bigger, and this one also same. Okay. All right. So now I'm just going there. I'm just picking one more. Especially, what are the things are there? So far good. I'm just keeping another service called, which is a node port. So for example, when the discussion comes to the node port team, I'm just considering the node port. So I'm just keeping node port bit outside also. I'm just keeping node port bit outside, and you also need to think about the case. Okay. I'm just keep for the node port service. I'm just keeping especially what are the node port you have. For example, I'm just giving this one as a node port. So why I'm keeping this one outside? The reason is node is a virtual machine and corresponding to the port. You are clearly telling here. So there is a node, and you need to give a port for that. That port is exactly the entry point for the end user. That's what exactly you're telling here. For example, when you launch any service with a node port, so what will happen especially? So generally, when you are using node port, since you have 3 virtual machines, obviously you will be end up with 3 nodes, especially something like that. So 3 services, especially your service will be something like this. It looks like this. It looks like exactly in this particular format, meaning that this VM has an IP address. Agree? So you have an IP address. I'm just taking the public IP of this particular VM, 30.140.20.15, for example, and colon, I think it goes on some port number 32,000 or something. Okay. In the same way, you can also use the same port, whatever the port you are just thinking about. And you can also use the same port specially here, and you can also give this particular thing as a 32,000, sorry, this particular IP as a 16. And there is one more. I'm just taking one more IP address, especially I'm just keeping this particular thing here. Okay, I'm just keeping this particular thing as a 17. So what exactly you guys understand here? Especially when it comes to the node port service, it is considering node IP as the source of truth. Node IP. So node IP means 13.140.25, 13.140.2016, 13.140.2017. You tell me one thing, team. Are you really interested to give 3 IP addresses for your end user? Hey, please use this IP 15 or 16 or 17. Do you see such kind of cases generally? No. We never see such kind of cases. Maybe you may think, okay, instead of giving the IP address and the port, you will give the domain. Okay, when you go for the domain also, always domain needs to be resolved to either any one of this IP, right? Multiple IPs you cannot give with the same name. So there is a 15 or 16 or 17. Any one of the one domain or one particular IP only you can make use. But you're not actually balancing the load here. See, if you use specially this one, what exactly the thing? So you're just dedicatedly coming to this particular node. But obviously when the traffic is reaching this particular node, and corresponding pod will receive the traffic. And also you need to think about one thing. When this particular load balancer is something like 3140, 2050 and 32,000 something, there is 3 endpoints exactly you are saying. 3 endpoints. Why? Because 3 nodes are there. If you have only one virtual machine, obviously only one endpoint. Obviously, if you're running with multiple replicas also, your node port will balance the traffic among all the parts. Absolutely fine. It will do that. But the problem with this one, what exactly you are saying, multiple IP addresses, which is really not good to handle the traffic from the public side. So end user side, it is not really recommendable. Now I'm just going for one more, which is the load balancer. So when it comes to the load balancer team, this is exactly the one of the best use case which you can make use the load balancer. For example, whenever you are launching any service with the load balancer type, for example. So for example, let's take a scenario. Okay, let's take a scenario. And whatever the diagram you are seeing at the moment, okay, I'm just taking the node port from here, team. Okay, just to avoid the confusion, I'm just keeping on this particular thing only. Now I will take one more scenario. I'm just taking one more. That particular thing is a load balancer. So the advantage with the load balancer service is this load balancer has a capability, especially either to be as an internal or to be as an external. It can do 2 things, team. Either internal load balancer or external load balancer. So it can act as a 2 things. Okay, I'm just keeping here internal or external load balancer. So what exactly the point I'm trying to highlight here? So the load balancer can route the traffic by sitting as an internal load balancer, like exactly cluster IP. Or you can keep your load balancer outside, and you can tell the end user, hey end user, please go there and hit my load balancer. That's absolutely fine. That is what exactly you can make use by using load balancers. So for example, what exactly the point I'm trying to highlight? So load balancer, I'm just keeping the traffic, okay, corresponding to this particular arrow. I'm just giving the arrow to make the diagram very clear. And also this particular thing also, I'm just giving the connection. Okay, I'm just giving the connection team, and this is also fine. And there is one more, which is an entry specific to your pod, which is sitting exactly there. Okay, this is what the another one. Okay, so now the point you should understand here is team. So what exactly the point you should understand here is, so far good. So you understand something really good. So where you are able to route the traffic by using load balancer to the 3 pods comfortably, but it is an external load balancer. That is also good. But you need to give an endpoint for the public, right? What endpoint you will give? Generally, you will be exposed definitely http colon / okay. I'm just writing an IP address 13.120.40.60 colon 8080. This is what your endpoint looks like. This is what exactly it looks like. See, always there will be a port number. Always there will be a port number. And this is what exactly your endpoint. Right? This is what exactly your endpoint. And also another interesting fact which you need to keep in your mind. Whatever the load balancer you just established by using this particular type as a load balancer, this particular load balancer you can make use in your real-time applications also, maybe for the lower environments. That's absolutely fine. You can make use in the lower environments, no doubt in that. That's fine. But for the production equivalent applications, again, I'm not recommending to use such kind of service in your production infrastructure. Not really recommended. So These are all the 3 services exactly are there with you in the Kubernetes by default. You can make use. But ultimate connection when it comes to your real-time architectures. Generally, your connection will go from here. Okay, Ingress controllers will be in the picture, and followed by you will keep the cluster IP. Generally, this is what your production level configuration will be. Cluster IP, or you can use internal load balancer also. But my recommendation is use cluster IP. See, cluster IP is the one is very much secure and very much safe also, because the cluster IP means only for the cluster component. Outsider cannot interact. The cluster IP cannot communicate with outside also. So that's exactly the advantage. And also, and followed by generally the cluster IP and followed by the pods will be there. Obviously, the pods, what are the pods you are seeing? What are the pods? And all these pods will be there as usual. So this is what exactly your real-time connection to. This is how exactly your real-time connection usually we will give. Okay, when it comes to the projects, usually you will give the connection something like this. And also another interesting part you need to understand. Ingress also, it will not be connected like this. I'm just doing another add-on here thing. So whatever the thing you are saying at the moment, and on top of it I will take another one called application. On top of it I will consider one more called APGW, application gateway. Application gateway is connecting to your Ingress. So application gateway is connecting to the Ingress. Application gateway is connecting to the Ingress. Ingress means it's a load balancer, and your load balancer is connecting to your service, and your service is connecting to your pod. So this is what exactly you need to practice for your real-time infrastructure. Okay, this is the connection exactly you need to take care. So I'm just bringing this one. That's it. Okay. So ultimately, at the end of the Kubernetes, whether you are fulfilled with this architecture or not is the matter. Okay, if you don't understand this flow, this particular architecture, maybe after I think we'll touch this one maybe some 2-3 classes after. By end of the Kubernetes, if you don't understand this particular flow, you cannot handle the Kubernetes in real time. That is impossible. Okay, you cannot handle. So this particular flow is very important. Keep this particular flow diagram in your mind. Thank you for the session. See you in the next part. Welcome back, team. Okay, welcome back, team. Let's move on a bit. Okay, now I'm going to introduce specifically one thing for you, team. For example, let's assume you have an application in real time. Okay, you have an application where you want to deploy this application into the Kubernetes cluster. So that is what exactly usually your goal in real time. That would be your goal exactly. How to handle this case? How exactly we can handle this one? So what are the ways are there to do this activity? Generally, just let's consider this is a standalone application initially. To make it as a Dockerized application, what you guys did, can you please recall? You did only one activity. What is that? You added a Docker file. You simply added a Docker file to this application, and your application being converted to a Dockerized application. Now your manager is asking, convert this Dockerized application to the Kubernetes one. That's what exactly is asking. Then what you need to add extra? What you need to add? Along with the Docker file, you need to add some manifest files as well. Okay, manifest files. We'll call those things as manifest files. Those files really will helpful for you to deploy your application as a pod into your Kubernetes cluster. So that is exactly the differentiating on a repo level. Okay, manifest files will be added extra. That's exactly the thing. Okay. So when it comes to the deployment point of view or the provisioning point of view of the Kubernetes, when we consider that one, we just come here to generally. So what exactly we will think about when we are provisioning about the Kubernetes here is, first we will make sure a subnet is ready for the Kubernetes or not. That's the thing first you will make sure. So before going further, I want to highlight one more thing. Let's consider a virtual network scenario. Okay, or virtual network scenario. For example, I'm just considering another box. Okay, I'm just keeping the Kubernetes cluster. Let's assume this is your virtual network. Okay, VNet. See, this particular VNet, generally, you will get the VNet address space from your regional infra, generally. So whatever the address space, meaning that whatever the side are generally, for example, 10.90.6.0/22, such kind of IP addresses, generally you will get from your regional infra. So that's exactly the thing usually you need to depend upon. There is a strong reason behind why you need to depend on them. The reason is, in your company, you are not only the one person handling the project. Your company has multiple projects. All projects may be there inside the same subscription in Azure. Then, obviously, when it comes to the different projects, it's always a very good practice to just maintain the different address spaces. If you maintain the same address space also, your application will definitely work. No doubt in that. No doubt. Your application definitely will work because it's an internal IP. Definitely it will work. But the problem is, if you want to consume their API after some point of time from other application in your company, then the pairing is very difficult. VNet pairing cannot be found. It's a difficult scenario. Definitely difficult scenario will be raised. That is why it is always recommended to maintain different side or different address space for the different applications. So that's the first thing which you need to keep in your mind. And second thing, once you get an address space, what you need to think about? You need to think about what are all the components are there in your architecture. Generally, in my architecture, okay, your manager already asked you need to deploy your application to the Kubernetes. Obviously, Kubernetes is one component which I need to make use this time, and also Azure database. Maybe I'm just picking up one database. Whatever the databases are there, I'm just bringing one database. Okay, that is one thing. And also I'm just bringing these things in. And also I may need some key vault. What is the advantage of key vaulting? The key vault advantage here is which helps us to just store secrets inside the key vault. So this is the one of the technique you can use in real time also. Okay, maybe your project is really demanding event hub. Event hub is a message queuing system. Okay, message queuing system. I'm just keeping one event hub. This is one of the another component which you can think about. Your project is still demanding some API management, which is helping us to just host APIs. APM, Azure APM, just a moment, Azure API management. Yeah, Azure API management, alright. So Azure API management, and also your project is really thinking about application gateway, Azure application gateway. I'm just bringing up another component, Azure application gateway. Your project is still looking at one other component. I'm just bringing one more, which is a friend door. I'm just bringing one more component called friend door. Okay, friend door. You can consider the friend door or something like this. See, these are all the components involved. Just let's take an example. If all these components are part of your architecture, for example, so you need to think about your virtual network and subnet division. So how exactly we need to think about these things? That is very important. First and foremost thing, it's a very clear-cut point here is for Kubernetes cluster, we need a subnet. We need to divide this particular VNet into subnet. Okay. For at the moment, I'm just dividing this one into whatever 22 refers to 1024 IP addresses, right? 22 refers to how to know number of IP addresses are available. So there is a subnet mask which you are seeing as 22. A total number of bits, total number of bits available for IPv4 address. I'm just keeping here 32. Generally, when you'll be provided with this particular address space from regional infra, First thing what you need to do here is there /22. /22 means out of 32 bits, you can see 10.90.6.0 out of 32 bits, 22 bits are reserved. 22 bits are reserved. That is exactly the meaning for this. You may get doubt where exactly these 32 bits are. So each section is representing one octet. Octet means 8 bits. So I'm just typing here. I'm just typing below to that 8 bits dot 8 bits dot 8 bits dot 8 bits. Okay, so something like that. So what exactly the meaning for this one? Totally I'm /22 I'm just providing. So meaning that a total of 32 bits is the one exactly you are seeing at the moment on the screen. So this is actually a actual value which you can represent in the bit format also. You need to recall your childhood studies. If you go there for the binary formatting, generally if 8 bits I'm just telling here, right? Let me write down the 8 bits here. So for example, what is the first value? 2 to the power of 0. Generally, right? 2 to the power of 0, and I'm just going before to that, and 2 to the power of 1, 2 to the power of 1. I'm just going one more, and I'm just going 2 to the power of 2, and I'm just going one more, 2 to the power of 3. I'm just going one more, 2 to the power of 4. Just going one more, 2 to the power of 5. Okay, I'm just going one more, 2 to the power of 6. One more, 2 to the power of 7. Okay. For example, team, just think about this case. Okay, you represented 8 bits here. 8 bits here. For example, what is 2 to the power of 0 means? 2 to the power of 0 means it's a 1. The value is 1. And space 2 to the power of 1 means 2. 2 to the power of 3 means the value is 8. Sorry, 2 to the power of 2 is value is 4. 2 to the power of 8 means 2 to the power of 3 means 18. Okay, and next one 2 to the power of 4 means 16. And next one 2 to the power of 5 means 32. 2 to the power of 6 means 64. 2 to the power of 7 means 128. See team, I just place the actual values corresponding to these binaries. Okay. For example, team, if someone tell you to represent this particular IP address exactly in this binary form, exactly in this particular format, on the binary format, let's do that now. For example, if I ask you represent, so whatever you're saying at the screen, okay, represent 10.90.6.0/22 in the binary format. How to do that, team? Very easy. 10 means this 4th position and the 2nd position must be enabled, and remaining all are zeros. That is 8 plus 2 is 10, right? That's exactly the thing. 0, 0, 0, 0, 0, 1, 0, 1, 0. This is what exactly the value 10. Dot. I'm just going for the value 90. How you can represent the value 90, team? You just tell me what are all the positions exactly you need to switch on. You can understand easily. Team. Come on. So what exactly the number, what exactly the binary number I can type here to represent the 90? Just try. Just try and type in the chat box from anyone. Just try, no worries, nothing will happen, just try. So Yogesh already passed, okay, I'm just taking the Yogesh answer as it is here. You guys can notice that, I'm just pasting his answer here, you can sense it, okay. You just double check team, whatever he posted. So 0, 1 represents 64, plus, followed by 16, plus 8, plus 2. That is what exactly he came up, right? And also Mallikarjun also posted, yes, alright, yes. So that is a presentation. That's really good, very good attempt. And also to represent the 6, Can anyone type? That's very easy, right? Just type. You just need to type the 8 bits only, that's all. 8 bits where exactly we need to enable. Okay, so fine, that's good. Okay, so I saw the answers already, that's good. So that's really good, team. So I'm just presenting here. So corresponding to the 6 means 4 plus 2, simple, right? 0 0 0 0 0 1 1 0, and finally last one is 0 only, 0 0 0 0 0 0. Okay, so this is exactly the binary representation of your IP address, whatever you got from regional infra. What they're telling, /22 means total 22 bits. What are the bits you are seeing, right? These are called 22 bits, first 22. These 22 bits, what exactly they are telling here is, don't use those 22 bits. Don't play with those 22. Just play with the remaining bits only. Remaining, how many bits are there? 10 bits are remaining. 8 plus 2. Total 10 bits are remaining. Okay. Number of, I'm just typing, number of bits available in the address space. How many bits? 10 bits are available. You know another question you want me to ask? Number of IP address I can form. Number of IP address I can form. For example, if the 10 bits are there, how many IP address actually available? Okay, I'm just asking a question. Number of IP address available for the host. I can say it's a host, that's exactly the right word. So number of IP address available for the host equal to 2 to the power of 10, which is 1024. So this is exactly your calculation. So meaning that you have 10 bits available for you to play, but first 22 is reserved for the network, but 10 bits are only for the host, where we can deploy all our applications even in real time. When you go for a company where you are getting a VPN network, you will be allocated out of this 1024, and the left side one, which is a reserved for the network. That's where exactly when you are connecting to the VPN, your IP address, you can get an IP address where you can sense it some private IP which you can see. That IP address is coming from this particular side only, particular host side only, the 10 bits only, from the 10 bits only. That's where reserved for you, where you will get that particular IP. But the point you need to understand, what we need to, why we are discussing these things and all, actually not required for you. Why we are discussing these things? The reason is, whatever the CIDR regional infra is giving, whatever the address-based regional infra is giving, how many IP addresses are actually available? Maybe you might have asked, okay, I need some 2000 IP addresses. So casually you ask. But when they give this particular CIDR with address space with you, you should understand whether it is really 2000 or not. You should know how to know. This is the technique, this is the calculation you should follow. Now easily I can understand, yes, I have the 2000 IP addresses or 1000 IP addresses by using this 2 to the power of host bits. 2 to the power of host bits calculation. 2 to the power of host bits is nothing but a number of IP addresses which you can play. Now I am giving one problem for you. Okay, I have 1024 IP addresses with me. For example, when I'm provisioning, so out of all these components, the main component which can host the application is the Kubernetes. Rest all the components have a specific importance, but your application always will sit inside the Kubernetes. That's very clear. Each and all other component has its individual importance, but not a deployment hostable components. Okay, only Kubernetes was the only thing can handle that. Okay, so you need to plan a proper subnet for your Kubernetes. When you are planning for a Kubernetes, now I'm just keeping here 10 dot, for example, 90.6.0/22 is the one exactly the CIDR you got. For example, if you have something like this, but you want to reserve some half of your address space, maybe 512. You want to reserve 512 for your Kubernetes cluster, then easily you will keep 23. You know what is 23 means? How many bits are left over, team? If you keep 23, 32 minus 23. Again, 32 minus 23. How many? You can sense it, right? 2 to the power of 9. Again, it is just coming under 512. So meaning that you are reserving 512 IP addresses for Kubernetes. Now my question here is, I want to launch 3 nodes. Okay. I'm just keeping 3 nodes here. This is node number 1. Okay, node number 1. And another node I'm just considering node number 2. Another node I'm just considering, okay, node number 3 or something like that. Okay. Yeah, or something, sorry. Okay, I'm just keeping another one. Okay. So now the point what you should understand here, team. So when you are thinking about, you are allocating 512 IP addresses. What does it mean? So you know very well each node will have pods. You know that already, pods. So when you are provisioning your Kubernetes cluster, you will tell very clearly, in my Kubernetes cluster, I want to have some 100 pods, max 100 pods. I want to keep only 100 pods. This is your wish. And there is a limit also, which you can see when you are provisioning the Kubernetes cluster. So meaning that you want to keep only 100 pods inside the node 1, for example, node 1. So this configuration is a common. You cannot control from node to node, which is a common thing only. Even here also 100, here also 100. Total how many pods? Exactly 300 pods you planned. Example 300 pods you planned. I told one technique, each pod requires one IP address. Agree? Each pod requires one IP address. I told this point already. So 300 pods will take 300 IP addresses. Just come here, Tim. Okay. I'm just writing the scenario. 512 addresses are available with you. Okay, very important one, Tim, this one. So 3 nodes are with you. And I'm telling 3 nodes are consuming 3 into 100 pods. That's exactly the thing I'm telling. So meaning that it says 300 pods. You got it right. 300 pods total. So 300 pods is nothing but 300 IP addresses. Now how many IP addresses are left over, team? Can someone please type? How many IP addresses are left over? Anyone can say. How many will left over? 112. Sorry, 212, right? 212, right? So 512 minus 300, no? So I'm just bringing that particular thing. Total leftover IP addresses. So 512 minus 300. Maybe you can take easily some 212. Now I'm asking a question. How many nodes I can scale up to? What is this one? What is node scale up? For example, team, in real time, when you are deploying your applications and your applications are demanding more and more resources, if your node don't have the capacity, then one more node will be launched. One more node will be launched. That is what cluster autoscaler. Meaning that your number of nodes will be scaled up based upon your load, based upon your pod consumptions. So, and if you want to try to launch one more node, which is the 6th one, so already 3 are there, 4, 5, 6, 6th one. Now, how many IP addresses you have, team? 212. So, it can hardly support only 2 nodes. So, 2 nodes again 2 nodes to another node. So, 3 nodes are already there, plus 2 additional nodes. Right, 2 additional nodes. What are the thing, team? Okay, 2 additional nodes. Whatever you are seeing, 2 additional will consume into 100. So total 500 over already. If you want to launch the 6th node, this is impossible. You cannot launch the 6th node in your Kubernetes cluster. You cannot launch this one. You cannot launch. Then, if your application is really demanding to scale up, you will face an issue. You will experience an issue. You will get an issue in real time. You will get an issue. So, it is always recommended to reserve a sufficient number of IP addresses, especially for the Kubernetes cluster. That's the bottom point exactly I want to highlight. If you don't reserve properly the sufficient IP addresses for Kubernetes cluster, finally your autoscaler, especially the cluster autoscaler, will fail. Cluster autoscaler is not happens on time. Obviously, your application cannot be served with heavy traffic. That's the point you should think about. All right, team. Thank you for the session. See you in the next part. Welcome back, team. Okay. Let's move on today, and we'll see how to provision the Kubernetes cluster and how to deploy the different services into the Kubernetes cluster. So that is where exactly very good learning for you today. I think we can enjoy our sessions. All right. So fine. The first and foremost thing, what we need to do here, team, let's go to the portal. Hope you are able to see my screen and able to see the portal as well. And the global search, in the global search, just proceed for AKS. Just search for AKS, team. Okay, just search for AKS. I'm just searching for Kubernetes, or you can search for AKS also, not an issue. Once you click on that particular Kubernetes service, you can see this particular screen. Here you can have a create button. Click on the create button, create Kubernetes cluster. Just proceed with that first. Click on Kubernetes cluster. So what you are doing now, you are provisioning a Kubernetes cluster. That is the first job here. So for that you have a resource group. I'm just taking one resource group which we have already, a Docker project resource group. If you guys recall, you can remember that, right? We have one resource group called Docker-project. You can just pick that. And also this particular resource group has a VNet. Okay, let me just give a walkthrough on the VNet. So what exactly the VNet is consisting of and what all the subnets are available. Let's see that one also, team. Okay. So just to double check. Okay, I'm just going for the VNet section. Just go for the virtual network. There I'm preferring a specific to the VNet, which is required for your Kubernetes cluster to deploy, right? That's what exactly our previous learning. In previous learning, just exactly the same thing, which we understand how exactly we need to plan for a virtual network and CIDRs. That's exactly the thing. So you need to have one virtual network, right? So the same thing which we are just thinking about. You just go for the Docker project SG VNet. So there is a VNet, team. If you go there to the subnet section, there you can see the subnets. Okay. At the moment you are seeing different types of subnets here. Okay, that is fine, more than enough. VM subnet, app service, because you don't have any kind of app service. I'm just taking this one out. This is not required for me at the moment. Okay, just take that app service out. And also there is one additional subnet also which is available. That's really good. And especially whatever the app subnet is there, I'm going to use the app subnet. Especially the app subnet is the one exactly I'm going to use for the Kubernetes applications, team. Kubernetes application. So this is very clear. So now what exactly I'm going to do, team, go to the Kubernetes cluster, and once you're here, you're just taking this particular Docker project, and otherwise you can create completely a new resource group and new VNet also. That is yours, but that is already there. Already we know. That is why I'm not giving a recap on that particular part, VNet and subnet creations. Okay, we just proceed further, team. So once you are here, there you can see the cluster preset configuration. You are seeing different models here. One is production standard, dev test, production economy, production enterprise. For hobby project, so whatever the project you are doing at the moment, I can get the dev and test. And if it is really a production equivalent, always prefer production standard or production economy. So that is the only thing which you need to pick it up always. For best practices case, always go for this particular production standard. Okay, that's the best one. Alright, and the production enterprise is the one if you really require the best security as well as permission wise, even third party person should not enter into a particular network or the Kubernetes cluster. It will be very strong. But you can keep the production standard, that is more than enough. You can just select that one. And these are all the options being enabled recently only. So earlier it was simple, some standard, that's all. Okay, so you can just refer the documentation, learn more, compare the presets. So you can just take a link here. You can double check what are all the differences are coming up. For example, you see these are all the differences exactly. See, they are using the different pool size corresponding to that. Mission size is different, and also you can check and how exactly they can scale 225, 200, 225, 225. You can see the difference here, Tim. You can double check the difference, and you can just go through this one, which are not really needed at the moment because you don't know most of the things. Now we don't know what is a private cluster, what is the private policy. You don't know all the CSI driven network policies, authorization, authentication. That's why I'm not touching this one. I'll come to this one later. Just wait for a while, Tim. Okay. just be here. I'm simply selecting the production standard. Okay, so our discussion would be, first we'll create a Kubernetes cluster and we'll play. Later again I'll come back to the Kubernetes cluster with a detailed discussion on each and every option. Okay, all right. So once you have go for the Kubernetes cluster name type, I'm just giving the Kubernetes cluster name as some 8 p.m. AKS is the one exactly I'm just giving. Okay, so once you are done with this particular thing, where exactly you are trying to launch a Kubernetes cluster in Southeast Asia region, that's enough team. Okay, and followed by there you can see the zones, zone 1, 2, 3. This is the interesting fact exactly I want to highlight to you team. Okay, for example team, so whenever you are seeing the zones, what exactly you can recollect team. If you recall one interesting fact team, if you recall one interesting fact in the diagram yesterday and day before yesterday when we were discussing, always we were discussing about your nodes are being deployed into the different zones, zone 1, zone 2, zone 3, to maintain high availability. I'm keep on stressing this point if you guys recall. The same thing I'm just highlighting here also. So what are the things you are seeing at the moment? I'm just selecting the zone 1, zone 2, zone 3, okay, to just maintain the very high availability on your Kubernetes cluster. Once this is done, team, I'm just going for the pricing tier. Again, you can see it's a free one. Just the free one you can use for the lower environments, but prefer the standard one only. So you can read for the mission critical and the production workloads. And also you can get the 5000 nodes per cluster, and also you will get a very good SLA, 99.95 SLA. So this is the best one which you can use for the production, but your test case you can use the free one. Okay, that's more than enough. And the Kubernetes version is the one you can see the different types of version, and remember one thing, whatever is default, please select that one. And another catch I'm telling you here, if you are using any kind of lower versions of the Kubernetes cluster, I mean at the moment you can see some 1.25.6 as the lowest version. Okay, whenever you see some lowest version, please do not select such an option. So always go with at least default. Okay, you no need to go for the latest previews and all, at least go with the default one. The reason why I'm telling, if you don't select the more than default version 1.26 above, if you don't select that one, Azure will not support you. If you raise a really incident, some issue is happening from your end, first and foremost thing what they will tell you, you please go there and upgrade your Kubernetes cluster. You don't know, if you upgrade your version to 1.26 to 1.28, you don't know which one will break. That kind of worry always you will have, team. So that's why my recommendation is just keep with the default. That's enough, team. And another one, automatic upgrade enable with the patch recommended. Okay, so what exactly these things are talking about? For example, see, now you are seeing 1.26 as the default one, and also few other versions also being placed here, 271, 273, 28. And you want to proceed with this kind of automatic upgrade. Is that the thing exactly you are just expecting to see? So that is what exactly it is just talking about, team. Okay, and you no need to go for this one. My suggestion is don't go for this one, because for example you have set up a very strong network. Maybe let's consider you have set up some blockchain network or some kind of network in the Kubernetes cluster. If you completely depends upon the automatic patch update, automatic patch upgrade, if something break, I think you cannot answer to the client in the production. That's why we should not encourage these kind of upgrades until and unless it's safe. Of course, it's Azure managed only, but why to take risk? If something break, they will also say apology only. That's all. But the problem is you cannot say apology to your customer every time, right? That's why my recommendation is just disable that. If it is really necessary, then we can think about it. And next one is the authorization and authentication. That's the next thing which you are seeing on the screen. For this particular thing, you can see the different types of authorization authentication method. The local accounts with the Kubernetes RBAC, or Azure AD with Kubernetes RBAC, or Azure AD authentication with Azure RBAC. So these are all the different types of authentication. At the moment you are saying, I'm just selecting the default option, whatever is available. Okay, as I already mentioned you, I'm not deep diving into the options which are present in this each and every field. Okay, let's try to create a cluster first, then we will discuss deployments, and followed by once you get a solid idea, then we'll discuss these things again. Just go back to the notebook. This is what exactly I highlighted for you very clearly, team. Okay, very clearly I highlighted for you. The specialty team, I believe now they are adding a user pool also. Okay, earlier I think they will only give some system pool, team. This is what exactly the pool usually they will always give by default. But the point you should understand here is, okay, what are the agent pool? I think what are the agent pool and what are the user pool? This is newly added, seems to be. This was not even there even a month before. Okay, this is newly added. But the advantage of this particular user pool is, See, system pool is completely, just assume system, that name itself is telling you very clearly this is only for managing the Kubernetes cluster, meaning that this is only for Azure to just manage Kubernetes cluster. Maybe they'll deploy some specific resources into your Kubernetes cluster. So for that purpose, usually they will use this system pool. And also the strong recommendation even from the Azure is do not ever deploy any kind of node, any kind of application to the system pool. Don't deploy that one. But at the moment I'm just seeing only two pools. One is system, another one is user. You can create n number of user pool. What exactly the pool I'm talking about? This one team. 1, 2, 3. The combination of this particular nodes is nothing but a node pool. So total in the node pool, how many VMs are there? Total 3 VMs. I already mentioned the collection of VMs is nothing but a node pool. I highlighted that one at somewhere here or somewhere I highlighted. So collection of the node pool. Yeah, this is what the connection of the nodes is nothing but the node pool team. So that's exactly the point here. So now what exactly you need to think about here is times, but whatever the option it is just showing, just keep that one as it is. You don't need to work on anything here, but slowly you will understand the differences, what exactly we need to use, what kind of node affinities you should use, those things and all you will understand, but not right now. Don't go too fast, learn slowly, okay? And the virtual nodes we'll discuss later about this virtual nodes, and also this particular this is OS disk encryption only, just ignore these things team. And also I want to highlight one interesting fact. Click on the agent pool. Yeah, especially when it comes to the agent pool team, there you are seeing exactly the interesting fact here. This is what exactly I just mentioned. Okay, let me give a quick view here. Okay, what exactly the thing you are just seeing here. This is one of the system agent pool. There you are saying available to join as 1, 2, 3, and they are recommending some size DIDS v5. You can still control this one, not an issue, don't think about it. And also you just go there you can see scale method. See, there is an option called choose size. That itself is enough to just change your virtual machine model, so don't worry on that. And followed by scale method manual or auto scale. So auto scale is recommended only, but at the same time you need to be very cautious when you're going for the test applications. Okay, so for example, someone in your project is keep on doing some performance test on your application team. Obviously what will happen, the performance test requires more CPU and more memory. Obviously your nodes will scale up. Your nodes will scale up. Obviously your charge also will be displayed on your bill. So the point here is just enable this one whenever it is required in the lower environment, but this must be enabled for the production environment. So that's exactly the point. Okay, production must. And also this is how exactly you are scaling now. So minimum node count is 2, maximum node count is 4, something like that. You can still control. You can keep this one as 1 and you can keep this one as 2, something like that. Also still you can control them, so nothing will happen. Okay, and followed by there you can see this is the interesting one which I'm trying to highlight and explain in your previous class. If you see max parts per node is 110 team. This is what exactly yesterday I spent some time to just explain these particular stuff, how exactly you need to deal this case. For example, see node 100 parts, that's what exactly we discussed, right? So point here is still you can control this one. That's exactly the thing I highlighted. You can keep some 70. Now tell me team, what is exactly the subnet size we planned for this one? You can see here, okay, subnet size we planned is 250, and you are just giving this particular thing as 70. Total how many nodes you can launch? 3 into 70, 3 nodes you can launch, 210 IP addresses, clear. Fourth one you cannot launch. The reason is to need 4 you need 280 IP addresses, but you have only 250. That's exactly the calculation team. So for the last session, if you guys don't understand, okay. Alright, so once this is done, enable the public IP per node, which is not at all needed. We don't want to keep any kind of public IP for the node. It itself is a threat for you if you are keeping public IPs and all. Not needed team, just ignore. Okay, this is label, and finally the taints and no tolerations, these things and all in further sessions I will discuss. Okay, I'm just updating this. So once you are done, I'm just going for the network section team. There is a next networking section. This is the interesting section. There you can see the step number 1. You want to keep your cluster as a private? Absolutely yes. We want to keep always our Kubernetes cluster as a private. Please select this one, enable it. Okay, this is very important team. Okay, And also, so why this option is disabled? See, usually if you disable this one, this option is enabled. The reason is, for example, team, if you make a public cluster means that doesn't mean that each and every person from public can hit your cluster. That is impossible, team. But still you can whitelist only some set of IP addresses. Yes, I want to allow only some set of IP addresses only. You can give the IP address only, that particular set subnet only can connect with this particular cluster. You can still control that, but you no need to think about this option at all. The reason, always we will make sure clusters are private. So that's a base rule, team. Okay, everything is a private. That's the safest one. All right. Next one is the network configuration, which you are seeing at the moment, which is a KubeNet. Another one is the Azure CNI. So there itself, there is a small difference between these two, the KubeNet and the Azure CNI. Especially when it comes to the network configuration, team, you can read this one. Best for the smaller node pool, each pod assigns logically different address on the subnet for a simpler set. See, the best for the larger node pool, the only difference between these two things is, first and foremost thing, the KubeNet is suitable for the smaller work nodes, smaller workloads, and the Azure CNI is suitable for the larger. Now, why they are telling it's a larger suitable? There is a reason behind it. In Azure CNI, if you read this one, pod is assigned to unique IP. The same concept we discussed it so far. That is what exactly the Azure CNI is coming from. So it's best recommended to use the Azure CNI. Since you are using Azure Manager cluster, that one will be always helpful for you. If unknowingly, if you select the KubeNet, which is a smaller work node, example I'm just telling. So meaning that what exactly the thing, you need to struggle a bit to just spend some time for the internal routing. It may cause some latency issues also, especially when the application being deployed, when you are accessing the application. That for the traffic, it may create some latency also. That's why it is recommended always go for the Azure CNI. So which is best suited for the larger node pools, and also you can give a specific unique IP for the each pod. The only drawback with the Azure CNI is, team, it consumes more number of IP addresses. That's exactly the problem. Because obviously it is supporting for the larger work node pools, right? It consumes more IPs as well. So those are the things exactly you can think about these two options. But simply remember Azure CNI is fine. Okay, that's all. And bring your own network. Of course, I have one. I have my own network. Please select this option. Now it is asking what is exactly your virtual network. Yes, we have a virtual network called Docker, right, team? Docker. Project SGVNet is the one exactly the thing which you are talking about. See, now it is throwing an error message. Can someone please read this error message? The subnet is not large enough to support all your node pools. Current IP is available 215, but required is 11,242. So the problem is, there is a problem happened, especially in your previous section on the node pool. See, your user pool is scaling to 2 to 100 team. That's absolutely wrong. Okay, I'm not really interested to keep this user pool at the moment. See, that is what exactly your user pool calculated. So total 100 are required. 100 into 70. That is where exactly calculation happened, team. So by default, not 70. I think that one we haven't touched. If you don't touch your node pool, default pod IPs required is 110. Okay, Yogesh also asked in our last session. Okay, default is 110. So obviously that one will take 100 into 110 plus 2 into 70. That was the exactly the calculation you are seeing on the screen. Okay. So to be frank, you no need to worry on that. I'm just going here and just select this one. Now I believe still it is assuming the same thing. Maybe you just need to reload the screen. No choice actually. Okay. I think we forgot to update that particular node pool section. That is why I think it is still showing that. Okay, let me go for that particular option quickly. Okay, sorry. Alright, you just go for this particular thing. I'm just going for the Docker project and followed by this particular down. This isn't okay. I'm just doing the AKS 8 PM. The same option I'm just giving. These are all the things, and just go for that. And I'm just going for the agent pool is there. I'm just going for the agent pool there. I'm just referring one interesting fact. I want to keep this one as 1, this one as 2. Even you can keep this particular thing as a manual. I need 1 VM, that is more than enough. Even that is also absolutely fine, team. And 110 is the number, you can keep it. That is also fine. You just update this one. So that's the thing you need to do. Go to the networking section, enable private cluster, very important thing, and go for the authorized, not really needed because your cluster is not a public one. That's fine. And go for the network configuration. Azure CNI is the best suit, and bring your own network. Please go there. And finally, you are seeing Docker project SGVNet, right? Just this is what exactly the interesting thing. I'm just selecting the wrap subnet which we prepared for this one. Perfectly alright, team. And interesting fact, do not touch these two address spaces, especially what exactly these two address spaces. If you don't touch that, is the best thing which you can keep it. See, if you read this particular thing, generally when you are launching, if you can read this one, to assign service cluster IPs. For example, team, if you recall our services session, there I told about the cluster IPs, right? Especially, so these kind of cluster IP also require an IP address. Pod require an IP address, this is well known fact, but even cluster IP also require an IP address, team. But who will give the cluster IP address exactly? Or who will give the pod IP address exactly? So those things, especially this cluster IP section generally will come from the Kubernetes cluster only. That is why this particular subnet, from this subnet, cluster IP will be picked up. That's exactly the thing it is just telling you, team. Okay. This particular section will be used for the DNS communication inside the Kubernetes cluster. So recommendation, just keep these things as it is. If you touch this one, you should make sure these particular subnets or these particular IP is not overlapping with this. That is also important. Okay, keep that point in your mind. All right, I'm just going a little bit further. There is a network policy. This is an elaborated concept actually, but for now I'm just placing. So there you are seeing None, Calico, and also Azure Native. So Azure Native networking solution. So these are all the different types of network policies where Azure is offering you. So by default, either Calico is the one exactly you can go for the open source. This is a third-party open source which you can use again for the large-scale deployments. Definitely it's possible, but you need to put the effort. And even Azure Native Working Solution also, this is simpler to basic security network requirements. That tender your wish, team. If you really require to control some traffic among the pods or among the services, that's absolutely fine. Then it is the best option to refer the network policies. That's absolutely fine. But for now, I'm just taking, you can simply put Calico also, nothing will happen. Nothing will happen, but you need to define going forward. So that is the only the thing. But you can use Azure also. Azure also you can simply make use of this particular thing, not an issue. Going for the integrations, I'm not integrating any kind of Defender Cloud Container Registry or monitoring section. I'm not doing anything. I'm just Azure monitoring also. I don't need to monitor anything. I don't need to have any kind of alerts. Okay, not really required. Okay, fine. So once you are done, see this Azure policy. See, the Azure policies enforces especially your Kubernetes cluster to be safeguarded from the security point of view. I think it will help you to just make sure, I think especially on the any kind of attacks from the outside. So that's where exactly Azure policy, but don't enable this one for your dev test, these things and all. For production, please go ahead. Okay, not an issue. And finally, I'm just going for the advanced section. Enable secret store CSI driver. This particular option really helpful for you to pull a secret from the key vault. I'll show one discussion especially on the key vault, how to pull a key vault secret in the Kubernetes cluster. Slowly I will show you. Maybe when we are discussing about the cron jobs, but at the moment you don't worry about this particular one. But you just remember the option. If you enable this one, there is an option where it can pull a secret from key vault to Kubernetes cluster. That is exactly the thing you can think about. Okay, right. So all right, this is the another interesting fact. If you read this infrastructure resource group team, can you guys read this one? MC underscore Docker-project. This is what your actual cluster name. Underscore AKS AK. Sorry, this is what your resource group name. Sorry. This is your resource group name, and this is what your cluster name, and this is your location. See. MC underscore resource group name underscore cluster name underscore location is the one a new resource group will be launched. That resource group consisting of all Kubernetes services which are required specially for our further discussion. All the services Azure will provision under this resource group, not under your resource group. Though you selected your resource group here, under this one only cluster will be there. But all cluster resources, whatever are required for the cluster, those things will be tagged under this resource group. So when you are creating a Kubernetes cluster team, you should keep one thing in your mind. Once you create a Kubernetes cluster, new resource group will be launched. That point you should keep in your mind. New resource group will be launched. So keep that point in your mind. And finally, review and create, and finally click on the create button. So now what exactly the thing you are trying to do here is we are simply creating one Kubernetes cluster specially from our environment. So they are telling the VM size of the DS2 is only allowed in the zone 2.1 in your subscription Southeast Asia. The problem here is you just mentioned one interesting fact under the basics, right? This is what the issue exactly is coming up. I don't want to control this particular availability zone. I'm simply leaving that one, okay? Because we are using the developer accounts or the free accounts. They will not encourage you to block these kind of things for actual usage, okay? I'm just validation is through. I'm just creating the Kubernetes cluster. You know one thing, team, this Kubernetes cluster provisioning will take some 5 to 10 minutes easily. We'll just wait for this particular case. Meanwhile, I'm going to show you one option for you right now, okay? For example, today, this is what exactly you are trying and you are creating, okay? This is what exactly you are just trying for, right? So for example, team, for example, I don't know where it's been created, not an issue, it's okay. I'm just creating, this is what your virtual network. Let me form it, team, let me form it. This is what your virtual network. Under this virtual network, there is a Kubernetes cluster. That is what exactly you are trying for. This is a Kubernetes cluster. So Kubernetes cluster being launched in one of the subnet. That's what exactly you achieve. I'm just taking Azure VNet. I'm just taking one particular icon. If it comes up, let me bring that one. Azure network. I'm just bringing up the Azure virtual network team so that your understanding would be good. And also I'm just taking this particular thing as Kubernetes. Yeah, I'm bringing up the Kubernetes also, especially this is the Kubernetes exactly you can think about, okay? So you placed Kubernetes also inside. Now this is the virtual network, right? I'm just making this is little bigger, okay, little bigger. Now I'm going to take another subnet, especially this is another subnet which I can talk about. This is here. I'm just going to launch a virtual machine team, okay, one virtual machine. Now you should think about one case team, okay? I'm just launching a virtual machine here. Now the point here is, I told you already, your Kubernetes cluster is a private cluster. Agree? Your Kubernetes cluster is a private cluster. This is a virtual network. This particular part is a virtual network team. This is a VNet, this is a VNet. I'm just keeping, okay? I'm just keeping the VNet, okay? What are the VNet you are seeing at the moment? I'm just keeping this one as a VNet. And also this is a Kubernetes cluster. Now just remember one interesting fact here. So whatever the option you are seeing, this is a Kubernetes cluster. But the point what exactly I'm trying to highlight for you here, team, since your Kubernetes cluster is a private thing, it is not so easy for anyone to just come and hit your Kubernetes cluster team. Point to be remembered, okay? It is not so easy. Then how exactly we need to solve this case? How exactly you need to solve this case? How I can interact with the Kubernetes cluster? Because I need to deploy my application. I need to deploy my services, right? How you can do that? This is another challenging thing which you can think about. That is why I have deployed one VM here. The reason why I deployed VM in this particular subnet is, the reason is, I need to deploy my application in the Kubernetes cluster, with the help of this VM. If you don't have this VM, you cannot connect with the Kubernetes cluster, because your Kubernetes cluster is a private cluster. No, this is sitting in the private subnet and this is a private cluster. Not easy for an outsider. If you consider a person, I'm just considering a user, okay? If you consider a user, whoever the user you are just considering, it's not so easy for this user to just connect with this your Kubernetes cluster team. This is impossible. He cannot connect directly because he needs to come inside the virtual network. He needs to come inside the subnet. Then only he can hit this. That is not possible, team. And also, if you allow this guy, whoever you are saying, let's take this guy as a DevOps engineer now, okay? DevOps engineer needs to connect to this particular VM first. If he could connect to the VM, obviously subnet communication is absolutely possible, right? Subnet communication is absolutely possible, so that whatever the VM you have, definitely you can make a connection with your Kubernetes cluster. This is absolutely fine. So next you need to prove this combination. How can I connect to your Kubernetes cluster as a DevOps engineer? How I can make a connection, how I can make the deployments, how to proceed. That is what exactly next we need to see. Thank you for the session. See you in the next part. Welcome back, team. So we have a virtual machine ready in the same network. So that was exactly the discussion we started. So for instance, if you go back to your architecture, what are the architecture we were discussing? So this is what exactly we started, and you have the Kubernetes cluster sitting in one subnet, and you have the virtual machine which is ready in another subnet. Now the goal here is we are planning to make a connection from the virtual machine to the Kubernetes cluster. Why we need to do this? The reason for that one is, so as a DevOps engineer or as a Kubernetes admin, what exactly we need to do? For example, if some issue happens on the Kubernetes cluster, or whatever the application you deployed, that application is not really working, it is not responding. So always you should have some option to go there and see the logs or see the pods are really up or not. So these kind of things you need to ensure always. For that, you need to have this kind of access. Of course, in latest trend, you can see the tools like Prometheus, Grafana, Promptel, Loki, all these things are giving a better visibility than this kind of option. But my suggestion is start with this one first and try to understand. So once you are well versed with the Prometheus Grafana, then you can form completely a dashboard where you can see the logs corresponding to your Kubernetes pods. Alright team, so at the moment our virtual machine is ready. This is what our virtual machine, and I'm going to connect to this virtual machine. Let's use the Visual Studio Code and we'll try to connect today, team. Okay. So I'm just going for the connection. I generally go for the configure host. I'm just opening the configure host. And here, especially under the configure host, I'm just bringing up we have AKS VM, one AKS VM already. So what exactly I'm just going here, I'm just bringing up the IP address. What are the IP address we have? Just going here and just fill this IP with that. Alright, that's all. Alright, now just go for the proceed for the connection. I'm just going for the connection, connect to the host AKS VM. Okay. Alright, so it is asking the password, just pass the password. So this is the password exactly. We are just passing to this. Alright. So it will help us to just establish a connection with the virtual machine or something. You are able to see now. Okay. Alright, just click OK. Perfect. So fine team. So once you are inside the virtual machine, what exactly you need to do? So go to the terminal. It's the best thing which you can do. First and foremost thing, go to the terminal. So blindly, generally whenever you are here, obviously you will just go for the terminal and you will just come here. You will try to apply the command. What command you need to apply? What is your goal? My goal is to establish a connection to the Kubernetes cluster. That is what my goal, team. So to do that, what you need to do, you go to the Kubernetes service. What are the Kubernetes service you provision? Go to the service. There you can see on Kubernetes service. Of course, any Kubernetes service you can consider, not an issue. And I'm just going for, this is just a connection only I'm showing. That's why. You just go there, blindly you will just submit, okay, there is a subscription, because you may have a lot of subscriptions. You need to tell where your Kubernetes cluster is sitting. That is really important. That's why you need to set this particular Kubernetes subscription first, okay? Alright, just go there and just submit the command. See the command, from the error itself, you can understand what is the problem exactly coming up. What problem is coming up, how to solve this one. You can understand from this particular error itself. It is clearly telling, see, you don't have the AGCLI installed. So please proceed on the installation. Okay, I gave one Microsoft link to just install this one. You can use this one. See, I believe whatever the recommended option is there, it is not helping us to make it install. So in this particular situation, you just go to the browser and just go there, AGCLI installation Ubuntu. Okay, install Ubuntu. Just go there to the particular website team. So you just come here. Just there is a single command. Is it? Just copy this one and just go back and just submit the command. That's all. So you're just making sure AGCLI is installed in the virtual machine, which will help us to apply the further AG command also. So far your connection was through portal UI, right? So now onwards you are connecting through a virtual machine CLI. So that is what exactly you're just improving in this particular connection point of view, team. Wait for a few seconds, it will be okay. Alright team, so now see AGCLI got installed, team. Alright, so once that is got installed, okay, I'm just proceeding for the one more command, just subscription setup one more time blindly. I'm just going for this, but actually this time it is telling the subscription doesn't exist in the Azure cloud. See, you need to tell them very clearly who has this particular subscription access. That's exactly the problem here. That's why you just need to apply AZ login. You need to apply AZ login, team. No problem. Anyway, I think it's typo. That is first thing. But the best command which you can use always here is you can use this command team. This is the best command. Always this command will work. Okay, just use this particular command. This is also fine. Now what exactly it is telling? Open this browser and just pass this code. That's what exactly it is telling you. Just click on this one. So it got open in my other window. No worries. Okay, let me copy this particular link. Okay, first, and just going for the browser and take another tab and just paste over there, and followed by just give the passcode. So what are the passcode that just recommending? Okay, so with this you are authenticating exactly. So you are telling to the Microsoft Azure exactly you are logging in via CLI. That's what exactly you are telling. Okay, now you get the permission. Now you go back to the not terminal. You go to the Visual Studio Code. Now you can see the JSON response queue, meaning that your subscription, what are the subscription, you are completely logged in. Now the moment here is, now I'm just going for the subscription setup now. That's really awesome team. Okay, this is absolutely good. So once you are done with this particular part, what you need to do, the next immediate thing here is you just go here. There is a download cluster credential. This is the really important case where you need to pull the credential to the Kubernetes VM, not a Kubernetes VM. It's a standalone VM. Okay, I gave the name as AKS-VM, but don't think like it's a Kubernetes VM team. Okay, it's a standalone VM only. Okay, right. Since I'm using for the Kubernetes, that's why I just gave the name. But don't think like there is no relation so far. There is no relation so far between the VM and the Kubernetes. Now you are forming the relation now. Okay, just go there and just form this particular connection. What exactly it is doing? AKS get credentials, resource group under this resource group. This is the Kubernetes cluster. You are pulling the credentials into the virtual machine. The advantage of this particular thing is at any moment in future, if you log into this machine, automatically you can access the Kubernetes cluster. Point to be noted. You can have n number of Kubernetes clusters can be connected to this VM. That's what exactly the scenario which you can think about this one also. For instance, team, let me just zoom out a bit. Alright, so for example, team, now this scenario, if you consider this scenario, what are the scenario on the screen? For example, team, this is your dev environment AKS cluster, that's fine. This is your site environment AKS cluster, that's okay. And you will have pre-prod and production as well. But tell me, are you really interested to spend some money launching the virtual machine every time for the each and every cluster? Obviously no, we are not very much interested. So then what exactly the technique you will use? Obviously you will have one single VM and try to have the connection, this particular VM to this cluster and same this particular VM to this particular cluster. This is what the thing exactly you need to practice. So meaning that you should be able to connect your Kubernetes private cluster from outside of the network. That's the technique you should understand. Okay, just try to do as a homework this particular part. If you guys are unable to do this, I think I will explain one more time how to form this connection. Okay. Alright team, just try and let me know what exactly the things you guys attempted so that anyway I'll give the solution, don't worry on that. Alright team, so now the awesome thing here is the connection is formed already. Okay, to know that whether Kubernetes cluster is really up or not, you just go to just apply the kubectl SVC, another problem. So always to interact with the Kubernetes cluster, you need to have some CLI tool. That is the tool exactly you are seeing as kubectl. The kubectl is the one exactly which you can use to connect with your Kubernetes cluster, which is mostly widely used tool only. So what exactly you need to do? I think they're recommending a simple command. Just proceed on that. Just submit this one. When you submit this particular command, again they're recommending just submit this particular thing with -FN classic. Okay, -FN classic. So just proceed on this particular. Now it is downloaded in the kubectl into your virtual machine. You can find these particular commands, even some sort of other sudo apt module command also in the internet. Okay. You don't need to worry on that. You can find in the internet also how to install kubectl in the Ubuntu machine. That's a search sentence. Okay, just try. Perfectly alright team. So far awesome. Now I'm just going for the kubectl get SVC. That's perfectly alright. See, you have a connection to the Kubernetes cluster. That's really good. Perfect. Thank you for the session. See you in the next part. Welcome back team. Now, what exactly our goal ultimately? Why we are discussing about Kubernetes cluster? What is the need? We are discussing about the Kubernetes cluster. The only reason here is we are planning to deploy. We are planning to convert an application to the Kubernetes model. So while converting an application to the Kubernetes model, what model you know so far? You know how to delay a standalone project. That's what exactly I explained in our previous calls as well. If you recall, this is a standalone project, right, where you completely packaged your complete code. That's what exactly we learned. And on top of it, we learned the Docker project, where Docker project comes up with a Docker file so that you can build your application as a Docker container. On top of it, we are started discussing about another application which consisting of a Docker file along with the manifest as well. Manifest files. Now we need to understand what is manifest file. So the combination of Docker file plus manifest file exactly will help you for the Kubernetes application deployment. So you should understand about what exactly the manifest files, what all the files are there, and how to make use of those manifest files. Alright. So to do that team, what exactly the thing you should understand now is, let's start understanding about how exactly we can set up a simple application. Okay, a simple application, how to set up a simple application, so that I think you can understand some sort of, you can get some sort of understanding on the deployment or simple deployment. Okay, fine team. So I think you can easily go for the Kubernetes documentation also if you are interested. Okay, just go for the Kubernetes documentation. Another Kubernetes documentation deployment I'm just going for. Okay, just go for the Kubernetes deployment. There you can see I think few examples are already there. I'm just bringing up one of the example, whatever is the direct copy. Okay, I'm just copying one particular deployment, whatever is there. Let me explain this one thing, don't worry. So I'm just going here. Now I'm just creating one particular file here, which is a deployment.yaml. Okay, deployment.yaml. Okay, I just took one example, which is a deployment.yaml. I just pasted the what are the things I copied. Awesome. Let me explain this one a bit so that you will get an idea. Okay, what exactly the thing and what we need to understand here. Okay, we should understand few things. Okay, so team, always remember one thing. Whatever the manifest you are considering. Okay, always that manifest consisting of 4 sections: API version, kind, metadata, spec. Okay, these are the 4 sections usually you can see. And also, the interesting fact here is, what are the API version app/v1? This depends upon your Kubernetes cluster version. For example, if you are using some latest Kubernetes version, you may need to look for what exactly the API version we should use. That one will be available in the Kubernetes documentation, or even Azure also will tell you in the documentation. But at the moment, you can blindly proceed on this one. Don't worry on that. Okay, you can proceed on that because you are almost latest. So you don't worry on that. And also, the second thing, with what of the thing kind is discussing about what kind of manifest it is. It is a deployment. It is a deployment exactly. Let me talk about one simple hierarchy before proceeding further. We will get a solid understanding on what exactly the thing we are discussing. Okay. For example, team. For example, I'm just considering. For example, this is what, just assume this is exactly the pod which we are trying to deploy. Okay. What exactly pod consisting of? Pod consisting of a container. We know that very well, right? The pod consisting of a container. Now, inside the pod, container will be available. Maybe I'm just keeping this particular thing as a container. Okay. I'm just keeping this particular thing as a container. A pod can consisting of a multiple containers, which you know already. But I'm strongly recommending you don't keep multiple containers inside a pod. Okay, don't do that. And the second one on top of it, I'm just bringing up, that thing is nothing but a pod team, right? This particular pod you know already. So now what exactly and why I'm just bringing this particular thing? This is a pod. Awesome. So far we know this particular thing. On top of this one, I'm just giving one more layer team. Okay, one more layer. That particular layer I'm just discussing as that particular layer as a replica set. I'll call this particular thing as a replica set team. Okay, I'm just giving this particular thing as a replica. Okay. On top of this particular replica, what exactly I'm just doing? One more layer I'm just bringing up team. One more layer. And I'm just calling this particular layer. What are the layer you're seeing at the moment? I'm just calling that particular layer as a deployment layer. Okay, deployment layer. So team, if you keep this particular hierarchy in your mind, your deployment YAML is very easy. You should keep this particular hierarchy in your mind. So that's very easy to understand now. Okay. See what exactly the container, a pod consisting of a container, a replica consisting of a pod, and deployment is completely controlled in the replica. This is the sequence you should understand. Okay, exactly. Alright. Now, what you don't know exactly what is replica here. Generally, you know what exactly this particular thing, but you don't know the terminology. If you just come here, team, in your previous sessions, we keep on discussing about when we are deploying our applications as a replica. Deploying applications as a replica, right? That's the thing exactly you are keep on listening. See, meaning that 1, 2, 3, meaning that 3 replicas. So meaning to just maintain the high availability. We are always deploying our application into the pods. And you're not only one pod, right? Always you are maintaining, for example, 3 zones are there, at least 3 pods you are maintaining, which can give you the super high availability. That is what exactly you're looking for always. That's absolutely awesome. Alright, that is what the replica. And who is controlling the replica? The replica is being controlled by the deployment. Always remember this one. But replica is not being controlled by the service. Please understand. Service is not controlling. Service just route the traffic to the pod. It will not, or it cannot control. It cannot control. The complete control of the pod is in the hands of deployment. Please understand. Okay. Now go back to the Visual Studio Code now. Now you just come back here. See, that's the thing exactly at the moment we are seeing one deployment. Okay, awesome. And then third section is the metadata. Let's talk about a bit on this particular. Generally, when it comes to the metadata section, team, always you need to define some specific attributes, especially about this particular deployment. So metadata is nothing but any things you want to define, a name, a ID, or something. Something you want to define for your deployment. That's the thing exactly it is talking about. Okay. And also, if you notice, name is the one NGINX deployment which they defined. On top of it, they define the label. Labels plays a very good role here, team. Always remember. I told you already, if you recall. So one of the thing, generally, how exactly the labels technique will be used here. For example, team, if you remember one thing, for example, when how service is routing the traffic to these particular parts by using a label. How deployment is identifying these particular parts by using a label. How replica set is identifying its corresponding parts by using a label. So this is completely a label technique only. You will understand in few seconds, just wait. Alright, so that is why exactly we are defining a label with a key value format, a key and a value, a key and a value. Just understand like that. Alright, so far good. Now I'm just going for the specification section. If you open this particular specification section, what are the specification you are seeing? Okay, alright, team. So now if you see, team, now what exactly the thing you are come across here? See, you are seeing replicas as 3. First and foremost thing, right? Replicas as 3. Generally, when you are seeing this particular spec, you are clearly telling you should launch 3 pod replicas. This is pod spec. 3 replicas means 3 pods you should launch. And also, how exactly this is being controlled, that matters here. See, basically how, based on what we should launch this one. If you recall this particular 9, 10, 11 statements, 9, 10, 11, that is a condition actually. Select R, like if condition. If A equal to B, if C equal to D, or something like that, usually we'll always think about in the programming languages, right? Something like that. Here also, select R is equal to app:/NGINX, meaning that what exactly it is doing, you can launch 3 replicas. You can launch 3 replicas when there is a match happened on the labels. Okay. If you define your pod label, where exactly you are defining the pod label, this is what your pod label, team. Okay. This is your pod label. You are telling very clearly, hey, if you notice this particular under pod template section, you are seeing this particular pod template section. There you are seeing a metadata, again information. Metadata means just an information. Under the metadata, you are just defining a labels. If you see the labels, team, there you are just giving one particular label called app:/NGINX. That is the key here, team. That's the key exactly. Okay, what exactly it is doing? See, whatever the label you are giving here, same thing you should pass here. Then only 3 replicas will be launched. That's the connection exactly. That's exactly the connection. Okay, please understand. So whatever the line number 15 must match with the line number 11. Then only 3 parts will be launched. If you are using NGINX 1, it cannot launch 3 parts. It's a mismatch. So what exactly your replica will look for? Replica wants to launch 3 parts where the label tagged as NGINX 1. But you have not tagged your, you labeled your NGINX as NGINX only. But your just condition is NGINX 1, which is wrong, not matched. So these kind of mistakes don't do that. So the problem and the point you should understand here is, you should make sure a proper match from 11 and the 15. Don't by heart these line numbers. I'm just highlighting for you, okay? Because if you go for the very lengthy deployment, that case will be different, okay? Case will be different in the sense multiple values, multiple sections will come in between, okay? Understand slowly from 0. Alright, team, I'm just going for the container spec section. This is what you now you can sense it, see? So deployment, on top of it replica, on top of it pod template, on top of it container spec. See, container, pod, replica, deployment. That's the sequence exactly we are discussing here. Same hierarchy whatever I just showed you. And if you come to the spec section team, there you are seeing containers, NGINX, and image NGINX colon 1. So this particular thing, what exactly, this is a container name, and you are telling this is the image, please pull this particular image from the Docker Hub, and please enable the container port as 80 on this particular container. That's the thing exactly you are highlighting here. See what exactly the thing will happen. Now I will show you once you are, this is just a sample deployment only, right? No need to worry on this. For example, now you go for the kubectl apply -f, what all the things are there, -f, I'm just going this particular thing, just submit this one. Now it is just telling I have submitted a manifest to the Kubernetes. Now Kubernetes responded with, okay, engine deployment created. A deployment got created. First and foremost thing, what exactly things got created? Let me check one by one. First and foremost thing, kubectl get PO, for example, PO or pod. You can give POD or PO, anything is fine. For example, if you go kubectl get PO, what exactly it will tell you? It is telling you very clearly, total 3 pods you are seeing, first and foremost thing. A total 3 pods you are seeing, meaning that your application being launched in a 3 pods. That's exactly the thing. But how many nodes? Is it really been launched in the 3 nodes? That one also you can check. Kubectl get nodes. For example, if you apply that command called kubectl get nodes team, you are seeing only 1 node, meaning that all 3 pods are sitting in only 1 virtual machine. That virtual machine is sitting in only 1 zone, which is not at all good for your production scenarios. Please understand it. Please understand. So my point here is you have deployed simply 3 pods in the same node. Okay. The reason for that one is I don't have the quota where I can extend multiple virtual machines also. Okay. That's why I cannot launch the multiple virtual machines. But ultimately, in real-time use case, you need to deploy your pods into the multiple virtual machines which are present in the multiple zones. That's the thing exactly you need to practice. All right, team. So now, once you are done with this particular submission, now what exactly the thing we are achieving, what the thing actually happened. You can see one thing. So pods deployed, that's really awesome. For instance, what are the NGINX being deployed? For example, in real-time use cases, the possibility of the real-time use cases, I'm just telling on few things, okay? First and foremost thing, okay, I want to check the logs of your NGINX deployment or NGINX pod. What are the pod you just deployed? I just want to check the logs. To check the logs, always kubectl logs. I can copy this particular command team, NGINX deployment, you just paste over there. See, generally, when you have this particular command kubectl logs and the pod name, if you keep -f, it will show you the running log. If it will show you the running log, currently no logs are happening, nothing been listed inside the pod. That's why it is showing empty. But in your application scenario, what are the scenario we are going to do? That particular scenario definitely will launch some logs. So don't worry on that. Definitely it will launch. All right, team. So for what we understand, we just deployed a simple deployment and we just understand few commands, especially get svc, apply. Apply means just you are just submitting the manifest to the Kubernetes cluster. You just understand kubectl get PO, kubectl get nodes, and allow kubectl logs. These are the commands. I'm going to try one interesting fact now. I'm going to delete one pod team. Okay, I told you one thing. See, if you recall, if it's self-healing is one of the feature which you can think about when it comes to the Kubernetes, right? So what does that mean? For example, if your Kubernetes pod is being deleted accidentally, or your Kubernetes pod is being moved to the OOM error, out of memory error, or otherwise some health check failure or node draining, all these scenarios definitely cause your pod to be restarted. But the point here is I'm simulating the scenario by just considering kubectl delete PO. I'm just considering one of the pod, just copying this particular pod. I'm simply deleting this particular PO team. PO refers to pod only team. Just delete this pod. See, the pod got deleted. Now, the moment when the pod got deleted, immediately I just go there and just keeping -w. So, okay, I think it came up very quickly. What does -w refers to? -w is the one exactly will help you watch under watch mode. You can see something is happening on the pod. Some pod is going for restart. Some pod is going for termination. Some pod is falling into the pending. All these statuses you can see when you give -w. If something is happening, you can notice this particular thing. Let me show this one practically for you. I just kept -w. in this particular tab. I'm going to open one more tab for you, team. Okay, this is a one more tab which you can think about. For example, what exactly the thing, I'm just going here, kubectl get PO. Okay, I'm just listing the pods, team. Now what exactly I'm going to do, kubectl delete PO. I'm just deleting one pod specially from here, team. Okay, I just deleted one pod. So one pod got deleted, it just come back to you another tab. See, a lot of some process is happening here. Now you can sense one thing. See, you deleted one pod. If you go back to this particular thing, you can sense it. See, you got deleted some one thing for D5Q. D5Q is the pod exactly ending with. That is the one exactly you deleted. Okay, see, that's why it went for the terminating. The moment when it got terminated, nothing happened. Another pod came up. See, another pod came up which is in pending. After that, container creating. Finally, it is coming to the running. But don't think like why terminating in between. If you need to double check this one. D5Q is the one which you deleted. The same status is continuously coming up, okay, until it got deleted permanently. Okay, so meaning that time to time you can see what exactly the thing. So one pod is going out and parallelly another pod is coming up. So that's what exactly you're seeing. So if some pod got deleted accidentally also, we no need to worry at all. It will work for sure, okay, without any issue. So that's the point exactly you need to keep in your mind. Alright, team, so that is the exactly the basic thing first you should understand about your deployment. Just took the NGINX, that's the thing exactly, just want to explain you on few commands on the deployment part, team. Okay, now it's time for us to understand our actual application. Okay, now when it comes to the actual application, is there any major change or almost same? Almost same, so you don't need to worry at all. So now what exactly the thing you need to understand? Let me go back to your repository. What are the repository we have? I'm just going for the repository, team. So we have one of the repository. I'm just going to the repository and I will show you what exactly we need to take care when it comes to our actual application. Okay, that's the thing exactly we are simulating now, team. Alright, just go back and just go to the repository, team. This is the repository which you can consider, I think, the main project one, right? I'm just taking one of the main project repository, their deployment YAML. So one of the YAML which you can consider here. Okay, awesome. I'm just copying this particular YAML, whatever the thing you are seeing at the moment, okay? Better let me clone the project to your VM, team, okay? Let me simulate this one as a Kubernetes admin from the VM point of view so that I think you can understand easily things, okay? I'm just cloning the project, okay? I'm just cloning the project to the new virtual machine, whatever the virtual machine we have, okay? I'm just going here, okay? I'm just clearing the screen, okay? Git clone, I'm just giving this particular project, I'm just cloning the project, team, okay? And it is asking the password. You just can provide the pat token, what are the things, or what other thing got generated, you can use that when it got cloned. That's it. So your project got cloned. That's awesome. So if you come to the project, there you can see middleware UAT deployment YAML. Especially this is what a deployment YAML is. This is what deployment YAML. So now my point is, see, you're already seeing this one as a deployment YAML. And don't worry on few things here, because let me explain you very clearly. So don't worry on few things, especially when it comes to the environment variable. It's too early to understand for you to understand the environment variable, but remaining things are okay. Just forget about the environment section, okay? I'm not explaining you the environment section, just ignore this one, okay? Alright, team, let's compare whatever the deployment we made and whatever the deployment we just downloaded. So let's compare, let's try to understand what exactly the major difference here. See, API version kind metadata, this is a normal thing only. There is an additional one which you are seeing as a namespace. For the moment, I'm just deleting this one. I'm not explaining what exactly the namespace for you. The namespace is the one, it's a logical separation in the Kubernetes where, for example, team, in real time, for example, you have some 10 services as part of your project, and another project is also planning to use same Kubernetes cluster, for example. But when project A, project B wants to share the same Kubernetes cluster, but you want to separate logically the spaces between these two. At that particular moment only, we will use namespaces, okay? Namespace. I will use the namespace when I'm dealing with NGINX, but wait for a while, okay? Don't go for that. Alright, at the moment you are saying name and label app name same as it is. I don't see any difference, that's okay. Just go for the spec section, replica is 2, that's okay. Selector match label app middleware. These two must match, okay, it got matched, it's awesome. And I'm just going for the spec section there is a container section where you're saying some container name is middleware. On top of it, you're just telling something. This is what container registry name team, right? You need to give your ACR registry name team. That is your job. You should provide your ACR job. That's the thing exactly you're saying. That's really good. And finally, Environment section ignore for now, because environment section, because your application may require some database. That database requires some parameters. You need to pass the parameters also to your application, right? That's what exactly you are just making here. But don't worry on this, because I will deal this one in the secret AML when we are discussing about the secrets. Okay, not right now. And just go further, team. There are ports which you are seeing, container port at 8080, which you are exposing. And one more interesting one, image pull secret is one of the thing which you are seeing at the bottom. But I don't see image pull secret here. But I am seeing additionally image pull secret as part of this particular. The environment and image pull are the difference. But why we are seeing this one? There is a difference. You pull this particular image from Docker Hub, agree? We all pull this one from Docker Hub, but you are pulling this image from Azure Container Registry. Azure Container Registry is not for public. So obviously you need to give the credentials accordingly. If you give the credentials, then only it will be pulled. How you will pass the credentials? By using this particular secret. You will pass the credentials. Alright. So far our understanding is good. Only on two gray areas here. One is environment, another one is image pull secret. Let me explain the image pull secret one more time for you. Okay. But rest all same, everything got matched. That's really good. That's really good. Everything got matched. For example, team, let me explain you this particular scenario by submitting directly what are the errors you will get. Okay. First and foremost thing, what are the deployment YAML you have? What are the deployment YAML you have? Just coming here, kubectl -apply -f. What are the things are there? Just YAML. What are the YAML? I've just drag and drop. Just hit enter. Something got created. A middleware also got created. When it got created, team, just go for the kubectl get PO. I'm just going for the kubectl get PO. Now you're seeing there is a error. See, these are really very important, team. That's why I'm just making failed first. We will understand failure to success call. Okay, I don't want to make it pass directly. You should understand why it failed. That kind of things are really required as an admin point of view. Alright, so if you see this particular thing, invalid image name. Now the question is how to understand more details about this error. That's exactly the question here. How to understand more details. What is invalid image name? See, that itself is telling different meanings, right? We don't know exactly the root cause here. To do that, you need to apply another command, team, kubectl describe. You cannot check the logs, team. For your information, I'm just telling you cannot check the logs. For example, if you are intent to check the log, kubectl logs, if you just go there and enter, what exactly the thing you are seeing, team? The middleware part is waiting to start, meaning that your container start. If you really your container start, then only you can see the logs. But problem is container itself is not yet started. No. You cannot check the logs. So option B, you can go there and check, go for the describe. There is an option kubectl describe PO. You need to give the command part and copy the pod name and just press enter. That one will give you the clear information about what exactly the problem happened here, team. If you read this one, invalid image name, you can see very clearly, team. It will tell you successfully assigned, failed to apply default project ACR, Azure Docker, build number. Your build number is hard coded. We don't know, couldn't pass image reference. We don't know what exactly this reference format. This build number you hard coded. Can you please give the valid build number? Okay, no problem. We have the build number ready. What exactly we will do? We will just go back here to this particular container registry. We have one container registry. We just go back to the container registry, team. This is one of the container registry which I have already. The same thing which we have practiced in your Docker project also. Just go back to the repository section, team. This is what exactly I'm talking about. There you can see something called backend Java. So I'm just going for the backend Java. If you go for the 514, I believe, please double check whether this is exactly the path you are using or not. See, I believe ACR.io, Docker-Spring Boot. Okay, there is another one which I'm using that particular thing. Okay, no worries. You just go there. Just go there, team. Okay, Docker-Spring Boot only, no problem. And also you are seeing a tag. You are seeing a latest as the tag. That's really good. You just need to give the latest instead of the build number. Okay, I'm just removing this particular thing, team. I'm just giving latest. Okay, just save it. Just save it, team. Okay, all right. Now, what exactly the thing? Okay, so whatever the deployment you did, that is absolutely not good. Okay, so to delete the deployment, kubectl get deployment, team. Okay, kubectl get deployments, and also see you are seeing two deployments. One is NGINX, another one is middleware. Now I'm deleting the middleware deployment. Kubectl delete deployment middleware. Whatever the middleware is, I'm simply deleting this one. So once you delete it, It will not come automatically. Please understand. Deployment will not come automatically. Pod only will come automatically. So now what you need to do, kubectl apply -f. I'm just bringing up the middleware UAT one more time. Just press enter this time. One more time. So once you are here, kubectl get PO. I'm just double checking the logs one more time, team. See now this time error image pull. Okay, earlier what was the error? Invalid image name. Now I am seeing error image pull. What is this problem now? Okay, let me go back. Just to clear the screen on the top so that we can play here, team. Okay, now you are seeing image pull back off. Okay, error image pull back off. Some error is keep on moving here, right? So see, error image pull came again. So what is this about? Again, you cannot check the log because container is not yet started. kubectl only option for you. Describe PO. You just bring this particular part, team. Okay, whatever the part is, just go there. Now I'm seeing something failed to pull an image. It's the latest one which is considered failed to resolve the reference, failed to authorize, failed to fetch anonymous token, unexpected status get request 401 unauthorized. Okay, this is the exactly the error you are seeing at the moment, team. Okay, so now the point is when you see such kind of error, what exactly we need to do now? Okay, what exactly we need to do now? What exactly the thing we need to do? I just pasted the error message in your chat box also. You can take a look on that. Alright, so now once you are seeing this particular thing, I'm just clearing the screen. Oh, sorry, yeah. I'm just clearing the screen. What of the screen? I just cleaned it. Alright, so now the point here is, now what exactly you're doing, Let me go back to the diagram and explain you. Okay, what exactly you're doing, let me tell you, team. By using this particular Kubernetes, by using this particular VM, and there is an ACR, okay, there is an ACR. I'm just bringing up Azure ACR. Azure ACR is the Azure Container Registry. I believe it is not identified well. Let me go for the better icon. Okay. Yes. So this is the ACR. Now what exactly the thing I'm talking about? This particular ACR. What of the ACR is there? You have an image here. And whatever the deployment manifest you are doing at the moment, I'm just taking this particular thing as a manifest. Okay. Okay, what are the manifest you are taking, which is a deployment manifest. This particular manifest, what are the thing you are seeing at the moment, that manifest is referring your container registry. That's the thing exactly. So far you understand. The moment as an admin, the moment when you are submitting this particular manifest to this particular Kubernetes cluster, then this manifest is really demanding an image to be downloaded into this Kubernetes cluster. This is the scenario exactly happening, team. This is exactly the scenario happening here. So it is trying to download. When it is trying to download, now what is the problem you are getting? So the problem here is exactly what are the manifest you downloaded. This manifest doesn't have the proper credentials to pull this particular image. Now we should pass the credentials. How to pass the credentials is the one now we will see. You just go back to the Azure documentation. You can go for this particular Kubernetes ACR secret. Okay, you can check for this particular link, team. Okay, there is authenticated Azure Container Registry. See, pull an image from Azure Container Registry to a Kubernetes cluster using pull secret. So you can use this technique. What are the technique which I am showing on the screen? You can comfortably use this particular technique, team. Once you are using this particular, it's easy to understand. You just go there. There is a command. This is the command exactly I'm talking about. Now I'm just going there to the online notepad. Okay, online notepad. I'm just going for the online notepad. If you go back to the online notepad, team, so now what exactly the thing I'm just talking about, you just come here, I just go there, you just go there and paste over there. So for example, you need to fulfill the command. How to do that? First and foremost thing, you need to give on secret name. Okay, I'm interested to give the secret name as, what are the secret name you are seeing? ACR-secret. Okay, you can give anything, team, not an issue. Not an issue, you can give anything. ACR-secret is the one exactly I'm using. So this is the one exactly I typed. Okay, alright. Then namespace. Namespace is the one I told you already. At the moment you are just doing each and everything on the default namespace only. So I'm just removing this particular namespace. I'm just removing this particular thing as default. Okay, alright. And also Docker server. Now you are seeing Docker server, login server. I'm removing the container registry, whatever the thing you are just seeing at the moment. I'm just deleting the name. Once you delete the name, you go back to your container registry. There you can see your Docker server name. Okay, you just go to the registry and go for this particular access key stream. Okay, somewhere here you can see login server you can see. So login server is project 23, project ACR 23, azurecr.io, right? You just go back here. I'm just giving same value here also. Awesome. Once you are done, Docker username and the Docker password. You just come back here, team. There is a username which you are seeing. This is the username. You copy this username, whatever the thing you are seeing, and go back to the notepad and just come back here and you just give the username here in place of that particular value. And there is a password which you are seeing. Just click on this particular thing and just copy the password. Either anything is the password or password to anything you can copy this particular thing. So what are the thing I am showing on the screen, team? Okay, this particular thing you need to copy. Okay, go back to the notepad and you just come back here. You just give this particular value here. If you recall, in our app service project also you did the same thing, but you passed everything on the app service configuration. But you are passing this particular thing as a Kubernetes secret now. Just copy this particular command, team. Just copy that and go back to the Visual Studio Code. Now I'm just going with the Visual Studio Code. Just go there and just paste over there. I'm just Control-C, Control-V only, team. Okay, just press enter. That's all. Once you are done with the creation of the secret, now you need to see. Now you created a secret. Now go back to the architecture one more time. Okay, go back to the architecture. So now, once you go back to the architecture, yes. See, now you deployed a secret inside this particular Kubernetes. But you need to tell your manifest, please use that secret to pull an image from here. You need to inform. How to inform? That is the thing exactly you are doing here. Go to the Visual Studio Code. At the bottom, image pull secret name, ACR-secret. The same name you also created. So that's why you don't need to do any changes. Same name only you are also using. So the same name you are using. So now your manifest will use that secret to pull an image. One more time, team. kubectl get deployments. Okay, deployments. kubectl delete deployment. Okay, deployment. Just go there, copy this particular middleware, just delete the deployment. Once this is done, just go for the kubectl get PO. Simple, get PO. Now you deleted the deployment. Sorry, you haven't applied it, right? kubectl apply -f. Just bring this particularly this time one more time. Just submit one more time. kubectl get PO. That's the thing exactly you're seeing. Okay, our error got changed now. Now we are seeing a different error called create container config error. What is this error about? The create container config error is the one exactly talking about, especially if you have some configuration issue. What configuration is being missed out here? If you open your deployment YAML, we never talked about environment. We never care whether these values are there or not. That's the problem, next problem now. That's exactly the problem. For example, I'm just going to clear the screen and check the parts one more time. Create container config error is the one exactly you're saying. To fix this one, you should understand again about how to pass the environment variables for the deployment. Thank you for the session. See you in the next part. Welcome back, team. So fine, team. So we understand how to pull a image from ACR to Kubernetes. Now we need to understand furthermore, when we deploy a container, especially team. So when we deploy a container into the Kubernetes, we faced an issue called container creation config error, right? So that was the issue. Let me simulate the same thing and we will proceed from there onwards, okay? We'll proceed from there onwards, okay? Alright, team. So fine, our cluster is ready. And also, I just want to discuss with you first one thing. Did I show you how to connect a virtual machine via Visual Studio Code? Anyway, I will show that option first quickly. I'm not very sure whether I showed or not. I will show that option first, team, okay? So, first what you need to do, just a second, team. Yeah, so what we need to do first, I believe, please install the Visual Studio Code in your machine. I'm showing an option how to connect a VM via Visual Studio Code. If I already showed you, you can ping S in the chat box so that I can ignore this one, okay? Okay, so what exactly the case here is, team? Please install the Visual Studio Code in your machine. So just go to the internet. There you can see an option called Visual Studio Code download. Just go there and search for this. There you can see download links. Here you can download corresponding to your VM configuration and machine configuration. You can go for this particular link. That is one thing. Once you download the Visual Studio Code, team. So what exactly you need to do? You go to the Visual Studio Code. Once you open the Visual Studio Code, let me open the Visual Studio Code. Yeah, this is what the my local Visual Studio Code looks like. Step number 1, what you need to do, you just go to there is a plugin section. Okay, this is what the extension section. Please click on the extension section. When you click on the extension section, please search for SSH. When you search for the SSH, it will show you remote-SSH option. Okay, remote-SSH option. Please select this option. There you can see a button called install button. Please install that one. So that's the first step which you need to do. Okay, alright. Once you install this one, once your process is done, what exactly the new thing you can experience here is that the left bottom corner you can see a 2 arrow symbol. Here I believe you are seeing a arrow symbol. Left bottom corner. Let me see what of the screen you guys are seeing so that I can easily understand. Yeah, whether you are able to see or not. I believe it is not visible for you. Just a second. Yeah, this is the one exactly I'm talking about, team. Okay, there is a left bottom corner. You can see 2 arrow symbol pointing each other. Okay, you click on that. When you click on that connect to host, there you need to configure your virtual machine. Go to configure SSH host. There it will show you a default path in your machine. Please click on the default path. Once you click on the default path, here is the section, config section. Exactly, you will configure your VM. Is simply what exactly you need to do, I will tell. The host can be anything, this name can be anything, that is your understandable format. And also host name, this IP must be the same one whatever you are seeing on the portal. So please use the same keys, host name. Use keychain means you are not using any key based approach. If you key based approach, I will show that one tomorrow, don't worry. But if you are not using key based approach, just keep no. And there is a user which is Azure user. And the port, right? That's all you need to provide him. Okay, I'm copying this section to you in the chat box. These are the setups exactly you need to do. Once you are done, just save this one, Ctrl S. Then again come back to right arrows and go to the connect to host. When you click on the connect to host this time, team, what exactly the change you can notice here is it will list you what are all the VMs you configured. That is what this host section. Okay, it will list you. You please go there, for example, AZ-VM. When you click on that one, automatically it will start forming a connection. And it will ask you the password to key in because your VM has a password today. Okay, it will just ask you, team. So what you need to do, you just need to provide a password for that one. That's it. Okay. So once you provide the password, team, so now good, right? See, you got connected. Now you just click on the open folder. You're trying to open the folder called home Azure user. Okay, that is what exactly you're doing. So when you are opening this one, sometimes it will ask you one more time. Please key in the same password, team. Okay, that's it. So once you provide, you are inside a VM. Okay, you are completely inside a VM. To know that whether really you are inside a VM or not, just a moment. To know that whether really you are inside a VM or not, I believe you can see this one. Yeah, you can see this one. If you plus open this one, there you can see especially. You can sense here. Okay, you can sense here. There you are seeing a lot of things here. So whatever your VM folder structure, directory structure, completely in the UI format. So that is exactly the benefit you will get, team. Okay, a UI format of Ubuntu you can see in a UI visualization. Okay, that's exactly the advantage if you use the Visual Studio Code. So you can see all the folder structure on the UI, a kind of UI visualization, right? That's an advantage. Alright, team. I just start to show you so that I think we can make a connection to virtual machine via Visual Studio Code. Okay. Alright. So once you have connected to the VM, click on the terminal section. This is exactly the terminal. How exactly you are experiencing your terminal section, a command line or putty, the same connection, team. This one also username at the rate virtual machine. Okay. Alright. So once you are here, what exactly the problem we are getting now? So first and foremost thing, let me double check whether your Kubernetes cluster is on or not. Okay. kubectl get svc is the command to know whether your services are being run or yes, of course your cluster is on. Once your cluster is on, what exactly I'm suggesting you here, you can go there and you can check your parts. What are the parts earlier? I think you tried to place here. Okay, kubectl get parts. This is what exactly I'm trying to highlight. Last time when we deploy our middleware part, we deployed our middleware part, especially our AML. What are the part manifest AML, right? We have deployed that one manually. Correct, team? This is what exactly we took some deployment.aml. We filled this one, right? We filled this one. We pull the image into the Kubernetes, but we are facing an issue called container configurer. Why we are getting this one? Remember one thing. Whenever you face an issue in real time, firstly what you need to do, first you please go there and just describe it. That's a basic rule, team. Okay, describe PO. Okay, just go there, describe PO. You please select your part name. This is my part name. I'm selecting this one. Sorry, I think you selected wrongly. Just go there one more time. kubectl describe PO. I'm just selecting the PO. That's all. Okay, I believe. I think let me zoom out. Okay, just a second. All right. Okay, just a moment. So I just want to highlight you the error here. So what exactly it is telling here, team? Just let me take this one up so that I think your visualization would be good. Okay, now I'm just little bit zoom in. Yeah, okay, fine, team. And also I'm just moving this one also this side, so that entire screen you can see this. If you see this one, team, what exactly the problem here? I'm getting few problems here. First and foremost thing. If you see there, you are seeing some warning, normal, warning. So if you notice the messages, successfully pulled image. So that is done already. Okay, you have successfully pulled an image. That's awesome. And also if you notice, whenever this particular pod is getting scheduled, you are seeing a message called secret DB details not found. Okay, secret DB details not found. You know why we are getting that message? There is a reason for that. So we need to fix this one. That's a problem exactly we are getting now. Okay, how to fix this one? So that is also we are going to learn now. Okay, how to fix this one? For example, team, this is what our deployment YAML. This is our deployment section. There you are expecting some environment variable, right? This is an environment variable section. If you close all the environment variables, so that you will get an idea. See, all these are environment variables: RDG hostname, port, DB name, username, password. You know what exactly you are trying to do here? Let me show you on that diagram so that you will get a very good idea. For example, team, let me take a Kubernetes cluster. Okay, I'm just considering a Kubernetes cluster. This is what your Kubernetes cluster. In this particular Kubernetes cluster, what exactly you are trying to do, I'll show you. Okay, Azure Kubernetes. I'm just considering the Azure Kubernetes. Okay, this is what your Azure Kubernetes today, team. Okay, awesome. Now what you are doing inside the Kubernetes? Inside the Kubernetes, you have a node or VMs. Usually we'll talk about VMs, right? So VMs, right? You can consider a VM or something like that. So I'm just considering a VM. Sorry, I'm just considering a VM. Especially those VMs are called as nodes. Okay, please understand. Please understand it. Now what exactly you are trying to do? Let me take another box here so that your understanding would be really good. So this is the box, another box I'm just considering here. And by the way, I'm calling this one A sitting in a zone 1. Under zone 1, you have a virtual machine which is already there. Okay, that is exactly the case you are seeing here. Okay, this is the thing exactly we are talking about. Okay, so now once you have this setup, team, now what exactly the point I'm trying to highlight? This Kubernetes cluster may have multiple nodes also. Those nodes may belongs to different zones. So you should understand that concept. Okay, I'm just considering this one as a zone 2. Okay, this one as a zone 2. So that one is a zone 1 and this one as a zone 2. Now this is zone 1, this is zone 2. Okay, now you please consider MySQL server. I'm just considering a MySQL which is coming from Azure MySQL. I'm just considering Azure MySQL. Okay, but please consider the Azure MySQL server. I'm just considering one server, okay? So under this MySQL server, there is a database. This is a database which is sitting outside the Kubernetes cluster. Please understand. Please understand, team. This is sitting outside the Kubernetes cluster. But your Kubernetes cluster is separated. Your database is separated. Please understand, team. So once you have this situation, what exactly the point I'm highlighting here is, you should think about the pods now. This is the pod exactly you are trying to deploy today. If you try to deploy two pods will go to two different zones. These are nothing but application replicas, your deployment replicas. So two applications are running inside your Kubernetes. That's awesome. What I'm doing here, I'm going here and I'm just giving some color for them so that you'll understand easily. Okay. Alright. So these are the two pods. Okay. This is a pod. This is a pod 1. This is a pod 2 or something like that. So now what exactly the point I'm highlighting, team? What are the pods are there? The pods are connected to MySQL server. Why these things needs to be connected to MySQL server? That's the first thing you should understand, team. So basically, this is what your real-time structure also, team. Please understand one small logic here. So what are the applications you are deploying in the Kubernetes cluster? Always, if you are trying to store some sensitive information or some information about your application, always you look for storage. You can look for storage, a kind of a database is a normal case. Sometimes you can look for either disk or file also. I'm not saying that is not possible. Even you can store the data in the disk or file also. In this example, we are focusing on the database. So pods are writing or reading the data from database. That's a point you should understand. Okay, this is very clear. Now, pod is a Spring Boot application. Now, for the moment. So, Spring Boot application, to connect with your database, Spring Boot application requires connection strings. That is what your database strings. That's the basic rule. So, how you can provide the connection string to your application? That's the next important challenge. So, in Kubernetes world, either first you can directly keep your information inside your application, but which is not a recommended approach. If you keep something inside your application, let me tell you the scenario. If you keep something inside your something inside your Spring Boot application, hard-coded, definitely your hard-coded parts definitely will try to connect. But that is not at all a good approach. Because, firstly, you are keeping your sensitive information directly as a configuration of your Spring Boot application, which is wrong, which is not a good one. So it's always recommended to keep your sensitive information either in the Kubernetes secrets or Azure Key Vault. Even I'm telling you about Azure Key Vault also. You can make use Azure Key Vault also to just store your sensitive information. But for now, let's try to assess how to store secret information using Kubernetes secret ML. So firstly, to do that, I have the pod deployments, but I don't have the database. Let's go there and browse in the database quickly, team. So just go to the portal. There you go for the MySQL. You can open any of this database, not an issue. We are trying to open one database, okay? One database. You just proceed further. You can open the flexible server. That is fine. So once you are open this one, team, there is a resource group which you can think about. For example, usually you will apply under AJ-RG -22. I think you can take anything. AJ-RG I'm just considering for your case. I'm just giving here Kubernetes. Don't give the Kubernetes information. Maybe you will be confused. I'm just giving project-db. Okay. I'm just giving a name called project-db. And go for this one. I'm trying to provision this one in the Southeast Asia. Let's see whether this is possible or not in Southeast Asia. I think last time it has not allowed me. Do you want to allow it? So I think it is not allowed to provision in Southeast Asia. Yeah, I have a problem in Southeast Asia DB provisioning, okay? I believe it's not allowing me. So what is the technique you should use, team? Yes, you can use a technique called, you can keep your database in the East Asia. Okay, alright, not an issue, team. Not an issue. You can keep database in the East Asia. Okay, then I'm just going for development hobby project. Available to join, I'm just keeping, these are all things I'm just keeping with the minimal configuration only. SQL authentication is the one exactly I'm talking about. CP admin, I'm talking about GP admin, I'm just giving some password, okay? I'm keeping some password. I'm taking the confirmation also on the password. That's all, team. Go for the networking. Networking, here you can see this is a little interesting one, okay? If you keep the public one, definitely your Kubernetes cluster will connect, okay? Without any doubt, right? Allowed at a private endpoint. You can keep the private access also. Even that is also absolutely possible, team. Okay, absolutely possible. So that is your call, which one you want to go. But my recommendation is the private access. Okay, please go for the private access. If you do that, I believe you have some subnets in the Southeast Asia. Sorry, you have some subnets in the Hong Kong region. I believe. Please go there and select one particular any of your VNet. Okay, I'm just selecting one VNet. One DB VNet is already there. Azure VNet-HK. I'm just selecting one particular subnet for the database. Rest all same. Especially the private DNS zone. If you want to create a new private DNS zone, you can. I'm just creating a new private DNS zone so that you will get a very good idea, very good clarity. That's all. Once you are done with this thing, just create the MySQL Flexi server. I am going to give you a concept here for you. I believe I already gave. You should tell me now. This time, you're already smart this time. I'm just keeping a region here, team. I'm keeping a region, okay? For example, now your case is little bit different here. So whatever you're thinking about, your database is sitting in the HK region, team. But your Kubernetes cluster, what are the Kubernetes cluster you are planning or you are thinking, this Kubernetes cluster region is bit different, okay? This Kubernetes cluster region is a Southeast Asia region, right? So there is a difference here, team. Please understand. So now the challenge or problem here is, team, there is one problem, okay? What is the problem? So cluster is sitting in one region, cluster is sitting in one region, and database is sitting in another region. You know what to do. I gave the solution already in your previous project, okay? I gave the solution already. Okay, so now what should we do? So what exactly we should do here, team? Firstly, let database to be provisioned. Private DNS zone got introduced. For that private DNS zone, you need to add a Singapore region VNet. That's all you need to do. You need to do VNet linking, followed by VNet pairing. That is all you need to do. Then automatically connections will be formed. You remember, right? VNet pairing and the VNet linking are needed, okay? Are needed. Those two are the steps we need to follow. So wait. So now what we will do, once your database is ready, then we will try to form the connection accordingly. So usually before it gets ready, I want to introduce secret YAML specially. I need a secret file which consisting of these 5 attributes. So to create that one, team, I'm just going here in the Visual Studio Code, click on the plus symbol. You can type the secret.yaml. Okay, you can type this one or something like that. When you click on the secret.yaml, so here is the one exactly. You need to give a proper syntax. Again, same thing. API version, kind, metadata, spec is a common thing only. If you refer here, instead of spec here, you can see string data. So if you refer this one, team, API version, kind, metadata, this is what exactly metadata, label name is DB details. And also the type opaque means you are going to store this particular data in a key value format in the etcd server. Now you don't know what is etcd server now. etcd server is a database in the Kubernetes which can store all your cluster information, cluster state, all your sensitive informations also. You will understand more when I'm describing about your architecture, okay? So, but now what you need to understand, etcd server is holding, etcd is a kind of a database which can hold all your sensitive information in the key value format, and also it can store your cluster state, pod, service, each and every state it can store. Alright. So now team, once your secret YAML is placed here, now a little change you need to do. You know what exactly you need to do? You go to the browser. I believe I'm just waiting for this one to be provisioned. The reason for that one is I'm going to get the details from this MySQL server. So what you need to do team now, you just come back here. Let me fill few things because I already know. Especially I think username, password are same. I haven't changed this one. Now another interesting thing, you should understand this logic. RDS database name, hey, how do you know database name is todos? How do you know that? Because username, password you know because you provision. Port you know that is the default port which it will listen. But which database you should configure, how do you know? So to understand about the database to be configured, you should get a knowledge on your application what you are deploying. If you recall team, if you recall our Spring Boot application, whatever the Spring Boot application we did, okay? If you recall that particular approach which we did in one project, if you go to the repository, I will show you the technique, okay? If you open the, okay, this one is fine, more than enough. Open the SRC, open main, open resources, open the properties file team. When you open the properties file, they are always looking for a database called todos. Please understand. They are looking for a database called todos team. So that's the catch exactly I'm highlighting. So they are looking for a port called 3306. They are looking for a database host name called MySQL. If you don't define this variable, this one will be picked up. Don't define this variable, this one will be picked up. You don't define this variable, this one will be picked up. So that's the meaning for this one. So now what should we do? Even here also, username, password case also you can experience the same thing team. But this and all, why they place this kind of approach? Why they want to use some dummy values? These dummy values are really true when they are building their project local environment in their virtual machine. Because the local environment will use these variables to form a database and form a connection. So that is why they kept, if it is a dev or UAT or pre-prod, correspondingly variables will come. If it is not, it correspondingly localhost will come. That's only the logic here team. Alright. Now, I believe by this time it will be ready. I don't know why it is taking too long. Just we'll wait for a few more seconds. Yeah. So once your secret YAML is ready team, okay. So what exactly the changes I need to do, I will tell here. Firstly, I need to modify the host name, and then port is same, and database I need to create, because you are provisioning a server now. On top of it, you need to provision a database. MySQL server you are provisioning now. So on top of it, you need to provision database called todos. Once you are done with everything, then you submit this one. Then you will go for Kubernetes pod restart. That's it. That's it. Your problem, you should not see any kind of secret DB details not found or any kind of some config error. Okay, that error should not come team. That is the expectation first. First we deployed the pod, then we are deploying the secret so that your pod and secret will be there. Then we will go for autoscaler followed by the service. That is the sequence we will follow team. Okay. Awesome. So your deployment is okay. Now you just go there. Interesting facts I will tell. So firstly what we need to do team, you just go there to the server name. Please copy the server name. You just come back to the Visual Studio Code. Please fill the server name here. Okay, once you are done with this thing, there you can go for, there is a port, there is a database name, username and the password, right? Especially database name is there. Copy the database name. Under this particular left section there is a databases, right? click on the databases, click on add button. Under the name, you just paste the to-dos. That's exactly the thing you need to do. What you did, you created a database inside a server. That's the thing you did, team. So once this is ready, what exactly the thing I'm recommending here is, go to your virtual machine, fill all the values, okay? Fill all the values, that's all your case, okay? So now, I'm just going to the virtual machine. Under the virtual, let's go to the virtual machine, team. Alright, I believe rest all will be same as it is. Once you have done with this thing, go to the terminal. Especially I'm just clearing the screen. Better you just make a bigger screen. Just clear the screen so that it will be very clear. Now, what are the secret YAML is there? What are the secret of kubectl? Apply -f. Just drag this one there. Just drag it. That's all. So kubectl -f. Just you are providing the path. That's all. Just press enter. You know, secret DB details got created. Now what you should understand here, team. kubectl, especially get PO. If you apply the kubectl get PO, the moment when you see, okay, something came to running state. Let's try to understand what is this one, okay? kubectl describe PO. So the moment when you give this particular, describe this particular PO, remember one interesting thing. When your parts are running, you no need to describe it. You can check the logs directly. But when your parts are not running, anything, not only parts, service, or secret, anything, you can describe it to know the root cause. If I describe it, everything happens successfully only. Everything happens successfully only. So let's do one thing. Let's try to double check the case one more time. Let's try to double check the case one more time. kubectl get PO. That's the thing I'm just giving running. But it is going for a restart stream. There is a problem again. I believe you should understand this one, okay? There is a problem again because it is going for the restarts. So when it is going for the restarts, the problem here is, something is wrong happening in your application. To know the problem exactly, kubectl logs, you just go there and just provide this particular middleware. Just give this particular logs -f to just see the running log. Just go there, team. You see this one awesome. You're seeing an error here. You're seeing this is what your application pod logs, okay? You're seeing an error, a communications link failure. That's the problem exactly, team. This is nonsense, right? So some connection is not there. You know already what you need to fix. So the problem here is your DB is sitting in another region completely. Your cluster is sitting in one region. That's the problem here, team. So to fulfill this gap, to fulfill this gap, then what should we do? What exactly we need to do? You know VNet peering, you know VNet linking. You need to apply the technique, then you can solve this case, team. That's exactly the thing you need to proceed. That's all. If you do that, I think your problem is solved, okay? That is what we need to do. So to do that, what exactly your recommendation? My recommendation is go to this particular thing and go back here. Please understand two things before proceeding further. First, where exactly your database is sitting. That network is required. That network is really required for you. What is this network name? There is our AZRG VNet-HK. Okay, awesome. There is one more technique where your Kubernetes is sitting. This is not so direct, team. Okay, if you come to Kubernetes and open the Kubernetes, you will not see what exactly the virtual network here. Please understand. You will not see, you cannot understand, where exactly I deployed. To know that, what you need to do, you need to go inside a node pool, team. Okay, please go inside the node pool. If you go, because cluster means it's a collection of nodes, okay, where you deployed the node pool is the matter. So for example, okay, just a moment, okay, some error I'm seeing here. Okay, it's okay. Let's fix this one bit later, don't worry. So now what exactly I'm looking for, click on the agent pool. Once you click on the agent pool, team, you can come back here. Somewhere you can see, see this is the virtual network, project-vnet-az. This is your Kubernetes virtual network. Awesome. I'm directly clicking on the Kubernetes virtual network. Now, once you hear step number 1, I told you peering, right? click on the pairing, click on the add button. So I'm just giving SG to HK, okay, something like that. Okay, everything I'm just keeping as it is. Okay, this may be not required because these options newly added team I haven't explored. Maybe I will double check these things later. Okay, copy this, just give this one pairing link name. There I'm just going for the virtual network link. Here is the one exactly you need to check your HK one. I believe I do see only one HK. This must be ours. Okay, select that one team. Okay, alright, so once you are done, just click on add button. 2 entries will be there. VNet pairing is awesome. VNet pairing is formed. What is the next important thing you need to do, team? After VNet pairing, you need to perform VNet linking. To do VNet linking, you need to go to private DNS zone. Correct? You need to go to the private DNS zone, team. Please go to the private DNS zone. There you can see one particular option called project-db. This is what your database exactly you created just now. Correct? Project-db. Just go to the virtual network team. Just click on the add button. See HK we got added. This what see wherever your database is sitting, that VNet will be automatically added. That's exactly the technique in the private DNS zone. You just come here, click on the add button team. Now you just come here. I'm just adding a cluster VNet. Okay, cluster VNet. Just come here. There is a virtual network which is a cluster is sitting. Can you please identify that one, team? Yeah, project-VNet-AZ. That is exactly the thing which you can look for. So I believe once you are done, I believe it should be fine. I'm just creating this particular virtual network link. Okay. So once your virtual network link is getting created, team, you know what will happen? That is what exactly you form the connection really well. Now you can proceed and you can go there and you can proceed to restart your parts one more time. If you do that, your problem is solved. You go to the Visual Studio Code, just going for the Visual Studio Code team. Okay, this is a communication link failure, meaning that it was unable to form a connection. You just go there, clear it out. kubectl get PO. Okay, get PO. I'm just applying the get PO. See, it is waiting for the crash loop back off. You know why it is going for this? Because of your only the issue, that particular DB connection issue is one thing. And also I just want to describe one more thing also. Let me double check, because crash loop back off could be the reason which comes from the describe also. We'll see the reason here. Is there any problem is additionally coming here or not? Pulling image is okay. DB detail secret only the issue it is showing still. No, I think no worries. I think let's do one small activity, team. Now what exactly I'm going to do? I'm just going for the terminal. One more time, sorry. I'm just going for the terminal. Here I'm going to make the deployment one more time. kubectl get PO. You are seeing two parts here. So technique number 1, kubectl delete PO. Now what exactly I'm doing? Copy this particular part, place and space, and copy the second part also. This is one technique which you can make sure. So the two parts will be deleted. The interesting fact here is the moment when you delete a part, the controller manager immediately will check, okay, someone deleted the part, but my deployment is stuck. You have not deleted the deployment. Please understand. You have not deleted the deployment. kubectl get deployment, your deployment is telling still 2. So immediately controller manager will run two parts here. Okay. kubectl get PO -w. -w refers to watch. So two parts came back again. Now since it's running, you don't need to watch because it came to running again. So now I'm going there, I'm just double checking kubectl logs, just selecting this particular part, there's -f. Okay, let's double check. See, if this is form a suitable connection with the database, your task is done. Especially you know what you achieved, team? You achieved how a Kubernetes pod is connecting to the external component called database. That's the thing exactly you achieved at the moment. Oh, this is awesome. Once you achieve this one, what else are still pending? So those things also you should understand them. Okay. For example, I'm just keeping this one also here so that you will be very clear on how exactly these things are. Because this is what exactly your production equivalent configuration. Or something like this. So meaning that all your parts, whatever the parts you are thinking about, all the parts are pointing to your database only. Okay, this is the case exactly you need to think about. So That's awesome, team. That's awesome. But so far, public cannot access your application pod. That is impossible. He needs to come first inside the virtual network. He needs to come inside the Kubernetes cluster. He needs to come and access this application which is sitting in a different nodes. This is not possible. That's where the services are really helping you. Now services are really helping you to expose this application to the external world. So that is what exactly the services are helping you, team. Alright, team. So for now we have cleared our secret ML. That's awesome. And also which is pending at the moment. If you notice your service, especially if you notice let me open your Visual Studio Code one more time. There I want to highlight a deployment YAML. If you check the deployment YAML, team, so what are the deployment YAML you are seeing? There is a deployment YAML, right? Yeah, this deployment YAML. If you see the deployment YAML, team, here there is no service section. There is no service section. Everything you can deploy at once. Now I'm going to take one more file called svc.yaml. svc.yaml. This is what the service section. Now what is the service section? Now you go back to your screen. Whatever the screen you have in the browser, team. We have the application ready here. You go to middleware-uat YAML. Scroll down. This is what exactly the service we are talking about. I'm simply copying the service. You just go to the Visual Studio Code. Just paste here, team. Just paste here. Awesome. Now the problem here is, team, you are trying to create a service. Please understand. Why we need service, team? We need service to connect to the external world. Please understand. Sorry, yeah. So what exactly the problem you are getting now? You don't know how to form a service YAML. So that's exactly the one more problem which I am noticing. So especially, team, in this particular case only, you should understand about the labels. That's an interesting fact, okay? Labels. Now, if you see this manifest, API server, kind, metadata, spec, a common thing only. These are the common thing. If you open the spec section, under spec section, you are seeing selector. You are selecting an app called middleware as labeled. That's the point you should understand. So it's a condition, team. It's a if condition, okay? If label as app colon middleware, I'm capturing that particular part. That's what exactly you are highlighting. Please understand. That's what exactly you are highlighting. But what does it mean? So now, if you see the scenario, team, okay, let me come back here. If you go to the deployment YAML, in the deployment YAML, team, if you understand one particular technique, okay, let me show you the technique, okay. So this is what the label section, and again you have formed a match label section here, right? And again you have formed another label section here, okay. So you should understand these things clearly, okay. Just let's assess the case. Okay, let's assess the case. What exactly you are doing? You know, replica set is working on the selector label app colon middleware. This is trying to match with this. Whatever the thing you define here, you need to give the same thing here. Then your two deployment replicas will be launched. That's awesome. Same label. But when you go for the service, how exactly that works here is, under the pod template, you have defined a label called app colon middleware, right? The same label you should refer in the service. That's what exactly you are referring to. See, that is what exactly you are referring, app colon middleware. So your service will identify wherever the pod named as app colon middleware. For example, let's go for the diagram. In this particular diagram, what exactly I'm talking about, this is the label exactly you have used it so far. That's exactly the catch you should understand, team, okay? So I'm just discussing more on the label side, okay? More on the label side. So if you take this particular connection, I'm just taking this particular label. This is exactly the label will be there for all these pods, right? This pod also will be the same label on, because that is coming from the pod template. You should understand that technique, okay? So that's the label exactly been there. Now you are forming a service by matching the label. Now you know what exactly you're trying, team. You're forming a service, okay? So this is what exactly you're doing. This is what exactly you're doing. This is a service, okay? SVC. This is an SVC. So SVC refers to service. So this is the service exactly you're talking about, and this service is responsible to just capture your parts. That's a technique. That's exactly the technique of capture your parts. How exactly it is discovering? It is discovering your parts based on only one technique. Based on only one technique. That technique is called a labeling technique. Okay, please understand. That technique is called labeling technique. Okay. So now, what exactly the point you should understand a bit here. So I'm just let me form the connections first. Okay. Then we will think about the case. Okay. So this is the thing exactly you're talking right now. Okay. Awesome. Okay. So and also this one also I'm just giving. Also I believe that should be fine. So fine here. So this is the connection exactly you're trying to make. Just a moment. Okay, fine team. So now awesome team. So now you know what exactly you achieved. You have achieved the service is capturing exactly your parts wherever those are sitting. Okay, wherever those are sitting. So please understand this, and I'm just raising the thickness. Okay, all right. So this is what the exactly the point you should think about team. Okay. Now service is capturing. Service is able to capture. Awesome. So now this is what the service is doing. Now the service responsibility is to expose your application to external world. So that is what the service responsibility. So now the external world from the user from the external world. Okay, I'm just taking a user. So now easily user can come and user can hit your application by using that particular external service. That is absolutely possible, team. Okay, that is absolutely possible. But the point here is what you should understand. How exactly this particular endpoint being accessed by the user. Okay, that is what we should think about now. Okay, just save this one team for now. What exactly I'm going to do, let me go back to your Visual Studio Code. What exactly the one thing which you need to try here. So if you form this service, automatically it will launch a service. Here is the technique available. You should understand a bit here. Okay, you know one thing, I will show you one technique. If you apply this service as it is, you know what will happen? Let me show you. Team. Okay, one interesting fact here. Okay, Okay, clear. So simple kubectl apply, same command, right? Kubectl apply -f. So whatever the svc.yaml is there, I'm just bringing here. Okay, once you are here, just hit enter. Your service will be created. But what kind of service it is? You know, you already know three services. One is cluster IP, another one is node port, another one is load balancer. But I'm asking you what kind of service it is. Okay, that is exactly the thing which you need to think about also, team. Okay, so how to know what kind of service it is? Okay, so now we should think about this case, team. Okay, we should think about this case. So firstly, what we need to do, once your SVC is ready, kubectl get SVC. Okay, just once you are here, team, here is the one exactly you are seeing middleware. Kubectl edit SVC. I'm just taking this one -o aml. You know what exactly you are trying to do? You are trying to open your SVC and you are trying to edit also. You just open this particular SVC manifest. We are modifying the SVC manifest. Why? If you notice your model, whatever the service model you deployed, that is a cluster IP. Maybe you think I don't require cluster IP. You know very well about the cluster IP. Cluster IP is the one only the internal persons only can communicate. Only cluster components only can communicate. That is what cluster IP. You cannot provide a connection to outside. That is not possible. But you need to provide a connection to outside. Cluster IP is not the correct one. Then you need to go for the load balancer. That's the best case which you can refer. Here, under escape I button, then press I. After that, insert button will be, you can see at the bottom. Now you go to cluster IP section. Just remove that one, cluster IP. Okay, and instead of cluster IP, you just pass the load balancer. Okay, load balancer, and also there is no space. Okay, load balancer, exactly the load balancer is the one which you need to provide. Awesome. So once you replace cluster IP with the load balancer, :WQ exclamation, hit enter. That's it. You know what exactly you achieved, team? What exactly you achieved? You converted your service into the load balancer. kubectl get SVC now. If you try here, it is pending. You know why it is pending? Pending for the external IP. It will bring an external IP for you. That is exactly the connection which you can use to connect from outside. Okay, so that's the point. But to communicate internal components, it will use this IP. But to use the external component, it will use this IP. That's the advantage with the load balancer. So let me go there and try one more time. See, I got an IP. So this IP is listening on 8080. Please copy this particular IP. And also, I'm just giving a quick explanation here on the service one. Apart from the API, kind, metadata spec, your selector, these are missed. Now you can think about. Firstly, you need to understand protocol TCP. That is fine because it is happening on the network layer, level 4, and followed by port and target port are very important. Port is the one which you are talking about. This port is nothing but a service port. This port is nothing but a pod port. If you need to understand the diagram now. So you are listening on the port 8080 on the service. Your pod is also listening on the port 8080. That is what exactly you are telling. See, whatever the traffic you are getting here 8080, pass that one to port 8080 on the pod also. That's the thing too. You know why you need to pass on the pod 8080? If you recall your deployment YAML, there is a deployment YAML for you, right, team? If you recall your deployment YAML, under the deployment YAML, under the spec section, you open the port called container port 8080. So your service is listening on the 8080, your pod is listening on 8080, your container is also listening on 8080. Please understand. So now you can change the ports also, not an issue, team. You can change the ports also. I'm just going to the, I'm just copying the IP. You just copy the IP :8080. If you give the 8080, hit enter. See, this is returning true, meaning that this is coming from the Spring Boot application. You can see the icon, Spring Boot application, where I'm seeing a success call. As an external person should be able to connect with this. That's an interesting fact here, team. Okay. All right. You can also give it a try. You can also give it a try from your mission. It will work as it is. Okay. But I'm seeing a lot of problems here. First one is it is using HTTP protocol. It is not using any domain. It is using a port as exposed. These are all the issues. We'll solve one by one slowly. But what we understand today, we understand the secret YAML, we understand the service YAML. So two things we understand, and parallelly we are doing our practical real-time project also. That is what exactly we are simulating for you. Thank you for the session. See you in the next part. Welcome back, team. Okay, team. Okay. Fine. If you recall our last session, so there an application being deployed and correspondingly a service being launched which is for external world. That's okay. But if you notice the endpoint, team, if you notice the endpoint where you are seeing endpoint HTTP : / or some load balancer, some 13.16.43.222 or something, or some load balancer :port 8080. This is exactly our situation. Now we are introducing multiple services into the same Kubernetes cluster, meaning that there is a requirement in your project where you need to deploy multiple applications. That is where additional connections came here. Okay, so different colors I placed which are representing different applications and different services. Now each and every application is exposing one service. That service is a network load balancer. If you notice the network load balancer IP address, here you can understand few things. Point number 1, it is not a HTTPS. Point number 2, you are using completely IP address. Point number 3, you are exposing a port. So these are all the issues with this one. And also there is a major problem here is, if you want to deploy 3 applications into your Kubernetes cluster, you need to expose 3 load balancers. Again, it's a costly thing for you in your company. Again, you need to bear the number of load balancer. If I ask you, please launch 100 load balancer, 100 services, obviously you will launch 100 different parts in different zones. and correspondingly you will expose 100 load balancers. You need to pay the charge for 100 load balancers, which is very high. So that is why, to address this issue, there is one particular component called Ingress. Ingress in Kubernetes. Okay. So Ingress is the one, exactly the solution for this problem. With the help of Ingress, you can really solve this case. Let me deep dive into the diagram. One more diagram I'm going to draw so that you will get a very good idea. Okay. So far you understand the problem. I'm going to draw the diagram with the help of Ingress. Alright team. So team, now what exactly you need to be very focused here. For example, I'm just taking how exactly the flow would be with the help of Ingress. I'm showing you team, okay, so that your understanding would be nice. Okay, I'm just keeping this one. Just assume these are all the type of nodes only. Just assume. All right team. So fine. So you consider specially. So whatever the type of nodes you have, virtual machines, especially Ubuntu virtual machines, you have as a node pool. That's awesome. Now what exactly you are trying this time? Okay, a little change on your approach. Okay, how exactly you need to attempt this one? But very easy. So basically, you know very well that there is a pod corresponding to the middleware. I'm just giving a pod called middleware pod. Very clearly, I'm just writing the name here, team. Okay, all right. Let's consider two services so that you will have an understanding. Okay, I no need to present multiple services anyway. Yeah, I'm just keeping middleware. That's awesome. I'm going to consider one more. So that particular thing I'm just considering as a some mobility. Maybe just an example. Okay, I'm just giving an example, team. Middleware is okay. There is one more application which I am calling that one as a mobility. Okay, all right. So always we will maintain very high availability. That is why I'm taking 3 parts of that particular application. Okay, awesome so far. So you also need to take the same thing in this particular node also. So far very good. So now what exactly we are thinking about? So far good. If we need to expose a service, obviously we need a service team. Without service you cannot route the traffic. See, if I want to route the traffic equally among middleware pods, you need a load balancer. That is what I'm calling as a service. This time, I'm not exposing your applications as external load balancers. I'm exposing your applications as a cluster IP. Please understand. So I'm just exposing your application as a cluster IP corresponding to the middleware. Okay, cluster IP corresponding to the middleware. So what exactly the point you should understand at the moment, team? What are the cluster IP you are seeing, right, team? What are the cluster IP you are seeing? Or correspondingly one more I'll just draw. So there is one more called mobility. So which is a mobility cluster IP? Mobility, okay? Mobility cluster IP. So what exactly the responsibility of these particularly these services? The solo responsibility of these particular cluster IP is to just route the traffic to the mobility parts. That's all, team. That's our case is very simple. Just route the traffic to the mobility parts. That's it. So now your cluster IP is really solving your case. Okay, you are routing the traffic to the mobility, and also there is one more mobility here. Sorry, there is one more. I think I'm just passing an arrow. For that, I think it's too small. I think that's why the arrow is not coming up. I'm just let me do in this way. Okay, so yeah, all right. Yeah, okay, fine. So that's it, team. So you are routing the traffic. Mobility cluster IP is routing the traffic to mobility parts. That's awesome. That is what exactly you are managing your load. That's good. Now middleware parts are there. Now middleware cluster IP is also there. This is also cluster IP, right? So middleware also needs to deal in the same way. For example, you just go there, you just copy this one, copy this one. So the cluster IP middleware is passing the traffic to the middleware parts only. That is also awesome actually. Okay, so far we understand really well. Okay, so far we understand really well. So far the connections are good. So our understanding also good. Okay, fine. So now what exactly the point you are trying to highlight, team? Okay, there is one interesting fact. Okay, there is one interesting fact if you notice. That is, I'll tell you. Okay, what exactly that one here is? So far good, but the problem with the cluster IP is cluster IP cannot route your traffic. You know that already. Cluster IP cannot route your traffic traffic from outside to internal. A person who sits at the outside, for example, I'm just taking a user. I'm considering a user. I'm just considering a user or something like this. Okay. User wants to access your application. When user wants to access your application, user cannot access your cluster IP directly. That is impossible, team, because the cluster IP is, the name itself is telling very clearly, cluster IP is only for cluster, not for outside world. There, what we need to do, that's what exactly we need to think about now. Now, there is a technique called Application Gateway Ingress Controller. I'm just writing the place here, AGIC, Ingress Controller. So, Ingress is the solution for this case. Whenever you have the multiple microservices and the multiple applications, you need to expose that application or that services properly, either path-based routing or host-based routing. You will use two types of routing. One is path-based, another one is host-based. Okay, two techniques you can use, team. Okay, one is path-based routing, another one is host-based routing. So the main advantage what you are getting here, that is the point you should understand, team. The advantage what I am getting here is, I no need to launch multiple load balancer. First point number one, I no need to launch multiple load balancer. At the same time, I no need to worry, especially in configuring multiple services at the router. You no need to worry actually. The process is very simple and you can route your traffic simply based upon the path-based one. That is also awesome. So you can also make sure that. And another advantage you will get with the AGIC, you can check how exactly the health of your application. You can check the health of the app also. So that is the continuously you will be pinged by your application load balancer. So then only I think the traffic will be routed based upon that one only. Health of the app. Okay, that is continuously you can sense it. Okay, that is absolutely possible. And addition to that, what additionally you can think here, you can keep SSL config. Okay, that is what exactly I'm talking about. HTTPS. You can use domain to route your traffic. No need of any port expose. Okay. So all these benefits you will get if you use the Ingress in your application now. Okay. Now the point is how to use this one. Is it a easy way to understand to use this one, or it's a very difficult? So those things also we should understand a bit. Okay, I'll give you a chance, Naga, don't worry. So that is the thing exactly we need to understand. So now I'm just going further a bit here, next few minutes. So now what exactly the point here is, you did everything awesome. The only missing part here is, whatever the application you are running in your Kubernetes cluster, you need to make sure a path is always accessible so that you can check the health of that particular application. For example, if it is a middleware, okay, I'm just going with middleware /middleware is the default path, I'm just assuming. And if it is a mobility /mobility, for example, team, mobility. So you know what does that mean? So meaning for this one is, if your request comes with /middleware, your traffic will go to cluster IP middleware, or forward the traffic to the cluster IP, forward the traffic to the middleware parts. So that is exactly the thing will happen here, team. That is exactly the thing will happen here. Let me just give some color for this so that your understanding would be really good. Just give a moment. Okay. So that is what exactly your middleware, and also I'm just rising your thickness of the connections. Okay, a bit. Okay, and followed by there is a mobility. And when it comes to the mobility, team, when it comes to the mobility, I'm just selecting all the possible arrows. Okay, and you just go there. I'm just giving the different color for that. I'm just increasing some thickness here also. Okay, so now the point is missing. Okay, now the point, I believe you understand the point now. Okay, so the cluster IP will route the traffic. Cluster IP middleware will route the traffic to the middleware part. Cluster IP mobility will route the traffic to the mobility parts. Okay, that's the only difference. So far good. Now I'm telling one more thing. I'm going with the path-based routing first. Now coming to the path-based routing on the AGIC, what exactly we need to do? AGIC refers to Application Gateway Ingress Controller. Please understand. Application Gateway Ingress Controller. you you might be heard about NGINX, HA proxy, right? So these kind of F5, these are the NGINX Ingress controllers in the market. I think few others are there. Those are not in so much use, but NGINX is commonly will be used, and HA proxy also sometimes people are using that one. Okay, these are all open source NGINX controllers. Those are all NGINX open source controllers. But the thing what exactly I'm talking about, this is Azure native. Azure native. Application Gateway Ingress controller is a Azure native, which is similar to your NGINX only, but it's native to Azure. Very easy to configure. But later we will understand about NGINX controller also, because without that you cannot survive in the industry. Not possible. So first we will assess the AGIC because concept is same. So I have opened specific paths on your application, which is /middleware/mobility. Now I'm forming an ingress resource. We'll call that one as an ingress resource. In the ingress resource, you will tell very clearly, if your traffic comes with /middleware, please route the traffic to cluster IP. You will define this one very clearly, team, and followed by, if your traffic comes with the /mobility, you will route the traffic to cluster IP mobility. Okay, please understand this one, team. This is the technique exactly ingress resource will follow. That is all. Now you understand very clearly, right? So my point here is you are very clearly placing your routing rules. These are all path-based routing rules. Which you are using in the ingress resource. That is what exactly you are talking about. So when the end user is hitting an endpoint, I'm taking an endpoint here. This time, whatever the endpoint you are considering at the moment, firstly it will start from http ://13 dot, for example, I'm just giving 14.45.211. Okay, that is all exactly your application endpoint, exactly whatever you are exposing. I'm telling you one more thing. You can use this one also. You can add a domain, you can add a certificate also. That also possible. This is called listener, https listener. I can tell this is a https listener. Okay, so whatever the listener you have here, so it will listen whatever you are just typing in the browser. Once it listens, it knows very well that where it needs to pass the traffic. For example, if you are coming with /middleware, it can sense it. Hey, my user is asking to connect with the /middleware. So then immediately, what exactly /middleware will do? With the /middleware, your traffic will go to middleware. This rule will be identified. First /middleware. These things will be identified in the ingress resource. Okay, then you give the /middleware. /middleware will be identified in the ingress resource. And also, if you notice one thing, the /middleware is being identified, and it knows very well in the ingress itself where you need to route the traffic. You need to route the traffic to cluster IP middleware. Then the traffic will move to cluster IP middleware, something like this. That's it. For example, this is about the middleware. For instance, let's come up with the mobility. So this is what exactly, maybe the next one is mobility. I'm just considering, okay, for example, if your traffic is mobility. Okay, mobility. So now what exactly you should do? Again, you will think about the same process, but the concept is same thing. Again, you will come here. When you give the /mobility, your ingress resource, that is what exactly application gateway ingress controller. So your ingress resource, this is the resource which you will feed to AGIC. You will feed this one to AGIC. Now AGIC knows very well how to route your traffic. Now when you give the /mobility, now what exactly will happen? When you see the /mobility, again Yeah, when you give the /mobility team, I don't know why it is not selectable. Okay, no worries. Okay, let me come here. When you go to the /mobility, what exactly the point you need to think about here is, team, I'm just giving the box in red. So then whatever the traffic is coming from, the traffic will come to this mobility. This is what exactly your scenario. Once it comes to the mobility team, then followed by whatever the traffic received by the mobility knows very well that where it needs to route the traffic. We need to route the traffic to the cluster IP mobility. Just take the arrow and just point that particular arrow to this one. Okay, that is what exactly you need to do, team. Okay, that is exactly the thing you need to perform. Please understand. That's exactly the thing you need to perform. So now you routed your traffic from mobility to your mobility cluster IP. Awesome, right? That is what exactly you achieved now. That's good. That's good. So this is exactly the thing which I am stressing at the moment to understand. Okay, what exactly, where exactly we are routing our traffic. Okay, let me move this one a bit so that it will be adjusted really well. Okay, so I'm just copying this one, and whatever the things are coming up, I think you are just passing that one to the mobility. So that's the point exactly you should understand. If you understand this concept, team, so this is what exactly your ingress is doing. Same thing your ingress is being performed. For example, I'm just connecting all your red colors so that you can easily understand everything is coming like that. So this is what exactly your traffic is flowing through. All the blue is flowing through in that way. Okay, so now what you achieved so far. My achievement here is, so far I was exposing multiple load balancer in my scenario. That is what we just ignored, and we no need to have multiple load balancer. Instead, you can have only one load balancer. That load balancer will be called as application gateway. Application gateway load balancer. This is the only one load balancer which you need to have in your portal. This is the only thing. This application gateway load balancer is the one exactly will make use of your AGIC and will make use of all your routings properly routing to the correct destination. Okay, let me just keep a person here on top, and between I'm just keeping a load balancer. So now load balancer will make use of this routing technique. This is exactly your routing techniques. Based upon that one, your traffic is flowing through for the below ones. Okay, so this is what exactly about your upcoming flow, team. This is what exactly we are simulating as well. All right, team.
Thank you for the session. See you in the next part. Welcome back, team.
After understanding about the AGIC and its corresponding flow, now what we need to do, we should be able to enable the AGIC on the Kubernetes cluster. That's the step number 1. You should be able to enable it. To do that, go to portal. There you can see your Kubernetes cluster right here. Please enable the Kubernetes cluster first. Start the Kubernetes cluster. So once it gets started, you have an option, especially under networking tab. If you go to the networking tab, under networking tab, you can see a specific an option called application gateway ingress controller. Enable ingress controller. That is what exactly it is telling about. Remember one thing, one activity you should make sure before going for this screen. Okay, what is that one? Whatever the VNet you have planned for your infrastructure. For instance, I'm just going into the overview. If you go to the overview, I'm just going for the node pool also. I'm just going for the node pool. Under this node pools, if you notice one thing, let it start actually. If you go to the agent pool, there under this particular thing, here you can see your virtual network. Please click on the virtual network. One activity you must and should do, I will tell what is that. Go to subnets. If you notice your subnets, here one subnet you delegated for application gateway. Hope you remember this one. Whenever we are dividing our VNet into subnets, we did this activity. So the point here is, team, whatever you are seeing, especially on the app gateway subnet, right? So whatever you are just thinking, the app subnet is the one which is Azure Kubernetes is sitting. Okay, sorry, Azure Kubernetes is sitting in the app subnet. Okay, but I'm talking about app gateway subnet. But whatever the app gateway subnet you created, please delete that, but refer your IPv4 CIDR. I'm just copying the CIDR, I mean the leftover CIDR, This is one of the leftover side. I'm just coming here, delete. I deleted the subnet. Why we are deleting the subnet? Because whatever the application gateway ingress controller, whatever I pointed on the Kubernetes cluster, that one will create this subnet automatically. So initially when we were planning, we just assume that particular subnet delegated for app gateway. But when actually you are reprovisioning, when you are provisioning the app gateway ingress controller, you must delete that one. If you don't delete that one, app gateway ingress control will not consider the cider. Please understand. It will try to create its own. Okay, that's only the problem here. Now go to the home. Open the Kubernetes cluster one more time. I believe it should be under starting. Okay, fine. Let's wait for a few more seconds. By that time, your Kubernetes cluster ready. Once it's ready, on top of the network, we'll go to the network and we will enable and we will pass the cider. Subnet, whatever the subnet we copied. So with that, app gateway ingress controller, that is what exactly you are looking for. With that, app gateway ingress controller will be provisioned for you in the portal. Okay. The app gateway advantage with the app gateway ingress controller is this one will automatically provision your application gateway also. Automatically. So that's the point exactly you should understand. Okay. Two things will happen. When you enable the application gateway ingress controller, not only gateway ingress, along with that, application gateway also will be provisioned. Please understand. So that's exactly the interesting fact here. So once you are done with this thing, now what exactly I'm doing? I'm just this is what the AGIC along with the application gateway load balancer both will be provisioned. Let me go back here. Let me reload the screen. I believe should be fine by this time. Okay, alright. It is still under starting. So meanwhile, we'll go there and we will start our database also. We have our own database, right? Please go there and start the database also. This is the another thing which you can consider. Okay, please start the database. Alright, so you are starting the MySQL Server database also. So they are the two components I believe for now in the Kubernetes cluster we provisioned so far. That's fine. Alright, okay. We'll wait for a while. So meanwhile, what I can do, I can go there and I can start the one of the VM also for our reference team. Okay. So we can start our jump host VMs also. I'm just starting our jump host VMs. Okay. Okay. All right. Your Kubernetes cluster is on, team. Okay. Once your Kubernetes cluster is on, I'm going to the network section. Go to networking. Under the networking, enable this one. When you enable this one, it is asking you application gateway, new ingress app gateway. That is what the name it will create. That's okay. I'm just clicking on the create a new. When you create a new, it is asking a subnet prefix. Here, I'll give a copy. That's it. Okay, I'll give a copy. Then, you can click on OK. Once you click on OK, then simply apply the changes. That's all. So, once you do this one, you're configuring ingress for your Kubernetes cluster. On top of it, application gateway also will be provisioned. This connection you are just making sure, team. That's what exactly you are doing. Okay. This connection you are making sure. Alright. So, once this connection is formed, then I think it will take 10 minutes easily whenever you are configuring application gateway ingress controller. I have noticed quite a number of times. So, meanwhile, we'll understand more on our ingress controller ML. Okay, that one we'll go for. Okay, that one we will see. Okay, so let's connect to the VM virtual machine, whatever the virtual machine we have already. Let's connect to that. It's loading, just waiting. So, alright team, I believe this connection you can close it. This is a wrong VM. You don't need to open this one. I'm just closing, sorry. I'm just closing the connection. I don't know what is playing this. Okay, alright. So once it got closer team, the firstly what exactly we are going to do, especially you need to connect to your AZVM, okay, that is what your VM. Let's connect to our VM team, okay, that is what our AZVM. Let's try to connect to that. Okay, asking the password. Alright. So once you give the password, try to open that path, Azure user path. Asking the password again. Please key in the password. Sorry, yeah, it will ask the password. Just a second. Your two windows got open, seems to be a lot open. Okay, let's close the old ones team. Okay, it's creating confusing. All right. Okay, so for this one, I'm just coming here, connect to the host, AZVM. Okay, under this one, I'm just bringing up this particular password. Okay, just give that one. All right, that's awesome. So once you are there, just open this particular folder. That's all team. Okay. Give the password again. Okay. All right. Now you are into the VM. Okay. So now what exactly you are going to do? So I'm just double checking whether my Kubernetes cluster is completely up or not. kubectl get svc. That one will tell you is everything is alright or not. Even your load balancer is also inside. Okay. Everything is there. Awesome. So firstly, what we need to think about here, team. So firstly, what you need to understand, we should be able to apply an ingress, especially to this particular Kubernetes cluster. But you should think about how to apply ingress to this Kubernetes cluster. So what is exactly the point here is, team? We should get an ingress resource. That is what exactly required for us. For instance, I'm just creating one ingress AML so that you will get an idea, okay, how exactly ingress resource works. vi ingress.aml. I'm creating one AML. So as part of this AML, I just pasted some code inside. Just escape : w exclamation. So now what you did, team? Let me go there and refer the code. If you refer the secret ingress AML, what are the ingress AML we just created? Where is the ingress AML? Yeah, ingress AML. Yeah, if you refer the ingress AML team, so this is what exactly we are going to refer now. See, API version kind metadata spec is the common thing. There are no any changes. And correspondingly, under metadata, you have given one annotation team. This is the annotation exactly will decide which ingress you are planning to use. For example, in case of NGINX or some other cloud providers, you will never give this kind of ingress class. This ingress class is dedicatedly only for the Azure, because you are using Azure Gateway Ingress Controller. That's why you are giving this one thing. This is the turning point here. Okay, this annotation. If you are going for some other NGINX, I will show that how exactly you need to use. If you are going for some GCP or the AWS also, this one will be different. Okay, not same. Next one, if you go for the spec, this concept is same only. Wherever you go, concept is same. I told you already we are going on routing on the path-based routing. That is what exactly we are trying to do here. For instance, spec rules. Under the spec, you are just telling whatever the HTTP request you are just bringing, which is coming to the ingress, it will double check the path as a middleware. If the path as a middleware as a prefix, then you are routing that particular traffic to the backend service called middleware. Now, what is this middleware team? whatever the kubectl get svc you applied, when you apply this one, if whatever the name you are getting, especially for the service, that is what exactly you are passing here. To be frank, you no need to keep this one as an external load balancer. The reason for that one is, if you refer your communication, so whatever the traffic is coming to the Ingress is routing that one /middleware /mobility. This is Ingress job. When it is dividing the traffic, automatically it is forwarding. If it is identified /middleware, you are passing to the cluster IP, not load balancer. Please understand. Keeping the load balancer is a security threat, okay? Don't keep the load balancer when you are using application gateway ingress controller. You no need to use that one. You just use the cluster IP. That is more than enough. Now, you should understand how to convert this particular service to the cluster IP again. So, you need to understand, right? So, to do that, kubectl edit ingress, svc. So, what is that? svc middleware -o aml. That's it. So what exactly you are doing? You are trying to open the middleware for the edit. Okay, just open this one. Once you open this one, team, just come here. Just scroll down to the last. Okay, there you can see one type called load balancer. If you recall, this is what exactly we changed from cluster IP to the load balancer. Now I'm just moving back from load balancer to the cluster IP. That's all exactly we are doing here, team. Okay, cluster IP. So once you are done with this thing, escape :wq exclamation. That's it. Your task is done. Now kubectl. Now go there. Get svc. If you apply, see the external IP got blocked. There is no external IP now. So that is what exactly you need to think about whenever you are going with the Ingress. You don't need any load balancer because the cluster IP is more than enough to route the traffic inside Kubernetes cluster. That's why you are using cluster IP stream here. Okay. Awesome. So far really good. So now what exactly we are thinking about? So once you are good really with this particular thing, now what exactly the point I'm just bringing up here? Once so far awesome. So next I need to understand a little bit more on this particular Ingress. That is what we are in progress with. Now if you come here, team, so you are telling, okay, if the traffic comes with the /middleware, you are routing to the middleware service. That's all. And middleware port is 8080. If you recall your service ML team, in service ML, you already told my service port is 8080. That is what exactly you should route your traffic. Please understand. So you should route your traffic always to port 8080 only. So that is the basic rule which you should follow, team. That's awesome. Now you know what additional thing I'm just interested to do this one here. So once you are done with this thing, team, on top of it, what exactly I'm going to do. So once you are clear, I'm going to add one more path for you so that you will understand, you will get enough confidence also. Under the paths, you just copy the path again, team. Under this one, just come back here. Just paste over there. I'm just giving this one as a mobility. This one as a mobility. If it is a mobility, you need to move this one to the mobility service. No, I need to move this one to the mobility service. That's all exactly you need to think about, team. And you think, okay, mobility is running on the port 8081. I think you can go the port 8081. That is one of the dummy service which you can think about always. So this is another service which you can think, okay, I'm just deploying another service called mobility. That mobility is listening on the 8081. So now escape :wq exclamation. If you give this one, sorry, yeah. So once you are done and you are on the editor only, just Control S is more than enough. So once you are done with this thing, team, now what exactly we are going to do? Now applying kubectl apply -f apply, sorry. -f. Okay, whatever the Ingress YAML you are just thinking about it, just take the Ingress YAML. So now, the moment when you are applying the Ingress YAML, please understand whether your Kubernetes cluster application gateway is completely up or not. Okay, that's the first thing you should think about, team. Ingress controller has not created application gateway yet. It may take up to 15 minutes. This is what the earlier message. Let's reload the case. Okay. Alright, I believe it created already. Okay. When I click on that arrow, see it is taking me to the application gateway. That's awesome. Everything is good. This is what exactly the application gateway got created, team. Now what you need to do, you just come back to the Visual Studio Code. Simply you just need to apply. That's it. Once you apply, you know what is exactly the things happening here, team. So now you just go there, kubectl get ingress. Okay. If you apply kubectl get ingress is the one exactly. This is what your ingress which you provision. Okay. This is what your ingress which you provision. Okay. So the point here is this ingress, whatever the ingress you are seeing, that is what exactly give the name ingress -support-path. So the same name being picked up. But you never talked about this IP address. But what is this IP address? Always remember one thing. This particular application gateway, what is the application gateway I'm showing you on the screen? That one will comes up with the public IP. That is what you are seeing here, team. This is the public IP, right? This is the public IP, team. So you are seeing this one. Okay. At the same time, you are seeing a public IP, you are seeing the virtual network and subnet also. So meaning that, so whatever the thing you are trying to hit from user side, so it is for you for the public only. But actually you are coming inside a network. You are coming inside a virtual network. That is what exactly the thing happening here, team. So application gateway has the public IP, application gateway has the internal IP also. So meaning that your application gateway load balancer especially is sitting on the virtual network where it is allowing the public also to connect and also internal traffic also it can move. That is exactly the capability you are reading about application gateway load balancer now. I will draw the architecture in our tomorrow's session. So you will get a very good clarity how exactly the application gateway, how exactly the further things you are dealing with now. Okay. Because lack of architecture only you are struggling with here. This is just a flow diagram. So that is why you don't, you're unable to assume, okay, really what exactly the subnet, what exactly the VNet and how it is opening the public IP. Okay. Two things it is doing. It is opening the public IP. It is giving the internal traffic also. Intranet traffic also it is handling. So that's the point here. Now you go back to this particular Visual Studio Code. Awesome, you already applied. Now I'm going to describe this one, okay? kubectl describe ingress. This particular ingress name, ingress -support path. I'm just describing this one here. The moment when you're describing this one, you know what exactly the thing? If you read this one, host, okay, hastic, okay, because you are not coming up with any domain. Your lack of domain today. We will see the domain case in NGINX, don't worry. So you don't have a domain, you have only IP address. That's why host is hastic. And whatever may be the host, if you comes with /middleware, whatever may be the host in the sense is application gateway IP address. IP address /middleware, a traffic will go to middleware. And here I have two parts to handle your middleware parts, middleware traffic. That's the two parts IP address, these two. But when you go for the mobility, it is telling you are routing traffic to mobility 8081, but error. I don't see any kind of endpoints for the mobility, meaning that I don't see any parts. Of course, right? You don't see any parts also. So meaning that whatever the routing you placed here, one is true, one is not true actually. This is true, this is not true. Okay. So now I want to simulate both the cases, how these two cases will behave. Okay. I want to behave that. I want to show you that. Okay. Clear. I'm just going there, team. Once your task is done here, you don't need to do anything here. Your ingress also applied. So you applied the ingress, you got the application gateway, ingress controller and routing rules placed, everything fine. To double check this one, you go to the internet, our portal. This is what application gateway you provisioned. Okay, once you are here, team, you just come back here. There specially, let's go through one by one in sequence. You go to listener. Listener is the one exactly listening on the protocol HTTP. Please understand. And also when it listening the protocol of HTTP, see friend end IP, yes, enabled. Protocol is HTTP, not HTTPS. Please understand. It's not a secured one. You are still using unsecure protocol only. Port 8080, and followed by associated rule. There is a rule associated. We'll see that. And listener, you are seeing at the basic. You don't need to worry about multi-site one because the multi-site you're currently handling single website only, right? If you are really routing based upon the multi-host basis, then only will go for multi-site. Your currently your case is only one particular endpoint, especially that to an IP address. You don't need to worry on this. And if you want to keep any custom IP address, custom error pages, you can give the endpoints here 403 and 502 comfortably. Alright, team. This is about this one. Next time, just going further. Once you are done with this thing, there is associated rule. Click on the associated rule. So what does that mean, associated rule? Associated rule means whatever the listener is listening, the traffic, this is what listener is listening, the traffic will go to backend target. What exactly the backend target is consisting of? My backend target consisting of two rules. These are the two rules exactly you created. You created by using ingress. /middleware /mobility. Now you can read very clearly here. /middleware /mobility. So this is what exactly you are routing your traffic to your backend pool. But meanwhile, you are seeing backend setting also. Let's understand little bit on backend settings, then we will come here, team. Okay, then you will get an idea. Okay, if you click on this one, you can see also a little understanding. These are all the default setup. Okay, default setup. So you just come here /middleware. You are just giving backend settings something. This is also default come up, and backend target. This is the one exactly you are representing your pods. Your pod representation is this one. But how do you know it is my pod? So to know that, I believe that's the best option here is what exactly we need to do here, team. You need to understand about the flow. Let's go back to our case. Okay, listener is clear. Listener is, okay, what other things are listening? I think we are listening really well. That's okay. Once listener listen that one, then the next task here is your traffic will go to the backend pool. Who is telling to go to backend pool? That is what exactly the routing rules exactly will tell that. Okay, fine. So let's go to the backend pool. Well, let's understand what is there in the backend pool. There are two backend pools. One is the default one. Another one is a pool default middleware, which is auto created. Okay, open this one. If you come here, see here I'm seeing two backend IP addresses. You know this? What are these two backend IP addresses? These two backend IP addresses are nothing but your middleware pod IPs. Please understand. So how do you know that? You just come here, kubectl, get PO. I'm just applying it. Okay, get PO -o wide. If you apply this command, there you can see IP address also 10.244.0.5, 10.244.0.8. If you come here, see 244.0.8, 244.0.8. See, it's taking automatically. That's good. For example, in future, for example, in some cases, maybe your pod may go for restart. When a pod go for the restart, team, what exactly the thing will happen? Automatically your IP address will change. Now you may think, okay, when IP is changed, how my application gateway backend pool will capture that? So that is automatic, team. For instance, I'm doing one practical case here. I'm deleting one pod. When I delete a pod, if you try to apply -o wide, now I think your IP will change. You will not get the same IP. So when you are getting the see, I'm getting 0.13. When you get the 0.13 and 0.8, you go back to application gateway ingress controller. Just reload your screen. Okay. Because you are in the same screen, that's why it will not display. See, 0.13 been captured. This is the interesting fact here. So, though your pods are getting restarted, getting deleted, are coming up, whatever the IP addresses being allocated for your pods, those IP addresses will be captured here automatically. So, you don't need to worry at all. You don't need to worry at all, especially on the pod restart, a pod deletion, a pod terminations. You don't need to care about this case. That's awesome. So that is exactly you're saying. That is exactly you're saying for the backend pool case, team. Okay. So let me repeat that one. This is what the backend pool. It is referring your two IP addresses. That's really good. Okay, fine. Now, once you are done with this thing, okay, this is what exactly the thing you are seeing. Okay, right. There is the default address pool. This is the default address pool. Nothing is there because the default you are not configuring anything because you are just bringing up everything as an actual, which is a middleware. And you don't see anything for the mobility because you don't have any pods on the mobility. That's why your backend pool is not got created here. You are seeing only for middleware only. That's awesome. Go for backend settings, team. This is interesting. Okay, backend settings. Coming to the backend settings, you are seeing for both middleware and the mobility. Forget about the default. Click on the middleware. So whenever your call is going to the backend pool, these settings will be useful. So whenever you are touching your parts, especially your parts cluster IP, are you trying to use HTTPS connection or HTTP? Because that is already internal. You're already inside the Kubernetes cluster. Obviously, it's HTTP only. So you go for the HTTP. You don't need to use HTTPS for internal communication. Not required. If you use HTTPS for internal communication, again latency issue will come. Okay, please understand. So HTTP and backend port obviously 8080. This is what exactly my middleware cluster IP is listening on. Correct. That's what exactly the backend port. And these are the cookie based affinity connection training. So these are all the things basically not needed to enable, to be frank. Cookie based affinity, for example, if you want to log a particularly a user session based upon the cookie, I think you will keep this one enabled. Not really needed. And connection training means whenever you are particularly your backend pod or backend service is not available, so your application gateway will not route that particular traffic to that particular service and it will give a smooth exit. smooth exit, that particular termination. So that is what exactly this particular connection training means for. You can enable this one, not at all an issue here. Not at all an issue, you can enable this one if it is really required for you. And request timeout, by default request timeout is 30 seconds. Within 30 seconds my backend is not responding, automatically will say an error message to. Alright, if you see this one, you override backend path, host name, override with a new host name. No, I'm not overriding with anything. You just use whatever the things are being configured at the backend, which are pod IPs. Directly pass your traffic to them. That's all you're telling here, team. Awesome. So once you are done, I think that is what exactly your backend setting. I think I just clicked on save. Nothing been saved newly. Mobility also same. If you come to the mobility, you are listening on the HTTP protocol. Backend service port is 8081. Please understand. And this cookie based and connection training request timeout and override. No need to override anything because it will go to the default parts. But you don't have any parts for the mobility case. It's okay. Everything is awesome. Now we understand listener, we understand backend setting, we understand backend pools. Awesome. Now rules are talking about how listener is moving to the backend. That is, now you can come here and you can understand now. See, whatever the traffic is coming to the listener, you are passing to the backend target. How? You are just passing to the backend target. If it is a slash middleware, you are just passing that one to the pool default middleware. If it is a slash mobility, you are just passing to the default address pool because you don't have a pod IPs. That's why it is taking the default address pool, which you will get an error only. Awesome so far, team. Now, once you are done with this case, now I'm just going for one interesting fact, which is a backend health. Backend health. So this is exactly the thing. Basically, we'll talk about really your services are healthy or not. It will tell you, team. Your services are really healthy or not. It will tell, team. Very clearly, it will tell. For example, you are saying your parts are really healthy. 2 parts. It is rating 200. You know how come, and based on what it is defining this one, it will decide based upon the path you gave. So that is what exactly you need to think about. Okay. For instance, I'm just going for the overview. There is a health probe. Sorry, there is one more called health probe. Click on the health probe. If you go for the health probe, there is a middleware health probe, which is going for slash middleware. Please understand, slash middleware. So meaning that you are going and directly hitting your cluster IP. That's what exactly you are doing here. You can hit your cluster IP by using application gateway. In this particular page, that's possible. You can hit that one. You just come here, just hit it in. The moment when you hit, automatically you are just checking whether slash middleware is really responding or not. So it will tell you whether the pods, whatever the pods you have, those pods are really doing good or not. Yes, 2 pods are doing good, healthy. Once you get this confirmation, you go to the overview screen, team. Go to the overview screen. Once you are here, there you can go for the IP address, whatever the IP address you are just considering. Copy that and go back to your browser, http://. I'm just giving this one, slash middleware. Okay, I'm just giving this particular path. Press enter, see, I'm getting true. So my Springboard pods are really doing good. That's what exactly you are achieving here. At the same time, I have mobility also. Let me give the mobility service. Okay, this is another service, right? Hit enter. See, I'm seeing 502 bad gateway because you have service ready, but you don't have the end user and end pods, exactly the mobility pods. That's why you are seeing this issue. I want to simulate both the cases. That's why I took this one. Okay, please understand. So one is positive case, one is negative case. When you see this kind of errors, you need to fix this mobility pod. You need to deploy the mobility pod and you need to make sure your pod is responding on the mobility path. That is very important. Then only you can achieve this one. Alright, so far good. So what exactly we achieved so far here is, team. We took an application gateway ingress controller on top of our Kubernetes cluster and we tested that one by using a direct public IP, but which is a HTTP connection. That is okay for today. Okay, so we understand this one. We understand about the flow, listeners, backend settings, backend pool, which is helping exactly. Rules are really helping on this, and that is what exactly we have seen as well. And we understand about the health groups also. So these are all the things exactly about the Ingress application gateway, team. Okay, Ingress app gateway. So especially if you notice this one, you achieved this one. Whatever the thing we discussed so far, we achieved this one.
Thank you for the session. See you in the next part. Welcome back, team.
In this session, we are going to see particularly a part about NGINX Ingress controller, very important for your real time. Okay, because AGIC is the one which is being defined by the Azure, and this is a managed component, and you no need to worry anything about this one. And also, especially this AGIC corresponding to app gateway will make charge also in your account. Okay, it is not a easy one. Nearly $200+ is the minimum charge which you need to pay for application gateway usage. Please understand that. So that application gateway charges usually will come in two ways. One is fixed charges, another one is a variable. Okay. For example, fixed is 180 or 190 plus. I don't recall exactly. Let me open that one so that you will get an idea. Okay. Azure calculator. So whenever you get any doubt, you just go for the Azure pricing calculator. Okay. Where is that one? Pricing calculator. Sorry. I think they changed the URL or what? It should come easily by saying this one. Okay, let me type differently. App gateway pricing. Okay, let me go in this way. Azure app gateway pricing. Okay, click on this link. Yeah, you can see something like this. Okay, here you can go here, team. We can select your corresponding to your area, which is a Southeast Asia. I'm just selecting here for my case. Okay, so Southeast Asia, I'm just selecting. Corresponding to the US dollar, I'm just selecting, for example. You can see one is a fixed, another one is a capacity unit, and also application gateway. V2 application gateway, V1 application gateway for containers, which is in preview. Never care. Don't care about this one. Fixed one, see, this is per hour cost for you. If you take a firewall also, I think our charge will be little more, very costly. And capacity unit, if you see, per capacity unit per hour. So what is this capacity unit means, team? So number of instances, I can say it's a number of instances. See, sometimes if your load is too high, obviously you need to scale it up, no? So then you need to pay for more, but because of you scaled up. So that is what exactly the capacity unit here. So point to be noted here, application gateway architecture is a little bit costly one only. But I'm going to give you one best architecture which you can refer. So far we have seen a application gateway connected to the AGIC. I will draw the architecture for that also. But I'm going to draw the another architecture, especially for application gateway connecting to the NGINX Ingress. NGINX Ingress is connecting to your services. That's the best case which you can use in real time. Okay. So for example, let me take this diagram on. Okay. Let me take this diagram as it is, team. Okay. So that it will be helpful for me to just refer our architecture also. Okay. Just go there and just keeping here, and especially I'm just pasting that one. Okay. Just drag this one to the bottom. Okay. Awesome, team. Okay, just keep this one as it is. I'm just reducing the size a bit so that I think you can understand easily the connections and all. Okay, I'm just removing one sort of. I'm trying to keep only one service for now. Firstly, so that I think you will not be confused for the first. Okay, let's understand about one service first. Okay, so that you will be very clear, team. Okay, don't worry on this. Okay, otherwise you'll be confused. Okay, awesome. So this is the basic thing now. So what exactly the changes I am bringing here, easily I will explain here. See this one too. I am keeping a service, your service as a cluster IP. So that's why cluster IP will go inside. No changes on that. Okay, awesome. Take this connection out, take this connection out. So you know very well that, okay, I'm just taking these labels. Forget about labels because we have a solid understanding already. So in this Kubernetes cluster, if you notice the Kubernetes cluster, your Kubernetes cluster is a zone redundant, meaning that three virtual machines are launched in 3 different zones. So you are maintaining awesome high availability. That's really good. I'm not bothering about your high availability and all. So that's really awesome. Now, what exactly I'm worrying then? So I'm worrying about only one thing. That is how exactly you are planning to route your traffic. That is the interesting one. Okay. How? What exactly your plan also? Okay. That is what exactly we will see now. Okay. So when you are sorry, let me keep at least 75. Yeah. So when you are thinking about this kind of things, team. So what exactly the point should be there in your mind? So for example, I'm just keeping this as one box. Okay. So this is zone. So these things already you're well aware. I'm just keeping these things, team. Okay. This is another zone, and this is one more zone. Okay. One more zone. So those are the 3 zones. Corresponding to the 3 virtual machines got launched. Okay, maintaining high availability. That's awesome. That's good. That's good. Okay, awesome. So once everything is all right, now you know what exactly we need to think about. How you are planning to route the public traffic to this one. Firstly, take this out. Okay, that is not really required. So especially team, for example, my user, which endpoint exactly I need to hit? Obviously, first and foremost thing, the best use instead of using application gateway ingress controller, and also there is a problem with application gateway ingress controller, which is a known issue from Azure side. So whenever you are applying some rules, ingress rules on the application gateway ingress controller, sometimes it will not be reflected immediately. Sometimes it will not be reflected. It will take max to max 1 hour to see the change. See, we are coming to the Kubernetes. Kubernetes, the only reason for that one is you want to maintain a zero downtime. But if you say these kind of issues, obviously people will think, okay, why we need to go for AGIC? That's where NGINX got a very good importance in Azure world. Okay. If you come here, team, this is a cluster IP. I'm not touching this one. On top of the cluster IP, I'm going to bring one more, which is an ingress controller. I don't think so. Ingress controller, which I can see a icon here. Let me double check. Okay, I don't see any icon here. Okay, so let me do one small thing for you, team, so that you will also feel better. Okay, I'm just taking ingress controller images. Okay, I'm just going for the images, one of the images, so that I believe you will feel more comfortable what exactly I'm talking about. So that's what my goal. Okay, so let's take NGINX controller images. Okay, I believe all the images are with setup only. That's okay, fine, not an issue. Icon. Okay, let me open this particular thing. Yeah, that's fine. Okay, one icon I just need. Okay, that's all I'm just looking for. For example, I'm just taking this particular icon. I'm just taking a snapshot of this one, team. Okay, just for our architecture definition only. Don't take this kind of copyrights one, but since we are dealing with architecture, that's why I'm just preferring this one. So you can take some others also, not at all an issue. For example, there is a NGINX simple with symbol, and I'm just preferring this one. Okay, so that you will get an idea on this one, team. Okay, just copy this one. Just take a snapshot of this one. So once your snapshot is ready, what exactly my intention here is, just go to your snapshot over there, whatever the snapshot you just brought up. You just open this one, team. So I'm just going there, I'm just cut this one. I'll cut this one, and I'll just make sure this NGINX is sit inside our architecture. That's what my goal. So once this is done, you just go back to your you just go back to your architecture area, team. So this is what our architecture area. If you come here, what exactly my goal here is, I'm just keeping an icon here. This is what exactly my icon. I'm keeping an icon. This is representing your NGINX. So please understand. So your NGINX now, the problem or the question is, when you launch NGINX is always sits inside the Kubernetes cluster only. So for example, so if you launch the NGINX will take an IP. Will take an IP wherever the Kubernetes cluster is sitting, right? That's the same thing. It will be tightly attached to your Kubernetes cluster, I can say. Okay. And remember one thing, this NGINX is the one exactly will be considered your private IP. Private IP of one of the IP from the Kubernetes cluster. Also Kubernetes cluster. Awesome, team. So I'm just giving the simple connection here so that your understanding will be very good. So NGINX is connected to the service is connected to the pod is connected to the database. That's really good. Now, what exactly you are trying to implement on top of it? I'm trying, see, this is what I want to keep. See, this is NGINX. NGINX is open source. I'm not really very comfortable to open an open source component completely for the public. So what exactly the missing points here? So points missing here are, you need to able to attach a WAF for this one, WAF for the NGINX. So then, no, because it's a web application traffic, right? You should have a firewalls. Otherwise, the other man in the middle, the hacker, easily can exploit your traffic. There is a possibility. So my point is, at least you should safeguard your NGINX with proper WAF. That is one thing. The second thing, either you can go for that one, or if you think, okay, let me use NGINX as an internal load balancer. It's an internal ingress. I can call this one as an internal ingress, team. Okay, I'm just defining this one. Internal ingress. I can call this one as an internal ingress. Okay, so once you see the internal ingress, team, so meaning that whatever the traffic is coming to this particular internal ingress, you are just moving the traffic to the service part. Okay, that is what exactly our goal here, team. That's awesome, not an issue for us. Okay, that's still okay for us. So fine. So internal ingress. So now I'm going to introduce one more component for you, the specialty. One more component. That component is, because your cluster is sitting inside a VNet, right? So that is the thing exactly. I'm just making sure a bit here. So I'm just pushing this one back so that I believe I can use that particular outsider line for the virtual network. So that's exactly the thing I'm going to see. So this is what your VNet. Okay. Now I'm just considering this particular Azure Virtual Network. Just take the Azure Virtual Network thing. Okay. Virtual Network. Okay. I'm just taking this one. So this is what Azure Virtual Network. Just consider the Azure Virtual Network team. Just keep this Azure Virtual Network here. So awesome. So far good team. So this is what Azure Virtual Network. Then what exactly I'm going to do? Especially, I'm going to introduce another component called Application Gateway. Azure Application Gateway. So that's a component exactly I'm going. So you may get out why you are using Application Gateway again. The reason for that one is, firstly, this is Azure component and it is directly available for you to use. I don't see any problem with Application Gateway. There is a problem with Application Gateway Ingress controller. That's why I little worried to use the Application Gateway Ingress controller. In the place of Application Gateway Ingress controller, I'm using NGINX this time. That's the only difference team. Okay. So now you are just giving a connection from your application gateway to NGINX. That's awesome. So for good, see team, wherever the cloud, whatever the architecture you're defining, concept is same. You need to do the same thing. Okay. So don't change anything, everything as it is. Okay. Just follow the same architecture. That is more than enough for you. Okay. So what I'm telling, for example, if you go to some other cloud environment where you can see instead of application gateway, then for example, if you go to the AWS cloud, there you can see application gateway load balancer instead of application gateway. So that's the only difference. You need to use that one instead of using this case. That's the only difference. You need to think like that. Okay. If you go to the GCP, you need to use a corresponding load balancer, but the architecture must be same. Okay. No difference. This is the best one which you can refer always. Super good tip. So once you are here, next what exactly I'm thinking about. So far awesome. So now I'm just coming to the public point of view. Now I'm going to talk about few other things here. For example, team. For example, whenever you're hitting your endpoints, especially for the public, always you need to be very clear on your traffic should be HTTPS. The point number one, HTTPS. Okay, this time. And also you should use a domain name. You should not export any port for that. That's a basic rule. Agree? For example, https / flipkart.com, https amazon.com. Right? You're seeing a https protocol with a domain, right? That's what exactly I'm talking about. That's awesome. Now we are going to explore furthermore how exactly you can get a certificate, how exactly you can have a domain, which is a public DNS zone, and how exactly you can get the certificate, how to configure a certificate also, where our end user will hit our application gateway by using domain. In our previous example, we have used IP address to hit this one. This time, you are going to use a domain, but I'm going to use a self-signed certificate, okay? Self-signed one. I will show you how to generate a self-signed certificate also. I will show you exactly where exactly you need to configure in real time, okay? So that's only the thing. Alright team, so far I'm thinking we are making sense. Okay, this is exactly the architecture which we need to bring it up. Fortunately, we have few components ready. On top of it, we need to bring up NGINX, we need to bring up application gateway, we need to ask our user to test this case. That is all, correct? An interesting one I'm going to tell you now. I'm going to do this particular setup completely NGINX, service, middleware parts, everything I'm going to do specially in a separate namespace, not in the default one. So default one is the common one where everyone can refer. But when you go for a new namespace is nothing but it's a logical separation. So if you go for the namespace, always it would be really good for you to maintain your security policies also in future. Okay. Alright team. Now to implement this one, what exactly we need to do? Let's go back to our portal, okay? So let's go there, let's switch on our missions one by one, okay? Firstly, I'm going there, I'm just switching on the mission. AKS-7AM is the one thing, I'm just switching on this one. So firstly, just do this one. Alright, and once this is been switched up, then you go there and switch on the database also. So my database is also on. Two things are on already. And my VM is already on, so which you're going to use as a jump host. That's awesome. So far clear team. So these two things are already on. Those two are exactly the things required for us. And especially once you logged into the virtual machine, I'm logging into the virtual machine. This is what my virtual machine I logged in already. Okay. So firstly team, what exactly you need to do? Let me tell you. So firstly, our job here is let's go one by one, step by step. Okay. So firstly, what you need to do team? First you should understand, is there any, So first you should understand, is there any, I'm just cleaning the resources if anything is there inside your Kubernetes cluster. Okay, that is what exactly I'm just trying for. kubectl get ns, sorry, I believe Kubernetes cluster just no one, right? Let me double check that one bit later. So what exactly you need to double check here, team? First, step number 1, you need to make sure, is there any IP address is free for internal NGINX or not? Step number 1. So any internal IP availability. Even you can go for direct submission also. It will just bring some whatever is available. But if you want to dedicatedly give any kind of IP address, you can reserve that. Okay, you can reserve that. So for that one, what exactly we need to do, team? So what are the thing? I am just keeping a step here. For that one, you need to use a command. So I'm going to bring that particular command for you, so that I think you will feel more comfortable. So I'm just bringing up the command here. Okay, I'm just pasting the command also here. Okay, so this is the command exactly you should use, team. If you use this command, az network vnet, this is what exactly especially vnet name. Sorry, this is vnet name, and this is what exactly your resource group name. That's all. Only two things: vnet name and the resource group name. So those two things you need to fill, and you need to play with this one. That's all, team. Okay. So for example, now I'm going to simulate this case. Okay. So let this particular Kubernetes cluster to be on. Okay. Just focus for the next 30 minutes, team. Okay. It will be clear. So for example, kubectl get svc. Okay. I think still the Kubernetes cluster is not on. So step number 1, we are going and we are identifying, is there any IP is free to use or not. So that's the first thing, team. Okay. So once that task is done, what is my next step? So once the task is done, what you need to do, you need to install NGINX into the AKS. Okay, into the AKS. This is what the next step you need to do. So once you refer this one, once you use the NGINX into the AKS, so I told you already, since you are checking internal IP, it will become an internal NGINX controller. Internal NGINX. That's an interesting fact, team. So it will become as an internal NGINX. Awesome. So once it becomes as an internal NGINX, now what is exactly your goal here is, so now you are going there, you are simply installing NGINX into the virtual machine, into the Kubernetes cluster. Then your NGINX become as an internal NGINX. Okay. So once you install the internal NGINX, next my goal here is you need to set up an ingress for that. So you need to set up an ingress. Okay. How exactly you need to set up an ingress is the one next we need to think about. But what exactly I am recommending for you, before going and setting up an ingress, please create a private DNS zone. Private DNS zone creation. I will tell you why we need to create a private DNS zone. It's a very interesting explanation also, you will understand. So especially, team, when you got the HTTPS request on the application gateway is acting as a SSL offloader also, meaning that if you are coming up with HTTPS traffic, application gateway, what it can do, it can convert your HTTPS to HTTP also. That capability is there for the application gateway. So when it is doing SSL offloading, meaning that HTTPS traffic converted to HTTP, you are not really interested to handle again HTTP here. You know what will happen? It is already handling SSL offloading here. If you again handle SSL offload here, it will waste of time. It will create a waste of time for you. Again, it will impact your latency also. So the interesting fact here is, especially in the internal NGINX, because it's already internal, you don't need to consider really HTTPS traffic here. You can proceed with the HTTP traffic. That's more than enough thing. That's what exactly I'm telling. Here HTTPS traffic, which converts HTTPS to HTTP. Here only HTTP traffic. That's the only difference I'm trying to highlight. Okay. So this is acting as a SSL offloader also, and this is handling only HTTP traffic only. Please understand. Okay. So private DNS zone creation. Why we are creating a private DNS zone? Once you create a private DNS zone, what exactly we are going to do? You'll add a record of NGINX internal and NGINX address to the domain. I'm going to create one domain here, team, which is called tracker UAT dot cloud learning dot link. Okay, Link. You know one thing? So cloud learning dot link is the domain which I am already holding. I have this domain. I am the owner of this domain, cloud learning dot link. I'm just creating one private DNS zone for my domain. It's a private DNS zone which is only limited to you. Okay, only limited to your virtual network. Okay, no one can see this one. Okay, please understand. So once you are done with this thing, team, so you added a record. That's awesome. So private DNS zone created, you added a record. So your task is done. Now we are going to submit our internal ingress. Okay, you need to submit your internal ingress. Okay, what is your internal ingress, team? So submit the internal ingress to ingress resource. Okay, resource to AKS. Okay, I'm submitting the internal ingress to submit to AKS. So now you know what will happen. So when you form this one, you submitted the routing rules. That's what exactly you submitted at the moment. So once you submitted with the routing rules, next we are very much, this is what exactly you need to think about your internal NGINX team. That's awesome. Okay.
Thank you for the session. See you in the next part. Welcome back, team.
Okay, fine then. So in our last session, we understand about the NGINX architecture, right? So that was the part exactly we started with. If you notice, what exactly the changes we brought up here. So especially application gateway is connecting to the NGINX Ingress controller. But before that one, we discussed on how to connect with the application gateway, how exactly application gateway is connecting with the application gateway Ingress controller. Now, on top of it, we just brought the NGINX Ingress. Now, we should understand more on how exactly the routing can be formed in the NGINX. Okay, that is the important thing which we need to see. And also, before going for that, I listed few steps for you, so that I think we can take a quick look on that. So first and foremost thing, team, first we need to double check, is there any IP addresses available? Why we need to look for the IP address? The reason is, team, if you notice NGINX is an ingress controller which is sitting inside a virtual network. So if it is sitting inside the virtual network, so we need to make sure there is some private IP is being reserved for that. If you don't reserve, also not an issue, it will take a random ID. So instead, if you keep some reserved ID, that is really good benefit for you to just make sure, okay, that is exactly the IP this particular project A will refer. So that one will be definitely useful when you want to refer any other cases. Okay. So the best case here is, let's go there and find out the internal IP. If you don't find, also not an issue. Again, I'm telling. And then we need to install the NGINX into the AKS cluster. So again, another point you should understand here, whenever you're installing the NGINX, you should install the NGINX usually to specific namespace. Point to be remember, if NGINX is installed to the specific namespace, your service, your pod, your deployments, your secrets, each and everything needs to be deployed in the same namespace. Please understand. Okay. So what exactly the scenario we are simulating here? NGINX is deployed to one namespace where corresponding Kubernetes resources are also in the same namespace. So that was the concept exactly we are discussing. Okay, so now my point is, team, so once you are here, so now what exactly the point here is, so we installed the NGINX, then we need to create a private DNS zone. Now another question, why we need a private DNS zone? Why can't we go with just an IP address? Okay. So I want to show you how exactly the host-based routing is possible in NGINX. Okay, we have seen path-based routing in application gateway ingress controller. Now similar ingress controller we took as an NGINX. Now we are going to see how we can make a routing based upon the host. So that's the point exactly we are saying here. Okay, that's why you need to create some host. What is this? So this host is private DNS zone. Private DNS zone is always limited to only virtual network. The communication or the type, that particular DNS name will be resolved only within the virtual network team. Please understand. It will not resolve outside. Only within the virtual network only it will be resolved to an IP. Okay. Please understand that. Okay. Fine. And finally, you need to add a record, especially add a record of NGINX address to the domain, which is the track UAT. So I'm just taking one example for you. This is the private DNS zone domain. This is cloud learning internal .link is the domain. Okay. This is the domain. And for this domain, tracker UAT is a subdomain. Okay. Subdomain. So this is exactly the private DNS zone which I am creating, so that I think we will play with the same thing. And finally, submit the internal ingress resource to AKS. Okay, fine. So especially once you are ready with once you are ready with these things, okay. So once you are ready with these things, I believe. So what exactly the point here is? You just need to submit the internal ingress resource so that your Kubernetes cluster understand how routing can happen. So that is exactly the things which we need to take a look now. Okay. All right. Let me open the Visual Studio Code so that I think we can start connecting with the Kubernetes cluster. Okay, all right. I'm in the Studio Code already. Okay. So now first point what you need to think about here is, okay. So basically you know few things already. First and foremost thing, what exactly the point we discussed? We just discussed. We need to understand, is there any IP address which is available for free, so that I think we can lock it. Okay. There is specially a command to just clear that one. So that's the command exactly I listed also. Okay, you can refer this one. Okay, I prepared the actual command also for you. So this is the prepared command. Okay, prepared command. So meaning that what exactly we are doing here is, let me explain the command. AZ network, a virtual network. Okay, so there we are checking an IP address. The virtual network name is project vnet AZ and resource group is AZ-RC, and IP address is specifically we are checking whether this IP is free or not. I'm taking one more IP, I'm pressing enter. So the moment when type enter, it will double check whether this IP is free or not in this particular subnet. If it is free, I'm going to use that. See, available true. Available true means I can use that. That's awesome. Okay, that's awesome. Okay, right. Let me go back to our steps. So what are the steps we prepared? Okay, let's go back to our steps team. All right. So once you have your internal IP ready, there I'm going and I'm just installing internal ingress into your Kubernetes cluster. This is exactly the command which you need to proceed. Okay, so especially this particular command is talking about one thing. Please understand. So you are trying to install the internal NGINX specific to a namespace called ingress-basics. Let me double check. Do we have this namespace already? So kubectl get ns. Okay, I don't see namespace. Okay, that's awesome. So now what you can do, if you read this particular installation command, somewhere you will invoke your internal IP also. See, there is service.load balancer IP which you are passing as 10.120.0.22 or something like that you are passing, right? So that is exactly the thing you need to understand here. So you're passing an IP address, whatever you just see it's available. For example, 221 is available. So that is exactly the IP which you just noticed. So I'm just using the same IP address. I'm just filling the command. That's all you need to fill. You just copy this particular entire installation. Okay, entire installation, and go back to the VM. Okay, just come here, just clear the screen and just paste over there. So just the moment when you paste, okay, that's all you need to do. Press enter. So this is what exactly the Helm chart will be installed into your Kubernetes cluster. What Helm chart means, it consisting of all required resources, especially for the Ingress service, Ingress parts, Ingress controller, whatever the things are really required for Ingress, everything will be deployed. So now once this is done, team. Okay, so now what exactly we need to do here is, so once your Ingress stuff is installed into your Kubernetes cluster, so you can understand also what all the things got installed. kubectl get all, okay, get all -n ingress -basic. Okay, if you apply this particular thing, you can see all the resources which got installed into your Kubernetes cluster with respect to your Ingress. Okay, these are all the things got installed. Okay, you don't need to by heart anything. You no need actually. So whatever the installation is done, just keep that one with you. All right. So once this is done, team, I told you already, so your Kubernetes installation is awesome. So that is cleared out. Now what exactly you need to do? So let's go there and refer the documentation, team. Okay, if you refer the documentation, say NGINX is installed, that's clear. Then private DNS zone creation. So this is what exactly we need to proceed. You go back to the Azure portal, then come here. So there you can create a private DNS zone. I'm just creating on private DNS zone. Okay. Okay, and just go for the private DNS zone. Especially when creating a private DNS zone, I'm just clicking on the create button here. And for example, oh, come on. Why is still disabled? Just a second there. I'm thinking everything is alright actually. See, I think everything is started, right? Now why it is showing as disabled? It's active actually. Okay, I don't see any issue. Just a second, team. Just a second. Okay. All right. I think it's a normal. I think it's just an environment issue because we just seen that and now it's not there. Okay. All right. So just go there because you just go for the AJ-OZ. So this is the resource group I'm just considering them, especially for you. Okay. Okay. I'm very sorry, Tim. I'm very sorry. Actually, I got a call from hospital. That's why. Sorry. Okay, all right, team. So fine. So once you are here, team. So what exactly the thing we need to think about here is so whatever the private DNS zone I'm talking about, please copy this one. Please copy this one, team. So this is what exactly cloud learning internal dot link is your domain. That is what your internal domain. Please copy that and paste over there. That's what exactly you need to do. Don't copy your subdomain. That is not required. Later you will create the subdomain. So once you are done, just go ahead and finally click on create. So you created a private DNS zone. Simple. Once this private DNS zone created, what is our next step, team? Our next step here is add a record of NGINX Ingress to the domain trackeruat.cloudlearning.link. Okay. So now what you need to do, you need to create a link now. So how exactly we are creating this particular record? So if you go to your Kubernetes cluster, kubectl get ingress team. Okay. So for example, when you apply the command, so whatever the list you are seeing, this is application gateway ingress controller. Hope you remember this one. This is application gateway ingress controller. You remember, right, Tim? This is what exactly we wrote. So for application gateway, but I don't require this one. I require the ingress which we applied also, right? That is what exactly. So for example, we just deployed ingress, right, Tim? So just a moment. Sorry, kubectl. Ingress hyphen here. Hyphen n I'm just taking the ingress hyphen basic. Okay. Sorry, yeah. Just deployed the ingress into the same resource group. So that's what exactly my idea. Just give me a moment, okay? Sorry, yeah. I'm very sorry. I think you need to look not for that. You just need to look for the service, okay? kubectl get svc hyphen n ingress hyphen basic team, okay? You should look for the service team, okay? That load balancer is required for you, okay? This is ingress load balancer. You need to look for this. Okay, when you come to the ingress load balancer and NGINX ingress controller, external 10.140.0221. This is the IP exactly I'm talking about, team. Okay, copy this IP and go back to your private DNS zone, whatever you just created. So once you're here, I need to create a record set here. Okay, I need to create a record set. Click on the record set. And by the way, so once you're here, what exactly we need to think about here is, so whatever the IP address you are saying, just close this particular thing. Okay, 10.140.0221. Okay, this one I'm just keeping this one. And specially, whatever the domain you want to see, that domain name you need to use here. Okay, you can give anything, some ABC, XYZ also. So, but actually, what I said, we are planning an application in the UAT environment. So that's why I'm just giving some application name followed by environment. Okay, that's the format I'm following. trackeruat.cloudlearninginternal.link. Okay, that's the thing exactly I created. And click on OK, sir. So once you click on OK, so now what will happen here is, you have created a record. That's awesome. So meaning that what you achieved, I will tell. So if you come here, if you come to the virtual network, this is what your virtual network. Inside virtual network, if you give nslookup trackeruat.cloudlearning.link, cloud-learning-internal.link, it will be resolved to an IP. But when you go outside of the virtual network, maybe you sit somewhere here, another virtual network. If you give nslookup trackeruat.cloudlearning-internal.link, it will not be resolved. That is the exact importance of private DNS. Private DNS is limited to only your virtual network, but it can be extended also. But you need to add the virtual network link. Hope you remember that one. We added VNet link in one of our previous scenarios. So that case you need to solve that one. Okay. All right. For now, you no need to do or you no need to worry about that one. So this is awesome so far. Then you need to submit the internal ingress resource route to the A case. Let's go there and assess this case. If you understand, team, so I have an ingress ready. Okay, everything I prepared already for you. So this is what exactly the ingress resource we are talking about. So if you notice one thing, team, I want to differentiate, especially in this particular case. For example, Okay, so this is what exactly you are seeing for the NGINX. Okay, NGINX. A very important thing, what exactly you need to keep in your mind is only 2 points. Okay, point number 1, which namespace you are deploying this one. That is very important. Point number 2, what exactly your Ingress class name. This Ingress class name is also very, very important. Okay, for example, you can have multiple Ingress controllers in the same namespace. Multiple Ingress controllers are still possible. But how it will be differentiated by using Ingress class name only. You may get doubt where exactly we got this Ingress class name. The Ingress class name is came from here only. See, whatever the Ingress class name specially, if you use whatever the things, this is what exactly the default thing we just deployed. Okay, default thing we deploy. If you go with the default one, it will simply tell your Ingress class name is NGINX. If you want to override, you need to use --set. You need to override with the relevant parameter. Okay. So that is what the override exactly we need to do. But you don't need to think about it. You just ignore that now. So for now, I'm just going with NGINX default one, whatever is available, whatever we install. That's the default name. That's awesome. I'm setting a rule. Hey, if a traffic comes with trackeruat.cloudlearning_internal.link, if traffic comes with this, you should route the traffic to the service middleware and also path also middleware. So meaning that if the traffic comes trackeruat.cloudlearning_internal.link, if traffic comes like this, so you are routing your traffic and you are forwarding that traffic to this service. That's what exactly you are doing. Okay, that's what exactly you are doing. So now my point here is, this is very easy. So whatever you understand, especially in your NGINX case, okay, in AGIC case, this is what your AGIC case team. Okay, let me compare these two so that you will get an idea. So the right side one is the AGIC, which is a application gateway Ingress controller. The left side one is the Ingress one team. So if you see this one, okay, if you see this one, this is what exactly the tracker UAT. Sorry, this is what exactly the tracker UAT. Tracker UAT. See, this is the domain. It matches with the domain. If it matches with the domain, you are routing the traffic to the service called middleware. Simple. It matches with the domain, and also if the path name is /middleware, then only traffic is going. But it's here, if it is a /middleware, directly you are going to the service. That's a difference team. Okay, this is path based routing. This is what the host based routing. Okay, you need to understand this. Okay, all right. So once you are done with this particular process, now what is my goal here is, my goal, I need to submit this one to Kubernetes. So to submit this one to the Kubernetes, kubectl apply -f. I'm just dragging this one here. That's all. If you submit this Ingress, that's all you did. So now you just go there, kubectl get Ingress. Okay. If you try to get the Ingress, for example, this is the default one. If you go for the -a, it will list you the another one also. That's an interesting fact here. See, when you apply the -a, you are seeing an internal domain corresponding to an IP address. That's an interesting fact. See, from now onwards, if you want to play, you can simply take this domain name and you can play. What exactly I'm telling, I'm within the virtual network, right? NS lookup, I'm just giving NS lookup, I'm just giving this particular host name, okay? You just copy the host name, just enter. See, for example, in some cases, now it is not resolving. Hey, you don't get any fear here. It is not resolving within the same network also. My VM also sitting here. My VM also sitting in the same way Kubernetes cluster is sitting. Then why it is not resolving? It should resolve, no? This is a Kubernetes cluster. Our VM is also sitting here only, team. Okay. If you go to the VM here, okay, just copy the VM virtual machine. I'm just bringing this particular VM here. Okay, keep the VM here. So now that is what the point exactly I mentioned, right? If your VM belongs to the same virtual network, your NS lookup of your private DNS must resolve, but it is not resolving. The reason is only one thing. You go to your private DNS zone. You need to add the record for the VM also. You need to add the record. So that is what missing here. Okay. If you add the record, definitely it will result in. Okay. That's only the missing part here. So now how to add a record? That's very simple. You go to the VM first. Okay. If you go to the VM, if you go to the VM, there you can see the VM IP. Okay. You just come here. So this is what AZVM is, your thing. Okay. Just take that particular AZVM. Especially, I'm just taking AZ-VM. I'm just using the same name and just click the record set. I just come here and just giving the same name. Especially to the IP address, you need to give the IP address, whatever the private IP which you have, right? So this is the IP address exactly you need to give so that it will be resolved to that. Okay, it will be resolved to that. For example, I'm just giving, okay, this is a private DNS zone means only private IP address only you will give, okay. So just click OK. So now it will start resolving. Because you informed private DNS zone, please understand about this VM also. So then what will happen, you know, so just after a few seconds, if you try to apply the same thing, I think it will be sorted out, okay. Just you need to wait for a few seconds, team, okay, it will be work out. So let's just double check this one after a few seconds, not an issue. So alright team, so you deployed Ingress, that's awesome. You deployed everything. Everything is good now. Now, so far, let's go there and assess the architecture one more time. If you refer the architecture team, so this is what exactly you sorted out. But I want to double check one more thing, where the service, pod deployment, secret, all those things got deployed in the same namespace or not. That is my next challenge thing. Okay, to do that, you just go back to your resources. Here, exactly your resources I prepared. For example, if you go to the deployment YAML, this is what your deployment YAML, right team? So in this deployment YAML, I already added a namespace as Ingress Basic. Awesome. Okay, fine. So that is awesome. So you already added that one. So the next one, I'm just going for the service YAML. Service YAML also I added the namespace as Ingress Basic. That is also good. Next one is the secret YAML, right? So there is one more called secret YAML. So even secret YAML also, you just need to make sure Ingress Basic only. That's really awesome. Everything is good. Now what you need to do, kubectl apply -f, okay. I'm just bringing this particular thing. So especially, I'm just applying one by one team here, okay, one by one. So for example, deployment.yaml, okay. Deployment.yaml. So that is the first thing I'm just applying. This is what the deployment.yaml. So I believe this is the correct one only. Yes, okay. Deployment.yaml, just apply. Okay, awesome. I applied the deployment.yaml. I kubectl apply -f. You just take the SVC YAML. So that is the one. Is another one is that. So first pod deployment, another one is SVC deployment. So once these things are clear, next I'm just going for the secret. Okay, secret -f. Okay, secret YAML. So the secret YAML. Okay, secret YAML is the one exactly. I'm just stopping it. So I believe something wrong in the secret YAML. Okay, let me read this one. Secret YAML, right? Oh, sorry. I think some nonsense being placed here. Sorry. I believe this was the secret exactly. Okay, sorry. There is an interesting. Okay, I'm just clearing this one. Okay, all right. So once you just come here, I'm just placing this one more time. Okay? Everything is awesome. Okay. kubectl get po -n ingress -basic. Okay, that's the thing exactly you need to take it out. So for example, team. Now once you are here, it is telling some image pull back off. Image pull back off usually will come if there is a problem with the container registry. Okay, let me double check with any problem with the container registry team. Okay, so for example, I believe, okay, so fine. So for example, what exactly the thing I'm just thinking here is, let me go there and refer what exactly your container registry. Okay, I'm just creating one dummy shell script here. Okay, which is for our playing purpose. Okay, this is what exactly you need to refer. You need to prepare your command also. I believe something is wrong here. Just a second, team. So here, this is our project, right? Main project. I'm just referring what exactly our container registry name. Okay, so here you must keep that particular thing. Is it? I believe it is going for. I'm thinking we have developed our. We have pushed our image from here only. That's what exactly the thing I do recall. So just a second. 1 second, please. 1 second. Just give me 1 second, please. Sorry, deployment YAML. I think this is the one. Sorry, I believe this is what your ACR team. Okay, project ACR 23. Okay, this is what this must be there. If it is not there, I think that's a problem exactly coming for you now. Okay, you just go there. You just go there. You just go back to your portal. There I can see container registry. So you just go for the container registry team. Okay. If you go for the container registries, okay, this is what your container registry, no? Okay, I think that is the missing part. Okay, let me do one small thing. I'm just creating the container registry now very quickly. I'll push an image quickly. Okay, so I think I'm just going for the AZRZ. So AZRZ is the one. I'm just taking the same name so that you don't need to modify anything on the deployment. Okay, I'm just keeping the same thing. I'm just going for the networking, encryption, review and create. Finally click create. Okay, you are creating a container registry. Okay, at the moment. Alright, so once this is being created, I think what exactly the pending parts, you need to push your image to container registry. So that is also you need to do. So you need to build the Docker file. You need to build the Docker file. Okay, to build the Docker file, I'm just going there. You just go here. Okay, you just go here. I'm just going here, team. Okay, so firstly, what you need to do, so especially this is what your main project, right? I'm just going to the main project. Okay, because we did this one by using our raw approach only, right? So that's, I'm just going there. I'm just going here. So here is the one exactly the Docker file you are seeing, right? Okay, so now what you need to do, so you just need to build the Docker file. If you build the Docker file, I believe that's exactly the thing. You need to push this particular Docker file to the same registry. Okay, let's wait for a few seconds to that particular, particularly ACR to be ready. Okay, just wait for a few seconds then. Okay, let me see. Okay, yeah, I think it's good. Okay, so now you need to go to the virtual machine. Again, I'm doing sudo docker build team. Okay, sudo docker build -t. Okay, so that's the thing exactly you need to go, and followed by you need to give some name. Okay, Spring Boot or something like that. I'm just giving some Spring Boot. Maybe you can give the whenever you are just building up. I think it's always good practice. I think if you give this particular ID as the one of the tagging. Okay, it's not tagging actually, it's image name only. Okay, just give this one. So once you are done, I believe if you want to define, you can define the tag name also with the colon. Okay, that's your call. Okay, just give the dot. Okay, just press enter. Let it build. I think it will build very fastly only because I think we did the same thing under this particular VM earlier. Okay, see, I think it's built the project already. So it's it built the image already. Okay, so once it's built this one. So let me docker images. Okay, docker image, sudo docker images. Okay, that's the thing exactly you need to look for. So I believe if you look for, I believe there I can see something called yeah, I believe I'm seeing something. Okay, so I'm seeing something here, some ID project ACR slash Spring Boot. I think that's exactly the name we have given just now. That's awesome. All right, team. So once you are here, I believe I just need to modify. I'm just changing the tag also with respect to your just to align on the naming convention. The reason for that one is, team, whenever you are pushing, first it will check what exactly your login server. Okay, what exactly your login server. So that is the difference exactly I'm noticing now. I believe if you notice your previous images and this image, I think there is some difference. I think I do notice. Okay, so especially what exactly you need to do. So you just need to modify that one with respect to the tag. Okay, that is exactly the thing you need to do. Okay, all right. So now what exactly you need to do. So you can write another command. You know the command already. Okay, sudo. Sorry, let list down the images one more time. Sudo docker images. Okay. Okay, so this is what exactly you have used just now, right? So provide ACR / Spring Boot. Okay, so now I'm just writing another command. Sudo docker tag. Okay, tag. So what exactly the tagging you are giving? Just copy this one. You don't want to see like this, right? I'm just taking this particular thing. That's tagging. I'm just changing to some existing ones, but I will change a little bit. Don't worry. Okay, so not with the same. I think you can use the same thing also. Let me double check. I think that's the correct one also you are using in the deployment. That's awesome. You can use the same thing. Okay, so that is the thing exactly you just need to keep. So sudo docker tag current image and the future image name. Okay, that's exactly the thing. Just press enter. That's it. Now I think what are the image you just brought up? I think yeah, sudo docker. I believe Azure to the Azure CI docker Spring Boot. This makes sense. Okay, this is what exactly the same tagging you made again. So now you need to make a push. Okay, sudo docker push. Okay, so I believe you need to log in first. Okay, you need to log in. Okay, otherwise it will not proceed. Okay, to log in, sudo ACR login. Correct. So that's the command exactly you need to do. And -- name. So you need to give the name of your container registry also. So if you come to the name of the container registry, so you just come here. I'm just giving this particular name. You just give this particular login -name. So that's the thing exactly is asking the username. So especially just a moment, just a moment. Okay. So now you go back to your Chrome, and here I'm just bringing and referring our access keys. You know very well that you need to enable the admin user. Okay, just enable it. Just copy this username and registry name. That's your registry name. Just give that registry name. Press enter. It lasts the password. I believe. Just go to the Chrome browser one more time. Copy the password, access key. Okay, and just come back here and just paste over there and just press enter. Sorry, yeah. I think I placed it wrongly. I placed wrongly. Maybe just a second. Okay, I'm just copying the name one more time. So you just come here. Okay, just paste over there, and password is there. Okay, you just come here, team, one more time. I'm just copying very clearly. Okay, I just come here, just cursor press. Okay, just press enter. Okay, press. Oh, come on. Just a second. what exactly the problem I'm making here. Okay, am I pasting correctly or not? Enable the AD authorization token with the message, please run the AG login to set up the account. Unable to get the admin credentials. I don't think so. That is really required. That's a warning only. Just a second, team. Okay, just a second. I'm just giving the name one more time. That's exactly the name. I believe. Let me double check one more thing. What are the things I'm copying? Okay. Otherwise, I'll regenerate. You can regenerate also. Copy this one. I'm just going to the Visual Studio Code, and at the bottom I'm just we prepared one gg.sh only for the dummy thing or for just our player, just pasting the commands. I think it's pasting really well. I don't see any issue also. Oh. Okay, let me do one thing. Let me do unauthorized authentication required. Okay, I believe they are just asking me to log in first. Okay, I'm just doing the easy login, team. Okay, they're asking me to log in. No choice. Okay. Sorry, I think the browser got opened in another window. Sorry, I think that too it is saying I think it's not working. I'm just copying the another recommended command. Okay, let's try to use this one. Okay, so when you use this one, I believe you just copy this one and you just open the browser one. Okay, sorry team, I think I can show you that one here. I don't know, I think it's not opening here. Okay, let me do the same thing here. Okay, so that you will get an idea. Okay, for example, what exactly said this one exactly. Okay, they're asking the key. Just pass the key and just say you're logged in. Okay, you're logged in. Okay, all right. Okay, I believe that's the problem exactly you're getting. Okay, just go back. So JSON response came. Now you try to log in now. Okay, now you try to log in. Okay, this is what exactly you're trying this time. Okay, especially the same as the login, so no doubt. Just press enter and asking the password, and I took the password already, right? Just copy this password, just paste over there. Awesome, fantastic. Okay, you already logged in. That's really good. Now what you need to do, you need to push. Simple, you need to push sudo docker push. What exactly you need to push? You need to give your image name very clearly. Okay, very clearly you need to give. So to give that image name, I believe you need to list that one. So sudo docker images. Okay, I'm just getting the list. Okay, and especially you just copy this one. Okay, sudo docker push. Okay, I'm just giving this particular name. Okay, colon. So I'm just giving some relevant name also here, Tim. Okay, or something like if you want to give latest tag, you can give. If you don't give the latest also, it will pick the same thing. It will push it. Okay, awesome, Tim. So that's the problem actually, since ACR got deleted, I think because of our account issue. That's why I think we need to build and we need to push it again. All right, that's awesome, team. Everything good. Now what do you need to do? Simple activity you need to do. One small activity I will tell, and especially one interesting fact also. You remember ACR secret is the one which you need to deploy. You should not forget this, okay? Because your ACR is new now, okay? So you need to deploy the ACR secret also. When you want to deploy the ACR secret, please copy the names as it is. Okay, I will tell what exactly you need to do. Copy the ACR name, especially this is the name. Okay, containerization name. This is the containerization name I pasted, and the secret name is ACR-secret. That's one you know already because that is exactly the name we are using in the deployment YAML. Okay, to make you very clear, I think you can click on the deployment YAML. Sorry, you can go to the deployment YAML. I can show you. Okay, see. You are using ACR-secret, so you need to use the same name here also. All right. So once your thing is done, okay, I'm just going here. Okay. So once this thing is done, then I'm just going for the namespace. Okay. What is the namespace exactly you need to see? You need to see Ingress-basic. Okay. That's a thing exactly you should follow, team. Okay. Don't miss this one. Okay. Just do the same thing. Okay. You need to keep everything inside the same namespace. Okay. I'm just keeping everything already, username and the password again. Okay. Again, username is the same thing only, so I'm just giving the login ID as the username. Okay, just give that one, and especially the password is the one exactly the below one which we already copied. Okay, copy this one and just copy and just cut that one also. They're not really required for that. Okay, just pasting over there. Awesome, team. Just you prepared this particular command. You just copy this command and just go back and just paste over there and just hit enter. That's it. Okay, no such failure director. Just a moment. I think no, I think it's typo. Sorry, it's a typo, team. Okay, just remove this one. Okay. Alright, so it's remove this one. I believe it should be fine this time. Okay, let's try one more time. Okay, so press enter, team. Just a moment. Service a pass. No. Oh, so here also. Sorry, it's my bad. I placed unnecessary things here. Okay, I believe it should be fine this time. I don't see any other new things. Okay, alright. So fine. Just copy this one. Okay, just come here, paste over there, press enter. Okay, created team. Okay, secret created. Once a secret got created, what you need to do, So the next important thing here is team. So ACR secret created. That's awesome. So now interesting fact here is once the secret got created, now this is the time for you to just double check your deployment. Okay, kubectl get deployment. If you go for the deployment, you know very well. Okay, your namespace is different. Okay, ingress -basic. Okay, you need to give that one too. So there is a middleware. Okay, I'm deleting the deployment. Okay, kubectl delete deployment. Okay, deployment. I'm just deleting the deployment which is sitting in the namespace. Every time you need to give the namespace. Okay, otherwise it will not identify. It will refer only default only. If you delete that one, just have another idea. kubectl apply -n. Now I'm submitting again. Okay, where is the deployment YAML? Deployment YAML. Okay, I'm submitting now. I think this time it should be good. Okay, that's what exactly I'm also looking for. The kubectl get po -n ingress -basic. Okay, now we double check. I think error image pull. I believe usually it will come because of some authentication or authorization issue. Okay, so let me double check that one also. kubectl describe po. So this is what exactly you're getting, right? Copy this one and just paste over there. -n ingress -specific ingress. This is common team. Okay, you need to pass that. No choice actually for you. I believe you just deployed your secret. I don't think so any issue for you also. Sorry, yeah, because you just deployed, right? Failed to resolve. I think project ACR 23 Docker Spring Boot latest failed to authorize, failed to fetch anonymous token. 401 unauthorized. Actually, you deployed. I believe you deployed already the ACR secret. Okay, let me double check also. kubectl get secret. Okay, get secret -n ingress -basic. Okay, I'm just double checking the secret. Okay, there is ACR secret. Okay, which has been deployed 2 minutes 8 seconds. That's awesome actually. I believe everything is place. Everything in place. Maybe we will try for kubectl get po. We will try for one more time. Okay, get po -n ingress -basic. Okay, I'm just double checking one more time. Error image pull on it. No worries. Okay, kubectl delete po. I'm just taking one part delete. Okay, so when you delete automatically it will comes up. Okay, let me double check one more time. Okay, I believe it is showing the same thing as error image pull only. Okay, just a moment. What you deleted? Oh, LNL, right? I think it is still coming. Is it get deleted really? No, it has not deleted. Okay, sorry. So when you deleting team, see again you have not given the namespace. Okay, so that's a problem. It's not deleted. So if you see this one, see it's not found. It came. Okay, so it's your deletion was not successful. Just press enter one more time. Now you are deleting the part. Now you try one more time. So I'm just double checking. I think image pull backup is still there, but it's a. I believe I gave the fix already for this earlier, but that's exactly the thing we are trying because of it got deleted. Okay, that's the problem exactly raised. Okay, I'm just double checking the password. Whatever the password we copied, is it correctly placed or not? Okay, that's the doubt. First thing we need to sort it out. I believe if you notice this one, sorry, there is a problem here. The secret is S, starts with S. Okay, but you placed PAZ. Okay, that's a problem, team. Okay. So I believe you have not pasted the secret well. I think that is the thing exactly caused this issue. Okay, I'm just applying one more time the secret team. Already exist. Okay, so very good. Okay, whenever you see these kind of issues, you just delete that particular thing. Okay, kubectl delete secret. Okay, ACR -secret. Okay, -n ingress -basic. Okay, you just need to come here and just delete this one. Okay, so once you delete this case team, awesome, everything is fantastic now. So you created everything. Now please apply one more time. Okay, excellent. Okay, now it got created. Now I believe if you delete your parts, I think definitely those things will work. Okay, kubectl delete po. Okay, I'm just bringing up the po team. So this is exactly the part. Okay, I'm just copying the part. Sorry, I'm just copying both the parts. Okay, which are not really required at the moment. I'm deleting this. Let those two things come automatically. Okay. Okay, I believe. Just a second. I believe. So whenever you are deleting again, your delete was not success. The reason is I think you have not applied your namespace. Okay. Ingress -basic. Okay. Just apply. Okay. All right. Fantastic. So your parts got deleted. So once your parts got deleted, I believe Now I believe what exactly you need. Double check the pods one more time. Excellent. Your pods are running. Okay. Now so far good. Excellent. So far good. So now what exactly we achieved? Let me give a recap. So in this architecture, so firstly you install the NGINX, completely install, and once it is get installed in the Ingress-basic, you make sure your pod, your secret, your SVC, everything got deployed into the same namespace. That's what exactly you achieved. And you gave the connection as whenever the traffic comes from application gateway, it should come with a domain name, not with an IP address. That's the expectation you have. If it comes with the domain name, then only my Ingress will resolve that. That's a point, team. Okay, all right. So once you are here, now what I need to do? Now I'm just going back, team. Okay, all right. So far, excellent. So now I'm just going back. Now what I need to do? I need to create an application gateway. That is pending now, team. Okay, I need to create an application gateway. So now once you are here, now my job here is, let me give a point. I need to create application gateway. I need to connect the NGINX Ingress to that. Then your task is completed. That is what exactly we need to make sure end-to-end Ingress is working or not. Okay. Okay.
Thank you for the session. See you in the next part. Welcome back, team.
Okay. So in this particular session, we'll understand more on how exactly we need to request for the SSL TLS certificate from the well-known cert authority. Okay, how to request. I'm just keeping the title. Okay, SSL cert TLS cert from a well-known CA. So this is the thing exactly we should understand him. So the case here is, so whenever you're saying this cert generation by using a well-known CA, so we need to understand on the process. So what exactly the process we need to follow, that is very, very important. Okay, that is very, very important. So let's understand the process first, so that I believe we can make sure how to generate the certs in the real time also. Okay, all right. So step number one, the first and foremost thing, for example, here you are sitting here. Okay, you are sitting here and you are owning a domain. For example, I'm owning a domain like cloud learning. This domain is ours, right? The cloud learning.link is our domain. Okay, cloud learning.link. For example, I'm just make sure cloud learning.link. This is our domain exactly. So this domain we purchase. You can purchase this one from anywhere. You can buy this one from Amazon services, or you can buy this one from GoDaddy, or you can buy from any third party. Doesn't matter. The domain purchase is very straightforward. You will go there, you will select the domain, you will buy it. You will pay and you will buy it. Okay, clear. That's all. But the next one is, you need to get a certificate for the domain. That is the next thing which we need to take care. Okay. For example, at the moment you are just holding just I'm just giving the name here. Okay, cloud learning.link. Okay, learning.link. Okay, for example, let's consider this one. So now when you see this one team, when you see the cloud learning.link, so as a user, what we need to do, we need to make sure we are getting a certificate with respect to this domain. To do that, firstly what you need to do, you need to generate a key first. Okay, you need to generate a key. So I'm just going here, just generate the key. This is the first step which you need to follow. Okay, generate the key. Once you generate the key, next what you need to do, you need to use this particular private key to create a CSR. I'm just taking the next step. Okay, I'm just taking the next step. So this is the second step. These are the standard steps only, which you just remember. That's all. Okay, you don't need to behead anything. Use private key. Okay, so so here this key nothing but a private key only. Let me write it very clearly. So you need to generate the private key. Then you will use the private key. Okay, we will use the private key to create CSR. CSR. Okay, cert sign request. You will create that one by giving with the proper information. Okay, proper info. Okay, all right. So once this is done, now my next goal here is you will send this one to certificate authority. Whatever the CSR is generated, send the CSR to CA. Okay, so you send this one to CA. Once you shared with CA, now we will talk about little bit on the CA now. Okay, what exactly the CA, how exactly that looks like. For example, team, if you consider the certificate authority, right? So that one I'm just drawing a bit here. Okay, this is just assume this one will call as a root CA, root certificate authority. Okay. Now root CA has their own private key. Again, they have their own private key. I'm just keeping a private key. Again, their private key. Okay. This is their one. Okay, this is their one, and this is yours. Okay. Now once whatever the key they have, the root CA certificate authority, once you pass the CSR to them, right? What are the cert sign request? When you pass this particular CSR to CA, right? I'm just taking a box here. Yeah. I think it's too big. Okay, just wait a moment. That's too big. Yeah, this is enough. Okay. Yeah. So when you pass, especially the yeah. So just a moment. Okay, let me push this back. Okay. Oh, sorry. Yeah. All right. So when you pass the CSR, especially the CSR, to send the CSR to CA. Okay. When you pass this one to CA, okay, what exactly the things will happen here? So user CSR is the one which you need to consider also here, team. Okay, I'm just considering user CSR also. Okay, user CSR also. So I'm just taking a box, another box which is a user CSR. Okay, user CSR. So once you got the user CSR, okay, that is what exactly we passed. Okay, once we got this one, now what will happen here is what exactly the thing. Once we got everything here, now we root CA certificate authority will generate the certificate now, team. Okay, now it will generate a certificate. So it will generate the certificate. That is what exactly the generate the cert. Okay, SSL cert. Okay, and sign the cert with root CA and key. So that's the interesting fact here. See, if you notice the process here, team. Okay, if you notice the process very clearly, thoroughly here. So what exactly the changes we brought here? Okay, so if you go here, if you just make it big, okay, this is what exactly I'm talking about. So now the certificate authority generate the SSL cert, and that particular cert being signed by the CA by using the root key. So the root CA used your information and they signed this particular they signed the generated cert by using the root CA and the private key. Finally, the outcome of this particular thing is a certificate. Okay, simple. The outcome is a certificate. So once this is number 4. Okay, step number 4. I'm just giving step number 4. Step number 5, simple. Step number 5 is, okay, simply you will configure the cert for your domain. Okay, configure the cert for the domain. This is step number 5, team. That's all, team. Awesome. That's all you need to do. Okay, you don't need to do anything, team. That's it. But the point you should understand here is, team. So once you are here, okay. So once you are here, these are the steps, but you don't need to remember anything. To be frank, the reason for that one is this is not your job, especially. This is your regional infra job. Okay, you don't need to worry at all. Okay, You don't need to care. But they will directly give you the certificate, their certificate to you, but you should understand how this cert being generated. That is why I just explained this one in the steps, okay? So once you are done, team, now what exactly the thing I'm just focusing here is, this certificate you cannot generate at the moment. The reason is this is completely a paid one, okay? It's a paid one. Because if it is a paid SSL certificate, this is the process. But for our case, I mean, especially our case, what we can do, we cannot use the paid one. That's why I'm just moving to the self-signed. We can generate a free certificate also. I'm just generating a self-signed one, okay? Self-signed one. The how to generate the self-signed one. Now I'm just drawing that particular process also, okay? So just let me separate and give me the title so that your understanding would be good. Yeah. So especially here, team, I'm just taking, okay, self-signed cert, okay, self-signed cert. How to generate a self-signed cert, okay? Especially, team, even in this particular process also, the few things are exactly will match, so you don't need to worry at all, okay? So first and foremost thing, in case of self-signed one, especially what we lack of, there is something which is lack of completely. You know what is that? The root CA, what are the certificate authorities so far you played? Earlier it was an organization. In this case, you need to prepare this one. That is the first thing which you need to take care. Okay. User, I'm just giving the numbers so that I'll just remove the connection so that we'll play with the directions bit later. Okay. I'm removing these connections, okay? The firstly, what you need to make sure here, team, okay? Firstly, you just need to make sure, okay? Whatever the thing you're saying here, this is the certificate authority area. The certificate authority area, user needs to create this one, okay? User needs to create CA, okay? CA. And private key, okay, and private key. This is the first step which you need to make sure, okay, private key. We'll simulate this one, don't worry, okay. So this is the step number one. I'm just placing this is step number one. So once you got your root CA and the certificate, root CA, where is the private key? I think we missed the line for I'm just making sure this one is a private key, okay, or something like that. Okay. Okay, so I'm just keeping this one as a private key, team. Okay, private key. So fine. So once you have the root C and the private key with you, so that's fine. The next, what we need to do. So we also need to perform here. Okay, especially you know very well that this area, especially the certificate authority, what exactly it will do before generating the self-signed cert. Okay, self-signed cert. So what are the self-signed cert? So usually, to generate the self-signed cert, always user CSR is required. Always user CSR is required. Okay, user CSR is required. User CSR. With the user CSR only, they can generate the certificate, team. Okay, that's a point you should understand. Okay, now once you have the step number one ready, what exactly the thing we need to make sure? Now, as a user, you need to generate another private key. So same process, okay? Generate the private key. I'm just taking the step number two. Sorry, generate private key. Okay. Once you are done with this particular thing, now we will use the private key to create a CSR with the proper info. That is absolutely fine. No changes on that. Okay, no changes. That's okay. So once that is also done, then what is your CSR is ready. Once your CSR, you don't need to send to CA because CA is already with you. Okay, CA is already with you, team. So you don't need to send to somewhere. So now the sequence is, I'm just going here. This connection is not required. Sorry, this connection is not really needed. But we will generate this key and you will pass this one to this one. That's all, team. Okay. Now what you understand here, but this activity you did for the first, please understand. Okay. Please understand, you did this for the first. Okay. Here you are the user. You need to do this one. Two directions for you. You need to do this one and also you need to do this activity also. Okay? This activity also. Two things you need to do. Please understand. You should do these two. These two things together. Together means sequence is fine. First you will come here, then you will come here, then you will come here. Awesome. So once this is done, now this is the fourth step exactly. Okay, generating the certificate. Okay, generating the certificate by self-signed certificate. Okay, self-signed certificate and sign the certificate with the root CA and the key. That's a common thing only. So once that is done, team, so now what exactly you need to do? So you need to use this particular certificate. So now step number 4 I'm writing. Okay, use the certificate. What are the certificate being generated, right? So use the certificate for your application. That's all, team. Okay, use the cert with your app. Okay, with your app. Okay, so once this is done, now what we need to do, generally whenever you are using self-signed certificate in real time, it will ask you to just override. So when you give the self-signed one, so it will ask you to just telling you it's not so secure, you need to still proceed or something, it will ask you. Okay, so that is exactly the thing you need to do. So you need to so you as a user need to override the message. Okay, that's all you need to do, team. So if you could achieve this particular part, okay, what are the thing I'm just mentioning, that is more than enough, team. Okay, more than enough. Now we're going to simulate this one, we're going to prove this case also, don't worry. So now once you are done with the thing, these are the steps exactly you need to follow, team. Exactly. Okay, no changes at all. Exactly you should follow. And especially I'm just selecting this, I'm just selecting this area. So whatever the area you are seeing at the moment, I'm just selecting this area and I'm just selecting these things and coming to this arrange, just go there and just give some color, different color, so that I think your understanding would be good. Okay, all right. And also better, I think this would really make sense, but just a second, this is good actually. Okay, I'm just using this one. Okay, that's awesome too. Okay, that's excellent. So this is what exactly the self-signed certificate process, team. Okay, this is what exactly you need to do. Okay, just repeating one more time. So user need to create a CA and the private key. So this one and this one is compulsory. Okay, that's the first thing. And the next one here is then your actual user will generate a private key. User will use the private key to create a CSR with proper info. That CSR will be passed to this one. Then automatically CA will generate a certificate. That certificate we will use in our application. That's what user need to override the message. So this is our self-signed process, team. Once you are done with this particular thing, now what we need to do? So we need to proceed and implementing the process, right? That is what exactly we need to make sure. So to do that, what exactly the thing I'm just recommending for you, team? I think we have the script ready. I think we will simply use the script, or with that I think we can sort out our case easily, team. Okay, fine. Let's go to the virtual mission first. Okay, let's go to the portal. And let's start our virtual mission, and we will generate our certificate first, then we'll proceed. Okay. So I will share this script directly with you. You can use this script for your real-time cases whenever you want a self-signed certificate also. You just go for your VM. This is AZ VM. Just go and open that particular VM. Yeah, just start this VM. So what are the process we just discussed so far? The script will solve for you. Okay. The script will help you exactly what exactly you need to do. That one will take care. Okay, you don't need to do anything. Wait for a while. Okay, so fine, team. So once your VM is on, now going for the Visual Studio Code. Especially, I'm just closing the connections, all unnecessary connections. Just click on this arrow and just you go for the connect to the host. Just click this one. Sorry, you close the remote connection. That's not really needed for you. Take it out and followed by the double arrow pointing to this. Connect to the host. There you just go for this particular thing, team. So whatever the VM we are talking about, I believe this is the one of the VM. I think we can check and refer. Okay, I'm just passing the password to that. Okay, and coming to the benefits of self-signed certificate. Okay, maybe I will write few things here. So you will also have a very good understanding. Okay, a few benefits are also, what exactly the benefits you can think about in this case. The first and foremost thing, okay, no need to depend upon the third party. Okay, no need to depends on the third party CA, cert authority. Okay, third party CA. So usually, so that is the normal case. Okay, so you just overcome that one. Okay, but of course it's a free one. That's a difference. Okay, and you can create own CA. That's a interesting fact here, Tim. Okay, you can create a own CA. I'm just keeping own CA. So the next one, so you no need to pay anything to CA. No need to pay anything. Okay. And fourth one, you have full control on your certificate. Okay, because the key, whatever the key used to generate the cert, you know that. Okay, if you have full control on the cert, okay, these are the advantages too. But at the same time, we have few drawbacks also with self sign. You should understand that one also. So what are the drawbacks usually we will get? Okay, this is positives and this is negative. Another one is negative. Okay, I'm just taking the negatives also this side. So first and foremost thing, okay, sometimes we need to install the cert in the browser. So what it will do, sometimes when you are playing with a self-signed one, browser will ask you to install this particular certificate, so which we need to do it. Okay, and also we need to trust. Okay, we need to trust the CA manually, right? That is our job only. And also this is unsafe for public facing applications. Okay, apps. It's not so good for public facing apps. Okay, that is also one of the thing. Okay, and it's very prone to man in the middle. Okay, man in the middle attacks. So this is not safe when you consider the security, but okay for your environments. Okay, that is okay for your environment. So these are the advantages and these are the disadvantages with this particular certificate. Okay, all right, let's go for the VM team. Okay, awesome. So you got connected to the VM. Let me open the folder. So once you got open this particular folder team, so what exactly the things we need to do? So I believe the script ready in this particular VM. Okay, there is some section called ssl.sh. Okay, this is the exactly the script which is already prepared. You no need to do anything, no need. But whatever the things I explained so far, those commands only will be inside. So what exactly you don't need to understand also, not right. So what exactly we need to understand? Oh, for example, SSL.sh, right? That is like and here is cloud.link. You need to pass the domain as the attribute. Once you hit enter, or something happened. Now you can now if you notice, especially that things happen here. If you notice, there is one certificate .crt and .key. .crt, maybe I think a few things got placed already inside. Just a moment. Let me remove these things one time and let me try one more time so you understand. Okay, all right. So let me clear everything. I'm just preparing the scenarios. Nothing is there with you first. Okay, and you just have the script alone. Okay, just go there. Just enter it. That's all you do. If you notice what exactly the task root cert, especially the one of the thing which, and also the root source, which you can sense it, which you can think of. And also just a moment. Here you can see it has generated a certificate for you .crt. This is what exactly I'm talking about. This is the CSR. This is what exactly I'm talking about, the signed request information. And this is your key, is not a CSR, this is your key. So these are all the things are also got generated. Out of all these things, you need only this one. That's all, team. Okay, you don't require any other. Awesome.
Thank you for the session. See you in the next part.